Hello friends, I am Pradeep Yadav and I am about to discuss 8085 microprocessor complete course in a single video. And I will cover each important topic with brief explanation, and also I will present example wherever it is needed, and I will try to cover all the topic so you can easily crack your microprocessor examination by watching a single video. So without wasting our time, let me start. So first question is that what is microprocessor? So microprocessor is basically integrated circuit that contain all the function of a central processor unit of the computer. You can say that microprocessor is just a CPU. CPU means central processing unit. And microprocessor is a multi-purpose programmable logic device that reads binary information in form of 0 1. Whenever we are talking about binary, means we are talking about bit, and as we know bit are 0 and 1. So here microprocessor basically reads the binary instruction from a storage device that is called memory, accept binary data as input, and processor process according to that data and provide that result as output. So here your input is also stored in memory and your output is also stored in binary. Let me draw a simple diagram so you can easily understand how basically microprocessor works. Suppose this is a memory and this is CPU and this is output. Okay, so this is input. So what happened? Microprocessor take input from here, and this is basically memory. Okay, this is memory in form of 0 1. 0 1 means binary, and CPU process according to this input and give output, and that output is also stored in memory. Okay, here we have decoder. So basically the work of decoder is to decode this code and tell microprocessor you have to perform this operation according to the information. So this is basically a simple diagram. What happened? CPU reads information from input device that is called memory in form of binary. Decoder decode that instruction and tells or generate a signal to tell microprocessor you have to perform this operation. Then ALU of CPU perform operation according to that information and give output, and that output is also stored in memory. Okay, so this is basic definition of microprocessor. So a processor is brain of a computer which basically consists arithmetic and logic unit that is called ALU, and the main function of ALU is to perform arithmetic and logical operation in microprocessor. And register is a basically you can say storage device which is used to contain or store the information, and control unit, the main work of control unit to generate control signals, and that signals is carried by buses and tell microprocessor according to that signal microprocessor perform the operation. So as the name indicate, ALU perform all the arithmetic and logical operation on the data received from input device or memory. Register array consists of a series of registers like accumulator B, C, D, E, which acts as a temporary memory location for processing data. As the name indicate, control unit control the flow of instruction and data throughout the system. So basically this is basic definition of microprocessor. Now here this is block diagram of microprocessor. So here you can see this is input device and this is microprocessor, basically contain ALU, control unit, register array, and this is output device, and this is memory unit, means your input is also stored in memory, your output is also stored in memory, and your operation is also performed by using memory. So memory is everywhere. So this is basically a simple block diagram of microprocessor. ALU, arithmetic logic unit, control is just control all the operation within the microprocessor. Register is temporary storage device, is used to store temporary data for processing. Now important part of microprocessor, so we have control unit, input output unit, ALU, register and cache. So question is that how does a microprocessor work? So basically microprocessors follow a sequence, and that sequence is fetch, decode and execute. Fetch means you have to fetch the data, means you have to take the data from input device. Decoder means decode which operation microprocessor have to perform, and then microprocessor perform operation according to that information and then execute. So microprocessor fetches those instructions from the memory, then decode it and execute those instructions. So basically a microprocessor take input from input device, process it as per instruction given the memory and produce output. So basically this is fetch, decode and execute. So why do we use microprocessor? So it is used to build a system which can perform multiple tasks by avoiding the use of traditional transistor individually, and thus making the system compact in size. Because if you are going to use transistor, your system can be heavy and bulkier, and that is not easy to use in modern days. That's why we use microprocessor, to avoid all the problem. And it is basically building block of third generation computer that makes them compact and versatile. And a microprocessor is similar to our human brain. It can be trained to do anything, it can be programmed to do anything we want based on its instruction set capabilities. And whatever program we are going to import in microprocessor, basically microprocessor is going to respond according to the program. Sometimes solutions are very complex, circuit also become very complex if you try to solve it without programming. So in microprocessor, to solve our program, at least we can use program. So whenever we talking about the application of microprocessor, so this world is full of application of microprocessor. Wherever you want to see, you can find many application of microprocessor, because nowadays computer system is also example of microprocessor. Laptop, mobile phone, means whatever digital device we are using microprocessor as well. So the microprocessor is used in personal computer, the microprocessor is used in laser printer for good speed and making automatic photo. The microprocessor are used in modem, telephone, digital telephone, and also in air reservation system, railway reservation system, in medical instrument to measure temperature and blood. It's also used in mobile phone and television. It is also used in calculator and game machine. It is used in accounting system and data acquisition system. So there are various application of microprocessor. So in military application, traffic light control, home appliances, controlling various parameter. So I have already discussed this world is full of application of microprocessor. So basically there are many application of microprocessors. So within one lecture we cannot discuss and we cannot cover all the application, because whenever you are going to write, you can write millions of application of microprocessor. So now, what is advantage of microprocessor? So it's low cost, microprocessor are available at low cost. Okay, high speed microprocessor chip can work at a very high speed due to the technology which is involved in. Versatile, microprocessors are very versatile. The same chip can be used for a number of applications by simply changing the program. If you are importing addition program, that is going to work as addition. If you are importing subtraction, this is going to work as a subtraction. So low power consumption, it's basically microprocessor usually manufactured using metal oxide semiconductor technology. So that's why they are going to consume very low power, less heat generation, reliable, portable, and devices or computer system made with microprocessor can be made portable due to the small size and lower power consumption and small size. So basically these are some advantages. Now talking about common terms used in microprocessor. So bus, basically bus is a set of conductor, or you can say set of wire. So that is used to transmit data, address or control information to different element in microprocessor. Instruction set, so instruction set is a group of command that microprocessor can understand and perform the operation according to those instruction set. So in next slide we are going to discuss more about instruction and instruction set, so don't worry. And word length is basically number of bit in the internal data bus of the processor, and also you can say it is a number of bits a processor can process at a time. For example, an 8-bit microprocessor will have 8-bit data bus, 8-bit register, and will do 8-bit processing at a time. Cache memory, so cache memory is a random access memory that is integrated into the processor. So the processor can access data in cache memory more quickly than from a regular RAM. So the concept of cache memory is a very much important in microprocessor, and that is used to enhance the capacity of microprocessor. You can say the enhance the speed of microprocessor as well. And also we have clock speed. So microprocessor uses a clock signal to control the rate at which instructions are executed, and basically the main work of clock speed is to generate crystal frequency, and according to that crystal frequency your microprocessor is going to work. And also it's related to how many instructions are executing per second. It's also depend upon clock speed. If you will increase the speed of clock speed, so definitely your microprocessor will execute more instruction per second. Bandwidth, so it is number of bits processed in a single instructions. Data types, so microprocessor has a multiple data types format like binary, BCD, ASCII, signed and unsigned number. So now we are talking about evolution of microprocessor, means how microprocessor came into the market. So according to the generation or according to size of microprocessor, we can categorize the evolution of microprocessor in various form. First one is first generation, that is called 4-bit microprocessor, and the first generation microprocessor were introduced in 1971 by Intel Corporation, and it was named as Intel 4004 because it was a 4-bit microprocessor, and it was a processor on a single chip. So it could perform simple arithmetic and logical operations such as addition, subtraction, boolean or and boolean and it had a control unit capable of performing control function like fetching an instruction from storage memory, decoding it, and then generating control pulses to execute it. Now second generation, it was 8-bit microprocessor, and that was introduced in 1973 again by Intel, and it was first 8-bit microprocessor which could perform arithmetic and logical operation on 8-bit data. Okay. Third generation, it was a 16-bit microprocessor introduced in 1978 by Intel. Okay, and which were 16-bit processor with performance like a mini computer. Fourth generation, that was 32-bit microprocessor, and several different companies introduced the 32-bit microprocessor. The most popular was Intel 80386. Fifth generation, now 64-bit microprocessor. So from 1995 to now we are in fifth generation. So after 80856, Intel came out with a new processor, namely Pentium processor, Pentium Pro CPU. Okay, other improved 64-bit processor are Celeron, Dual, Quad Core, Adda, i3, i7, and many more. So if you want to know about latest processor of Intel, so latest processor of Intel is new 10th generation Intel Core processor, or deliver remarkable performance upgrades for improved productivity and stunning entertainment, including 5.3 gigahertz Wi-Fi. There are many functionality included in new processor which is launched by Intel. So you can see at their site, and this is is summary of evolution of microprocessor. So here you can see microprocessor name and year of invention and some properties of that microprocessor, like word length, memory address, pins, and clock. So here you can see Pentium 4 in 2000. So here i3, i5, i7, and now these are some terms which are used in table. So here you can see what is basically what is full form of those terms. So PGA, MMX, EPIC, SIMD, ALU, MAU, FU. And if you want to visit Intel processor family, so you have to click on this link and you can visit. So now let's start discussing about 8085 microprocessor. So firstly I will discuss about some basic properties of 8085 microprocessor. Then we will discuss about bus organization, internal architecture, pin diagram. So many things we will discuss. So firstly 8085 microprocessor is also called as a 8-bit microprocessor, and the microprocessor is the CPU of a computer, and as we know everything is handling through the CPU in a computer. So that's why 8085 microprocessor is called brain. You can say brain of computer or heart of computer, because all the logical arithmetic operation happen within the microprocessor, or you can say CPU. So it is designed by Intel in 1977, and it is 8-bit microprocessor, and it is 40-pin IC. It uses a single plus 5 volt DC supply for its operation, and the clock speed of 8085 microprocessor is 3 megahertz, and clock speed is related to number of instruction executed by microprocessor per second. If clock speed is greater, then number of execution of instruction will be greater, and also you can say performance of that microprocessor will be also good. And it contains 8-bit data bus, 16-bit address bus, 16-bit stack pointer, and 16-bit program counter, 6 8-bit register which are also arranged in register pair as BC, D, HL. So these are some properties of 8085 microprocessor, and this is basically diagram of internal architecture of 8085 microprocessor. So each block is connected to each other, and I will discuss each and every block and working of each and every block, so we can easily understand how microprocessor works. Okay, so here you can see various block: interrupt control, serial input output control, accumulator, temporary register, timing and control unit, address, data bus buffer, multiplexer, instruction. So basically these are some block. Here you can see register here. So I will discuss each and every block. So before discussing each and every block, let me discuss bus organization in 8085 microprocessor, because bus is related to connecting wire, and I am hoping you have seen some physical CPU and computer system, and whenever you open your laptop or CPU, you can see devices are connected to each other through the wires. Basically those wires called bus in microprocessor. And also you have seen a computer system. So in there is a keyboard, monitor and CPU. So keyboard is also connected to CPU, monitor is also connected to CPU. So here keyboard is a input device, monitor is a output device, and CPU is a processor. So the wire which connecting keyboard to CPU and CPU to monitor, basically that wire is called bus. Okay, and the main responsibility of bus to transfer information from one device to another device, or carry information from one device to another device. So in 8085 microprocessor we have three buses. One is control bus, data bus, address bus. So data bus, the main responsibility of data bus is to carry data within the microprocessor whenever the microprocessor is performing operation. So the main responsibility of data bus to carry data. The length of data bus is 8-bit, so it can carry 8-bit data, and the range of data can be from 00 to FFH. And data bus is bidirectional, means data flow in both direction, from microprocessor to memory or input output device, as well as from memory to microprocessor and input output device to microprocessor. So when it is write operation, the processor will put data in data bus. When it is read operation, the memory controller will get the data from the specific memory and put in data bus. Now we have address bus. To the main responsibility of address bus to carry address within the microprocessor, and it is 16-bit, means it can carry 16-bit data. And address bus is unidirectional, means it's work in only one direction, and that direction is from microprocessor to memory or from processor to input output device. And the range of data bus is 000H to FFH. Now talking about control bus. So control bus basically control all the operation which is happening within the microprocessor, and it is a group of conductive wire which is used to generate timing and control signal to control all the associated peripheral. And also microprocessors use a control bus to process data, and some control signal are memory read, memory write, input output read, input output write, opcode fetch. So now let's discuss architecture of microprocessor. So first block is timing and control unit. So the main responsibility of this unit to control all the operation which is happening within the microprocessor. Basically it generates signal, and that signal transfer to the CPU. According to that signal, CPU perform the operations. So it's control the entire operation of microprocessor. So here there are some signal which is associated with this unit. Control signal read, write, ALE, status signal S0, S1, hold, HLDA, reset and reset out. So next is register. So register is also very important parameter in architecture of 8085 microprocessor, and register are smallest data holding element that is used to hold the information during the operation, means arithmetic operation, logical operation, and it hold the data temporarily. And the capacity of register is 8-bit in 8085 microprocessor. So we have two type of register in 8085 microprocessor. One is special purpose register that contain accumulator and flag register, and second is we have 6 general purpose register. These are B, C, D, E, H and L, and 2 16-bit register. One is stack pointer and program counter, instruction register and temporary register. So mostly we use special purpose register, general purpose register, stack pointer and program pointer. There is no use of temporary register, and also user cannot access instruction register. User only access A, B, C, D, E, H, L and F, SP and PC. So why accumulator is called special purpose register? Actually accumulator is represented by A, and whenever you are performing any arithmetic and logical operation, one data should be in accumulator. Means accumulator store input, and if you are performing any operation, arithmetic, logical and other operation, one data must be in accumulator. And after performing the operation, by default your output will be stored in accumulator. So accumulator is doing 3 work: containing input, taking participation in operation, and by default output will be storing in accumulator. That's why this is called special purpose register. Now talking about general purpose register. So the main responsibility of general purpose register are to store 8-bit data, and generally they contain input. If you want to store output in these register, by forcefully you can store. By transferring data from accumulator to this register you can store, but by default your output will be stored in accumulator. And these are B, C, D, E, H, L. And suppose if you want to store 16-bit data in 8085 microprocessor, then you can do it by using register pair. So in 8085 we have a 3 register pair. One is BC, DE and HL, and register pair is represented by first letter of pair, and it's depend upon instruction that B is register or register pair. Just I am taking example. Suppose there is a 2 instruction. One is in INR B and second is INX B. So here in this B is 8-bit register, here B is BC pair. Why? Because this instruction work with only 8-bit data, that's why, and INX works with 16-bit data, that's why. So this is BC pair and here B is simple register. Okay, now program counter. So it is 16-bit special purpose register, and program counter hold the address of memory of the next instruction to be executed. And stack pointer, it is a 16-bit special function register which is used to the point the memory location called the stack, and the stack is nothing but portion of a RAM. Now instruction register. So the instruction register hold the opcode of the current instruction of a program during arithmetic and logical operation. And we have actually what happened before the CPU decoder takes the instruction from the instruction register and decode it, and after that decoded instruction is passed to the CPU for the execution. So basically this is working of instruction register. Temporary register, actually it is not accessible for the programmer, so it's only internally used by the microprocessor. So now flag register. This is a really very important topic to discuss. this, and I will also explain to you 3 examples so you can easily understand what is flag register and how you can check yes your flag is set or reset. So LU include 5 flip-flops which are set or reset after an LU operation according to data condition of the result in accumulator. What happen, whatever operation you will perform in 8085 microprocessor, by default your output will be stored in accumulator. According to content which is available in accumulator, your flag will be set or reset. Set means value of flag will be 1, reset means value of flag will be 0. So in 8085 we have 5 flag: carry flag, parity flag, auxiliary carry, 0 flag and sign flag, and this is basically structure of flag. Okay, so here you can see basically this is 8 bit and this is D0 bit and this is D7, means this is MSB and this is LSB. Okay, this is basically structure of flag. Okay, and we have 5 flags, so I will discuss each and every flag. Firstly, sign flag. Suppose you have done any operation, by default your output is stored in accumulator. Okay, and output will be stored in this form. Suppose your output is 0 0 0 8 bit. Suppose this is 8 bit. Okay, so basically this is D7. If value of D7 is 1, then your sign flag will be set, otherwise it will be reset. And sign flag mostly used in signed and unsigned number. If you want to find yes your number is positive or negative, so by this D7 you can find. If D7 is 1 means your sign flag is set and that will be negative number. D7 is 0 means sign flag will be reset and that will be positive number. Okay, now second is 0 flag. If total output is 0 means content of accumulator is 0, means all the 8 bit are 0. In that case your 0 flag will be set, otherwise it will be reset. Now third is parity flag. If number of 1 in output or even, number of ones in output or even, in that case parity flag will be set, otherwise it will be reset. Now just taking consideration of this example, number of 1 is 3 means odd. In this case your parity flag will be 0. Carry flag, if you are adding 2 number or subtracting 2 number, if a carry is generated at this place, means suppose I am adding this number. Okay, if your carry is generated here, means in this case carry flag will be set, otherwise it will be reset. Now auxiliary carry. What happens, suppose this is 8 bit, so this is 4 bit and this is 4 bit. Sometimes people used to call it lower byte and sometimes people used to call it higher byte. If any carry is transferring from lower byte to higher byte, means if any carry is generated at this place, okay, in this case your auxiliary carry will be set, otherwise it will be reset. So this is all about the flag register. Okay, so now here you can read it and also you can understand how flag is going to be set and reset. Okay, 0 flag, here auxiliary flag we have already discussed, parity flag, and now this is carry flag we have already discussed. Now just taking to a 3 example to make you understand. Okay, so here this is first example. So first number is CD and second is E9. So basically this will be D7 and this will be D0 and this is output, and according to this output your flag will be set or reset. So just take first flag is sign flag, just we are discussing. So here you can see the value of D7 is 1. In this case sign flag will be set. Now second flag is 0. total output is not equal to 0, means 0 flag will be reset. Third is parity flag, just count number of 1, 2, 3, 4, means number of 4 is even. In this case parity flag will be 1. Now check carry flag. Here you can see 110, means carry will be generated here. In this case your carry flag will be set. Now check auxiliary carry. So D0, D1, D2, D3. Here D3 you can see 110, means carry is generating at this position. In this case auxiliary carry will be set. So this is all about carry. Now here you can see second example. I have added two numbers 55 plus 54. Here 9 we will get 1010, 11001. So there is no any carry, so carry flag will be reset. Number of 1 is 4, even. Parity flag will be set. Here D7 equal to 1, sign flag will be set. Here there is no any carry generation at this place, so auxiliary carry is 0 and total output is not 0, so 0 flag will be reset. Here you can see second example, and here just try to do it yourself so you can easily understand how flag works in 8085 microprocessor, and I have also provided solution. So by using this solution you can easily understand how you can find yes flag, which flag is set or reset during the subtraction and during the addition. So here you can consider this example also. And if you face any problem regarding the flag register, you can put a comment or you can send me a message. I will help according to that how you can find which flag is set or reset. Now LU. So LU basically arithmetic logic unit. All the arithmetic and logic operation are performed in arithmetic logic unit. So the main responsibility of LU to perform arithmetic and logical operation. So the LU perform the following operation: addition, subtraction, logical AND, logical OR, logical XOR, complement, increment by 1, decrement by 1, rotate, clear, and many more operation which is done through the LU. And increment decrement register, so we have the 8-bit contents of register memory location can be incremented and decremented by 1, and this 16-bit register used to increment and decrement the content of program counter register by 1. Address, data buffer and address buffer, this is same which we have already discussed. Okay, so and serial input output control unit, basically this unit participate whenever a serial communication or serial data communication is happening, and it's control the serial data communication by two instructions. One is SID, serial input data, and SOD, serial output data. And also we have an interrupt unit. So basically this control interrupts a process. Consider that suppose a microprocessor is executing the main program, and whenever the interrupt signal is enabled or requested, the microprocessor shift the control from make a program to process the incoming request, and after the completion of request the control goes back to main program. So in easy language you can say interrupt means to generate a error. Okay, so whenever a error will be generated in microprocessor, so firstly microprocessor will be solve that error, then execute the main program. So basically this is handled by interrupt unit. So here interrupt service routine. So basically by this figure you can see here okay, this is main program is happening here, interrupt is generated, then after this control will transfer to interrupt service routine, and that is going to solve this program and then again return to main program. And interrupt signal present in 8085 are INTR, RST 7.5, 6.5, 5.5 and trapped. So here, so this all about interrupt. So now time is to discuss a pin diagram of 8085 microprocessor. I have already told you in the introduction section that 8085 microprocessor is a 40 pin IC, and so here you can see the configuration of pins in 8085 microprocessor, and these are nomenclature from 1 to 20 and 21 to 40. So I will discuss working of each and every pins, how and what is basically usage of these pins in 8085 microprocessor. So here you can see VCC that is used for plus 5 volt supply, and BSS for ground reference, means BCC pin number 40 and pin number 20. Now when talking about pin number 1, 2 and 37, so 1 and 2 are terminal to connect the external crystal oscillator to generate the frequency, and according to that frequency microprocessor operate, and pin number 37 is used for the clock output. It acts as a system clock that keeps the record of time duration required by each operation to get completed. And now we are discussing pin number A0 to A7, that is lower address, and A8 to A15, that is higher address. So here you can see A0 to A7 and A8 to A15. Okay, so the address bus is a group of 16 lines A0 to A15, and the address bus is unidirectional, means bit flow in one direction from microprocessor to the peripheral device, and data bus AD0 to AD7 means basically pin number 19, 12 to 19 both are multiplexed, and these pins works as a used for data bus as well for address. So the bits AD0 to AD7 are bidirectional and serve as A0 to A7 and D0 to D7 at the same time. So during the execution of instruction, these lines carry the address bits during the early part, then during the later part of the execution they carry the 8-bit data bus. Means these pins work as address bus as well as data bus, and these pins are multiplex. Why these pins are multiplex? Only due to save the number of pins. So the main reason of multiplexing address and data bus is to reduce the number of pins and dedicate those pins for other several function of microprocessor. So we have a control and status signal, so that is ALE, that is called address latch enable, and it is an output signal used to give information about content of AD0 to AD7, and it is positive going pulse when a new operation is started by microprocessor. When pulse goes high, it indicate that AD0 to AD7 are address, and when it's slow indicate that content are data. Because we have already discussed these pins are multiplex. In earlier part they carry address, and later part they carry data. Now we have pin read. So read memory or input device. So if this is enable, means read operation is going on. We have write. If write signal is high, means write operation is going on. Input output oblique memory. So this signal is used to differentiate between input output and memory operation. When it is high, indicate input output operation, and when it is low, then it indicate memory operation. Now we have status signal S1 S0. It is used to know the type of current operation of the microprocessor. So here you can see if 00 means halt, 01 or you can say 10 write, 01 read, and 11 fetch operation. So we have ready. It is used by the microprocessor to sense whether a peripheral is ready to transfer a data or not, If ready is high, then means your peripheral is ready to transfer the data. If it is low, microprocessor in wait state, and whenever processor sets the ready signal after completing the present job to access the data. So basically this is working of ready. If ready pin is high, means microprocessor or peripheral device is ready to communicate. Now we have interrupt and externally initiated signal. Hold. So hold indicate that another device is requesting for the use of address and data bus. HLDA is a signal for hold acknowledgement, which indicate that hold request has been received. After the removal of this request, the HLDA goes low. Now we have INTR. INTR is interrupt request signal. When INTR pitch goes high, then the 8085 microprocessor complete the current instruction which is being executed and then recognize the INTR signal and process it. INTA is a interrupt acknowledgement sent by the microprocessor after INTR is received. We have reset. In this signal used to reset the microprocessor, and the program counter inside the microprocessor is set to 0. By default, the value of program counter is 0. Whenever your machine is start, you can set the value of program counter. Reset out, it indicates CPU is being reset. It is used to reset all the connected device when microprocessor is reset. And we have some interrupt RST 5.5, 6.5, 7.5 and trap. So these all are interrupt. When any interrupt is recognized, the next instruction is executed from fixed location in a memory as given below. So basically this is purity. On basis of purity, this is going to be solved. We have a serial input output signal. So SID. So you can see pin number 4 and 5. So SID is a data line for serial input. The data on this line is loaded into the 7th bit of the accumulator when RIM instruction is executed. And SOD is a data line for serial output, and the 7th bit of the accumulator is output on SOD line when SIM instruction is executed. So I hope I have discussed each and every pin. So this is all about pin diagram of microprocessor. What is instruction? The instruction is basically a command given to microprocessor to perform some specific operation on given data. So basically, in previous video I have already told about what is instruction. Instruction is basically, you can say, bit pattern which is used to provide microprocessor to perform some specific task on given data. Now when we talk about instruction set, so basically instruction set is a collection of the instructions that the microprocessor is designed to execute. This basically instruction set is just a collection of various instructions which is used inside microprocessor to perform various operations. Every instruction has two parts. One is opcode and second is operand. Opcode means which operation you are going to perform. Means suppose I am going to perform addition, subtraction, multiplication. So basically these are example of opcode. Operand means data, and which data you are going to perform. Suppose I have written an instruction that is add B. Just I have written an instruction that is add B, suppose. So here I am going to do addition. So basically this is opcode, and which data? That is data of B, that is operand. Here you can see example LXI at 2050. So here this portion is opcode and this is
operand on which you are going to perform the operation. Now, when we're talking about a classification of instructions, the programmer writes a program in assembly language using these instructions. These instructions have been classified into following group: data transfer group, arithmetic group, logical group, branch control group, and stack input output and machine control group. What is data transfer group means? Basically those instructions which is used for transferring the data within the register to memory or memory to register. Those type of instruction comes under data transfer group. Arithmetic means if you are going to perform any arithmetic operation in microprocessor, you have to use some specific command or instruction. That instructions comes under arithmetic group. Logical means if you are going to perform any logical operation as like and, or, not, so those type of instructions comes under logical group. In branch control, basically there are some instructions which is used for condition checking as like if and else. So this type of instructions comes under branch control group. And when we are talking about push pop, input output, enable, disable, sim, this type of instructions comes under stack input output and machine control group. So let me start data transfer instruction. Basically instructions which are used to transfer the data from register to another register or from memory to register or registry to memory come under this group. So basically this is definition of data transfer instruction, and these are some data transfer instruction which we are going to use in 808 for microprocessor programming. So let me discuss each and every instruction with the suitable example so you can easily understand. Now first instruction is move RD, RS, M, RS, RD, M. Here RD means destination register, RS means source registers. Meaning of this instruction is that this instruction copies the content of the source register into the destination register. Okay, the content of source register will be not changed. Just let me take an example here. I have taken example move RD, RS. RD means destination register, that can be any register like A, B, C, D, E, H, L. RS source register, that can be also any register as like A, B, C, D, E, H, L. Okay, here just assume the content of B is 05 and the content of C 07. When you are going to execute move B, C, means C is source register and B is destination register, means you are going to copy the data of C into B. So after execution of this instruction, the content of B equal to 0C and the content of C will be 0C, because the content of 0C will be not changed. Why? Because this is source register here and this is destination. In second program, here C is a destination and B is source, means you are going to copy the data of B into C. So here after executing of this instruction, the content of C will be 05 and the content of B will be 05, because in this example B is source register. Now talking about M, very simple, just consider the content of M is 05 and content of B is 06. Here move B, M, B means you are going to copy the data of B into M. After this instruction you can get M equal to 06, B equal to 06, and in another example M is working as source register and B is working as destination register. Now main question is that what is M? M represents memory. Just try to understand what is M, because M you are going to use in each and every program in 8085 microprocessor. Here M, the content of memory location which is contained by HL pair is called M. Suppose the content of HL pair is 2050, that is a memory location, and the content of this memory location is 05, means that 05 will be represented by M. So here M is 05, means the content of memory location which is acquired by HL pair. Now MBI RD data, MBI M data. Basically this instruction is used to load 8-bit data in given register. In given register means RD means destination register. There must be a register and you have to load this given data in that particular register. Just I am taking example MVI V, 06 means you are going to load 06 in that register B. And suppose you have written MVI C, 06 means you are going to load 06 in register C. So basically that instruction is used to load 8-bit data in given register. Now talking about LDA. Basically LDA load data direct in accumulator. Suppose there is a memory location 2000 and the value of 2000 is 05. LDA 2000 what will do? This will store the content of this memory location in accumulator. Means after executing this instruction A will have 05 and this is source that it will be 05. So if you want to transfer any data from memory location into accumulator by using this instruction, you can easily transfer that data in accumulator. Now talking about LDX, this is a very important instruction. D means LDX B. There is a possibility of instruction. LDX D, there is a second possibility of this type of instruction. Here we are going to load data in accumulator in indirect way. Please just try to understand how you are going to use this instruction. This instruction copies the content of memory location which is represented by register pair into the accumulator. Just I am taking example to explain this. Suppose memory location 205H is pointed by BC register pair, as the BC equal to 2050 and the content at this location is 05. When you are going to execute this instruction LDX B means you are just going to copy the data of this location into accumulator. So after executing this instruction, the content of A will be 05. So this is an indirect way to transfer a data from memory location into accumulator. LXIH. Basically this instruction loads 16-bit data in register pair designated in the operand. Means LXIH means we are talking about HL pair. Data is 2050 means data 2050 will be loaded in HL pair, means the MSB will be stored in H, LSB will be stored in L. Here after this instruction you can find out the content of H will be 20H and the content of L will be 50H. Now LHLD, this is the format of this instruction is HLD, 16-bit address, means this instruction is going to work with two memory address at same time. My meaning is to say that this instruction copies the contents of the memory location pointed by the 16-bit address into register L and the content of next memory location into register L. Just look at this example. Suppose the content of memory location 205H is 05 and the content of memory location 2051 is 06. Okay. And when you are going to execute HLD 2050, meaning of this will the content of 205 will be stored in L, means 05, and the content of memory location 205 will be stored in H, means this instruction is working with two memory address at a same time. Now ST, basically this instruction is just opposite of LDA. Here if you want to store the data of accumulator at a given location, you have to use this type of instruction. Just take this example. What happened in this instruction, the content of A will be stored at this location. Suppose the content of A is 05. So by using this instruction you can store the content of A at this memory location. Now talking about next instruction, that is a opposite of LDX, which we have already discussed. Here stacks H, B and D is a possible. Suppose the content of A is 05 and the content of BC is 2050. Basically 2050 is memory location which is pointed by BC. After executing this instruction, the content of A will be copied at this memory location. Now SHLD, this is basically opposite of LHLD. Here we are going to store the data of L and H at a given memory location. What happened, the data of L will be copied at given memory location and the data of H will be copied at next memory location. Here you can see, suppose the content of register L is 05 and the content of register H is 06. So after executing this instruction, the content of 050 will be 05, means the value of L will be stored, and the content of 2051 will be 06, means that is a content of register H. So here this instruction also work with two register at two memory location at same time. Now last instruction of this type of instruction means data transfer instruction. This is XCHG, means exchange. Basically this instruction exchange the value of H and L with D and E, means the value of H will be exchanged with D and the value of L will be exchanged with E. Here suppose the content of HL is 2050 and the content of D is 3050. Okay. After executing this instruction, the content of HL will be 3050 and the content of D will be 2050. So in this instruction works, and I think I have explained each and every instruction with example. Those instruction which comes under data transfer instruction. Now we have two programs, just try to solve it by yourself so you can understand how microprocessor programming is going to work. In first program you have to write a program to exchange the content of A and B, means input is A equal to 05 and B equal to 06, and you have to find output A equal to 06 and B equal to 05, means you have to exchange the data within two registers. Now just let me explain how you can do it. This is a very simple way. We have register A, that is 05, and we have B, that is 06. Okay, just take register C, and this is first step. Okay, when you are going to shift this data into C, what happen? After this, value of A will be 05 and C will be 05. Okay, now second step, just transfer this data into A. This is second step. What happens in second step, when you are going to perform this operation, the content of A will be 06. Okay, and the content of B will be 06. Now this is third step, just transfer the data of C into B. After this, what happened? The content of C will be 05 and the content of B will be 05. So here you can see after three steps, the value of B will be 05 and the content of A will be 06. So by using three move instruction, we can perform this operation. Here you can see the output where I have written the whole program. Okay, now this is second example. Basically you have to find the output of this program. So let me check it. MVIA comma 0 means after this instruction the value of A will be 04. When you are going to execute this instruction, means value of M is 06, that 06 will be stored in accumulator. After this instruction the content of A will be 06, and when you are going to copy the A into C, means after this instruction the content of C will be 06, A will be 06. After this the content of B will be 06, C will be 06, means the final output will be 06, 06. So what is meaning of arithmetic instructions? Arithmetic instructions are the instructions which perform basic arithmetic operations such as addition, subtraction and few more, means Also you can take example of multiplication, division, increment, decrement, decimal to hexadecimal to decimal conversion, because we have many instructions which are used in 8085 microprocessor to perform arithmetic operation here. And also as we discuss many times, whatever operation you are going to perform in microprocessor, the output will be stored in accumulator. Here the list of some arithmetic instructions. In this video I am going to discuss each and every instructions. Here you can find this type of instruction used for addition purpose, this for subtraction purpose, and this for other purpose as like increment, decrement, and hexadecimal to decimal conversion. So these are instruction, and just I am going to discuss each and every instruction one by one. Hope by looking at example you can easily understand how this type of instruction is going to work during the arithmetic operation in 8085 microprocessor. So let me start. First instruction is add R. R means register. Register can be any as like A, B, C, D, E, H, L. We have 7 register which are generally used to perform any operation. The 8th register is flag register. So actually we have already discussed the working of flag register is very different from the general purpose register. And accumulator also. Here M represent memory, and we have already discussed what is meaning of M. Now just what is definition of this instruction? The content of register or memory address are added to the content of accumulator, and the output will be stored in accumulator. Just let me take an example, then you can easily understand what happening here. Suppose the content of A is 05, here you can see, okay, and the content of B is 06. When you going to write add B, meaning of this will be A plus B. After addition, whatever output will be, that output will be stored in accumulator. So here you can see the content of A is 05, the content of B is 06. After this operation, both will be added, means output will be 11, but in hexadecimal that will be 0B, and that 0B will be stored in accumulator. So this is process. Suppose you have written add C. Okay, you written add C. Add C means you are going to add A plus C. Same as add B means A plus B, add D means A plus D, add E means A plus E, add A means A plus S. Means you are going to add the content of accumulator with accumulator itself, and in that case output will be stored in accumulator itself also. So this is working of addition instruction. Here we are talking about add M, means suppose the content of A is 05 and the memory location which is pointed by HL pair is 2050, and the content at this memory location is 05. Here 05 is represented by M. If you are going to do add M means A plus M, the content of A is 05, the content of M is 05, 05 plus 05 that will be 10, but in hexadecimal that will be 0A, and that 0A will be stored in accumulator. So this is process of how add instruction is going to work in 8085 microprocessor. Now second instruction is ADCR. R means register, which I have already told you. A, B, C, D, E, H, L. M represent memory, which I have already discussed in previous example. Now just take example so we can understand what is difference between add and ADC. Here the content of register or memory and the carry flag are added to content of accumulator, and the result is stored in the accumulator. Now let's just take an example. Suppose the content of A is 05, content of B is 06, and suppose you have performed any previous operation and their value of carry flag is 01. So when you are going to execute this instruction, meaning of this instruction will be A plus B plus carry. So here value of A is 0.5, B is 0.6 and carry is 1. 5 plus 6 plus 1 equal to be 12, and 12 written in hexadecimal as 0C. So here we can get output 0C in accumulator. In same manner, we can talk about memory, and I think I have already discussed what is meaning of memory. So here the content of this location 0.5 will be memory, and if you are going to write ADCM means A plus M plus carry, so we can get 0B. So this is a simple working process of addition instructions. Now moving towards ADI 8-bit data, means here you can see the format for mentioning ADI 45H. Here we are going to add 8-bit data directly to accumulator, and output will be stored in accumulator. So by this example you can easily understand. Here you can see the content of A is 0.5 and you have written ADI 0.6, means that 0.6 will be directly added to 0.5 and your output will be stored in accumulator. So here you can get. Now talking about ACI. ACI means here A plus given data plus carry. Suppose there is a carry 0.1, after ACI 0.6, that will be A plus 0.6 plus carry, and your output will be stored in accumulator. So this is working of this instruction, and we are here we are talking about direct data. In previous example we are getting data through the register, means we are getting data indirectly, but here we are getting 8-bit data directly. So this is a basic difference between ADC and ADI ACI, because here we are adding data directly without using any register, but in those cases we are taking register to add data in accumulator. So this is difference is only for direct and indirect. Now DAD, basically DAD is used to add a 16-bit register to each other. Here what happened in this case, suppose just by taking example, I think you can easily understand. This instruction is used to add for 16-bit data. Here suppose the content of HL is 2050, content of 305D is 3050, and when you are going to execute this instruction, meaning of this will be HL plus D, and your output will be stored in HL pair. Here HL works as memory pointer, or you can say this is works as accumulator. So here after addition, output will be stored in HL and the content of D will be not changed. Suppose you have written DAD B. Okay, here B means you are going to add HL plus BC and your output will be stored in HL. So this is simple working of DAD. Now subtraction. If you are talking about subtraction instruction, it is just opposite of addition, because in addition we are going to add the content in accumulator and store output in accumulator. Here we are going to subtract the content from the accumulator, means sub R means A minus R, sub M means A minus M. So directly we can take some example. Actually I am not going to read this statement. I think you are much aware about what is meaning of this. By example you can easily understand what happening here. In sub, suppose the content of A is 0.6 and content of B is 0.5, and when you have written sub means you are going to subtract the content of B from A, and in this case output you will store in accumulator as well. In same case here you can see the content of A is 0.6, HL is 205, the content of this is 0.5, sub M means A minus M. Okay. Now SBB means subtract source and borrow from the accumulator. Here we are doing, suppose the content of A is 05, content of B is 01 and the carry flag is 01 means borrow. So, after this instruction that will be A minus B minus borrow. So, here we are going to subtract borrow also from the accumulator. In case of memory, A minus M minus borrow. So, this is working of these instructions. And now we can talk about SUI and SBI. Basically, these are opposite to ADI and SEI. Okay. Here we are subtracting 8-bit data directly from the accumulator. So, here you can see example. Suppose the content of A is 08. So, after writing this 06, A minus 06 means we are subtracting 8-bit data directly. Here we are subtracting 8-bit data and also borrow. So, A minus 0 minus C. Here we can see A minus 04 minus C. So, basically this is instruction is opposite of ADI and this is SEI, opposite of ACI. Actually, sorry, here this is wrong. Here should be SBI, not ACI. So, I am really sorry for that. Okay. Then A minus 04 minus C. Now, talking about some other instruction, there is a INR. INR means increment and R means this represent register, M represent memory. Here, now what is difference? The content of designated register or memory are incremented by 1 and result is stored in same place. Here, suppose the content of B is 06 and if you are going to execute this instruction INR B, what will happen? This instruction will increment the value of B by 1 and store the incremented value in same register. We are not talking about any concept of accumulator. Suppose you have written increment A, in that case the value of A will be incremented by 1 and that value will be stored in accumulator itself. And we are talking about C, in that case the value of C will be incremented by 1 and the incremented value is stored in C. Same in case of memory. Here the content of memory is 06 when you are going to execute this instruction. After this instruction the value of M will be 07 and that 07 will be stored in at this memory location. Now, talking about INX, X represent register pair. Here RP means register pair and we have 3 register pair. One is B register, BC, HL and D. Okay. Suppose the content of HL pair is 2050. When you are going to execute, basically this will increase the value of pair by 1. So, here we can get 2051. Now, DCR is just opposite of increment. Here we are decrementing the content by 1. So, we can see example here, the content of B is 06, after DCRB that will be 05 in case of M also, and here we are decrementing the content of register pair. So, these are some instructions. Now, talking about last instruction of arithmetic, that is DAO, and this is a very important instruction, and just try to understand how this instruction work. Basically, meaning of this instruction is decimal adjust accumulator. Simple meaning is that whatever operation you perform in accumulator, that is in 805 microprocessor, the output will be stored in accumulator and the form of output will be hexadecimal. But if you want to convert that hexadecimal number in decimal, then you have to use this instruction, and the working of this instruction is basically convert hexadecimal into decimal. Now, question is that how this instruction work. So, here there are 2 conditions. One condition is if the value of lower order 4 bit in the accumulator is greater than 9, then add 06 to the output. If value of higher order 4 bit is accumulator is greater than 9, then add 06. Then we can get output. Now, just take a simple example. Here you can see two number 38 and 45. If you are going to add this number, we will get 70. Okay. Now, this is lower and this is higher. If you check, we are getting ki D is greater than 9, then you have to add 06 in this output, 0 and this is 6. Okay. Then what we get? 83, and here you can see also when you are going to add by using decimal method, also you get 83, and also we are getting here 83, means both are equal. Now, you can take a simple example, second example, 55 and 55. When you are going to add this, what we will get in hexadecimal? A. Okay. Now, this is also greater than 9, this is also greater than 9, then add 6 here and add 6 here. Now, what we get? A means 10, 6 means 16, and in hexadecimal 16 is written as 10. So, this is 0, 1 carry will be transferred here. Now, 10 and 1 11, 6 16, 17, and 17 in hexadecimal written as 1 1. So, here we get 1 1 10 in hexadecimal also, and also when you are going to add directly we also get 1 1 0. So, I hope ki by looking at these two examples you can easily understand ki how this instruction is going to work. Okay friends, so I have already discussed all instructions which is required to do arithmetic operation in 8085 microprocessor. Now, I am going to show you two examples. So, after solving this example, you can easily understand the concept of arithmetic instruction, how they are going to work in 8085 microprocessor. So, let me solve one example for you only, so you can easily understand. Just I am going to solve these instructions. Okay, but here you can see the one instruction. Meaning of this will be A minus A. Okay, means your output will be 0. Means after this instruction the content of A will be 0. Okay, I think you got my point. So, I am not going to solve these lines, because after this we are getting content of accumulator as 0. Now, after this line, that will be 0 0 plus 06, we will get 06. Now, content of accumulator will be 06. ADCB means A plus B plus carry, content of A is 06, content of B is 06, that is given here, and the content of carry flag is 01. 1, that will be 6 6 12 13. 13 means in hexadecimal that will be 0D. I think you get my point. Now, when you are going to perform add B, add M, add means A plus M, content of A is 0D and plus 1, that will be 0 E. Okay, here you can see E is greater than 9, then you have to add 06 here. Okay, after adding 06 you can get output in decimal also. Why I have add 06? Because here we are using DA, and DA will check both byte, lower byte and higher byte. Here we can see lower byte is greater than 9, thus then add 06. Now, just try to solve it by using decimal consideration. Here 06 B 06 means that will be 12 and plus 1 carry flag, that will be 13, and add M, that will be 14. So, here we will get 14,
if you are going to solve this, you also will get 14. Means by converting in decimal is same as doing in decimal. So this is in this example, and also as same manner you can solve this example also, and try to solve any program step by step. So you can easily understand, and just try to write down कि after this instruction what is value of A, what is B, and what is C, and after this what is, then you can find yes how your program is going on. Firstly, definition of logical instruction. Logical instruction or instruction which perform the logical operations like AND operation, OR operation, XOR operation, complement, compare, and rotate instruction. Basically this type of instruction comes under logical instruction in 8085 microprocessor. In my previous lecture I have already discussed कि all 8085 instruction divided in 5 type of groups, or you can say combination, and I have already discussed about data transfer instruction, arithmetic instruction. In this video I will discuss logical instruction with suitable examples, so you can easily understand कि how this is going to be worked within 8085 microprocessor. So here 3 set of instruction. Actually I have divided this instruction in 3 set. First set, here you can see basically these are some instruction that belong to you can say digital or logic, as like here ANA of instruction, ANI instruction, ORA instruction, ORI, XRA. Basically this reflects gate. I think you have studied digital electronics, and also you are aware about AND gate, OR gate, and XOR gate. So basically these are instruction. I will discuss in next slide how they are going to work within the 8085 microprocessor. And second set I have chosen, I like CMP means compare, CMA means complement of accumulator, CMC complement of carry, SCT means set of carry, and third group I have chosen by taking some rotate instruction. One is RLC, RAL, RRC, RAR, and these instructions are very useful in 8085 microprocessor programming, because using these 4 instructions you can find whether given number is negative or positive, whether given number is odd or even. If you want to find a reverse of any number by using this, you can find. If you want to find half of any number by using rotate instruction, you can find. If you want to find double of any number by using these instruction, you can easily find. So these are very useful instruction in 8085 microprocessor programming. So let me discuss one by one. So here I am going to start first instruction, that is ANA R, ANA M. Here R represent register. I think you have idea about register. So here R represent register, M represent memory. So value of R can be in microprocessor. We have some register. Here value of R can be A, B, C, D, E, and HL. In my first lecture of microprocessor I have already discussed. So here basically meaning of R is register, and the standard format can be suppose here that is given A and A, B. Now talking about what does this instruction do. So basically this instruction used to perform AND operation. I am not talking about adding, I am talking about AND operation. In digital electronics you have already studied about AND operation. So what happened, the content of the accumulator are logically ANDed with the content of register or memory, and the result is placed in the accumulator. Means suppose you have written A and A, AM, B. So just taking examples here, this is input, here output. This operation is performed by AND gate. So here I have represented a table. By this table you can easily find out
how AND operation works. Okay. Now, what is meaning of this? Suppose the content of A is 62. Okay, means this is content of accumulator, and content of C is 4A. Okay, and suppose you have written A and C. What is meaning of this? Meaning of this, the content of accumulator will perform AND operation with 4A. Okay, here NRC means A and C means content of accumulator will perform AND operation with content of C, and here after performing the AND operation, output will be stored in accumulator. So, here in this picture you can see here what I have written here. I have written 62. This is 62. Okay, here you can see 62, here 4 and 8. Okay, when you are going to perform AND operation, here you can see the table 0 0 0 0 0 0. Here you can see 0 1 0. Here 1 1 1 1 means 1. Here 1 0 0 1 means 0. So, basically you do not have to add this. Basically you have to perform AND operation. Okay, same in case of M. What we are doing here, basically we are going to perform AND operation with content of accumulator and the content of M, and M means suppose the content of HL is 2050, and at this memory location suppose some data are stored, so that some data are called as M. So, here we are going to perform AND operation between that content which is available at this location and 62. Okay. So, here suppose the content of this is 4A. So, here you have to perform AND operation between content of M and A, and after performing AND operation, output will be stored in accumulator, and here content of H will be 4A. Okay. Means content at this location will be 4A. So, I hope you can easily understand how ANA operation is going to work, means how AND operation works in microprocessor. So, by these two examples you can easily understand, and just I am requesting try to do yourself, so you can easily understand. Now, talking about ANI 8-bit data, here what happened, the standard format of this is ANI 86, means now the given content will perform AND operation with accumulator. Okay, here the content of accumulator or logically ANDed with the 8-bit data, and the result is placed in accumulator. So, you can take an example here, same. Suppose here I have written the content of A is 62, just assume, and here you have written ANI 4A. A means the AND operation will be happen between 62 and 4A, and whatever output will occur, that will be stored in accumulator. So, here you can see this is 62 4A. After AND operation, here we can get our output. So, this is for AND operation. Now, talking about ORA. So, basically ORA used for performing OR operation between content of accumulator and content of memory or content of register, and the value of register can be A, B, C, D, E, H, L, which we have already discussed. So, let take example here. This is a table of OR operation, how OR operation perform in microprocessor or in digital electronics. 0 0 means your output will be 0, 0 1 means 1, 1 0 means 1, 1 1 means 1. So, this is basically standard table of OR gate, or you can say OR operation. And here suppose the content of A equal to 62 and C equal to 4A. When you are going to write ORA C, means here OR operation will be performed between A and C. After this, here we can get output. Now, let us check your 0 0, just refer this table, we got 0 0, and here 1 1, refer this table 1 1,
0 0 0, and here 0 1 means 0 1 means 1, so here 1. So, basically we are performing OR operation here. So, and in same manner, in previous slide I have already discussed about M. So, here you can see second example, here the content of M is 4A and the content of A is 62. When you are going to write ORAM, means there will be OR operation between accumulator and the content of memory. So, now moving towards ORI and 8-bit data, here we are going to perform directly OR operation between the content of accumulator and the given content with instruction or in the form of operand. So, here you can see just take example. Okay. So, here you can see content of A is 62, ORI 4A, means here you can see data is given directly. In this type of instruction, the OR operation will be occur between 62 and 4A, whatever output will be occur, that will be stored in accumulator. So, this is working up ORI. Basically, what you have to do, you have to remember this table, then you can perform easily AND operation, OR operation on next XOR operation, because we are using table for AND, you are using table for OR, and also we are going to use table for XOR. If you remember these three tables, so you can easily solve any problem related to AND operation, OR operation and XOR operation, because whatever operation we are performing is totally depend upon this table, means input and output. Here what happen, the content of register will perform XOR operation with the content of accumulator. Okay, sorry, the content of accumulator will perform XOR operation with a register or with memory. It totally depend, you are going to perform XOR operation with register or memory. So, here you can see the example. A is, suppose the content of accumulator is EE and the content of E is 5AH. When you are going to write XOR A, means you have to perform XOR A operation between accumulator and the register E. Here after this instruction, the content of A will be B4 and the content of E will be 5A, means the content of E will not change. So, here also by using this table you can find out your answer, if this is correct or not. 0 0, here you can say 0, okay. 1 1 0, so here you can say 0, 1 0 means 1, you can find 1, again 1 1 0. So, by following this table you can find your output. So, this is working up basically XOR A operation. Here you can see XOR A M. Now, talking about XOR I have already discussed about ANI and ORI. So, this is same as both instruction, only difference is that the table, because in this case output will be different from the previous one, because here we are performing XOR operation. So, I do not think this is need to explain it again, but here just let me tell you something. Whatever content here you are going to write, here to write, this will perform XOR operation with content of accumulator and output will be stored in accumulator. This is operation of XOR. So, just remember one thing, ANA means AND operation, okay. ORA means OR operation, and XOR means XOR operation. Only you have to remember the table of this, then you can easily solve any program which is related to AND, OR and XOR. So, now talking about CMP, this is very important instruction which comes under logical instruction. Basically, whenever you want to find larger number, smaller number,
whenever you want to find largest and smallest number, you have to use this instruction, that is CMP means compare. And now what compare do? The content of register or memory compare with the content of accumulator, and both content are preserved. The result of the comparison is shown by the condition of flag. What happened? In this case, the content of register, whatever register or memory has given with that instruction, will compare with the content of accumulator, and the condition of flag will tell us the content available in accumulator is smaller than to given register, or equal to the given register, or greater to the given register. So, by the condition of flag we can easily find which number is larger, which is available in accumulator, that number is larger, or the content in register is larger. So, by using compare we can easily find which number is greater or smaller or equal. So, here you can see there are three conditions. A represent here accumulator. First condition is if A is less than register or memory, carry flag is set. Means suppose the content of R is 0.5 and the content of A is okay. So, here you can see suppose the content of R is 0.5 and content of A is 0.5. Then what happen when you are going to compare this? What happen in comparison? Basically, a subtraction operation occurs from the accumulator, means A minus R, and if you are going to subtract or you are going to perform 4 minus 5, we can know easily this will be not subtracted, means you have to take borrow. In this case your carry flag is set, means suppose you are going to perform operation or subtraction where carries occur, means the content of accumulator is smaller to the content of register or memory. So, this is first condition. If we are talking about second condition, that is zero flag set. Zero flag set means total output should be 0, means A minus R equal to 0, means suppose the content of A is 5 and the content of R is 5. In this case your output will be 0, means 0 flag set. If 0 flag is set, means both number are equal. Third condition is that if carry and 0 flag are reset, means meaning of this will be the content of accumulator is larger than given register. Suppose A equal to 0.5 and content of R equal to 0.6. If you are going to compare, means we get 2.0, this is not equal to 0, and also there is no any carry flag set, means the content of accumulator is greater than the given register. Okay. So, basically this is working of compare. Let me explain it again. So, first condition is this, carry flag is set. Suppose if you are going to perform compare operation and your carry flag is set. If carry flag is set, means the content of accumulator is smaller than the content of register, because here we are going to subtract the given data from the accumulator. Okay, because we have to compare with accumulator, not other registers. So, here we are basically behind the operation, we are going to subtract the content, the given content from the accumulator. Okay. So, suppose carry flag is set,
meaning of that the content of accumulator is smaller than register or memory. If 0 flag is set, means total output 0, means the content of accumulator is equal to the content of given register. In third case, if there is no carry, no 0 flag set, means the content of accumulator is greater than register. Here, okay, it is generally used in conditional execution. This instruction basically subtract one operand from the other for comparing whether the operand are equal or not. It does not disturb the destination of source, operand. It is used along with the conditional jump instruction for decision making. So here the now a question is arise when we are talking about a compare instruction. So what is basically main difference between compare and subtraction? Because here in compare we also subtracting the given content from the accumulator, and in subtraction also we subtract given content from the accumulator. So what is basically difference between compare and subtraction instruction? So here you can find the answer. The main difference between CMP and sub is that CMP does not store the result of subtract operation. In comparison instruction, CMP does not store the result of subtract operation. It performs subtraction only to set the status flag. Similarly, two registers can be compared to C. So basically what happens in subtraction operation, your output is going to be stored in accumulator. Being in compare, your output will be not stored anywhere. Only we can check the status of flag, and by checking the status of flag we can define the number given in accumulator is larger, smaller or equal to the content given in the register or memory. So this is working of compare. Here CPI means we are going to compare 8-bit given data with the accumulator, and we can find which number is larger, smaller or equal. Here same condition is applicable. Here only register or memory is replaced by 8-bit data. Here you can see the example. Suppose the content of A is 05 and the content of B is 06. When you have written this CMP B, means you are going to compare the content of B with A, means A minus B operation will be happen when you are going to subtract A minus B. As you know, the content here you have to take the borrow. Okay, means your carry flag is set. Means your carry flag is set means the content of accumulator is smaller than content of register. So here you can easily understand how this is going to work, and here we have taken second example. So you can pause this slide and you can easily understand. Here I have taken third. So here you can see the content of A 05. Here we are going to compare with CPI 05, means A minus 05 means 0 flag will be set, means both number are equal. Here you can see A equal to 05 and content of this is 04. When you are going to subtract A minus 04, means carry flag will be reset, 0 flag will be also reset, means the content of accumulator is larger than given content of register or memory. Now we are talking about most important instructions which comes under logical instruction, means we are talking about rotate instruction, and my request, please try to listen it carefully, then then you can easily understand how this works. Okay, so first is RRC, means each binary bit of accumulator is rotated right by one position. One thing remember, every rotate instruction work with accumulator, means you have to write only RRC, RAL. Meaning of this will that will work with accumulator by default. You have to not write anything, or even you have to not write accumulator, because the standard format of this instruction is RRC, RAR, RAL, RLC. There are 4 rotate instruction. So, here just try to understand this instruction. Each binary bit of accumulator is rotated by one position, means bit D0 is placed in position of D7 as well as in the carry flag, and carry is modified according to bit G0. So, here just see the diagram. What happened here? This is content of accumulator, not content, this is bit position of accumulator, means we are talking about bit position. This is D0 and this is D7. In second example, just you try to understand what happening. This is bit position. In case of RRC, okay, this bit, basically you have to shift one bit to the right. This bit will be shift in carry, as well this bit will shift in this position, means this is D0 and this is, then this is first time. Suppose you have written RRC, okay. Now you have written again RRC, then what happened? Here this bit already shifted, now this bit will be here, this will be here, means every bit will be shifted one by, okay. Now this bit will be here and this will be here and this will be here. Third time, okay. Now this bit will be here, here and then here, means every time you have to shift one bit, okay. Just let me explain it again, just try to listen, see the content of this. Okay, what happened first time? This will be shifting here and this will be shifting here. In this example, just see, 0 will be here, means 0, 1 here, means 1 here, and this one here, and 0 here, means that will be this. Again, here you can see 0, 1, 0, 1, 1, 0, 1, 0. So, this is process, so you can easily understand how RRC is working, and best thing is that just try to do it on a answer sheet or on a copy, so you can easily understand how this is working. Also in this case, if in examination they are not asking about carry flag, so you can neglect this. Now what happening, just look at, just see here, this is D0, D7, okay, this is here, now this is here, second time this is here, means every bit is just shifting, just here. Now see the content of accumulator is A is equal to 0.5, and you have to perform a program RRC. So let me explain it, okay. Firstly, you have to draw 8 bit, okay. 0.5 means 0, 0, 0, 0, okay, and 5, 0, 1, 0, 1. This is 0.5.
what happened first time. First time means this value will be shift here. Okay, now draw this, and this will be here. So here this value will be here 1, and shift this value by 1, 0, 0 and 0 and 0, again 0, okay, again 1 and 0. So this will be, now here you can see what happened, this will be, okay, and here you can see this is 8 and this is 2 after 1. When you are going to shift it again, now this will be here and every bit will be shift right by 1. So we will get 41. Now here you can see after writing 2 times RRC, we can get half of this number. Okay, means look at this. Okay, so this is, and this is applicable in only even number, not in case of odd number. So this is process ki how RRC is going to work. Just ignore this carry flag, because why I am saying just ignore, because we are not using this carry flag to shifting data. Okay, only what happening, we are using this. Okay, that's why I am saying you can replace. Now this is second example, you can do it yourself, so your concept will be clear ki how this is going to work. And here I have already written the answer. Okay, third, fourth, and here you can see if you are going to write this 4 times, we can find reverse of this number. Okay, so this is working of RRC, and I am requesting please try to do yourself, then you can easily understand ki how RRC is going to work. Now talking about RAR, rotate accumulator right through carry, means in this example we have to also consider the value of carry. So here you can see what happened in this type. This will be shift in carry and the value of carry will be shift here. Second time means first time what happened, this will be here and the value of here, and now everyone just shifted 1 position right. Okay, again, so here you can see what happening, the content of this will be here and this will be here and this will be here, means that will be shift 1 bit position right by using carry flag. So here you also can take, suppose here what I have mentioned, suppose the content of accumulator is A5. Okay, so let me take a pen and just I will try to explain. Question is that the content of accumulator is 05, means 0, 0, 0 and 0. 5 means 0, 1, 0, 1, this is 5, and the carry value of carry is 1. Okay, suppose you have to perform this instruction R A R, then what happen, this will be shift here and this will be shift here and every will shift their 1 position. Then what happen, new diagram, check it. Okay, here this is value of carry, because here 1 and now this will be 0. Okay, so let's check. This will be here, this will be 1, 0, 0, 0, 0 0 1 0. Now check it 8 2. So here you can see the output 8 2 means by following this method you have to basically perform RAR operation. So here you can see after one time you can find output. So now you can check this program by yourself. This I have already mentioned about the output, what will be output. First time when you are going to do RAR, you will get 82, second time C1, third time 60, fourth time B0. So you can check your concept, this is working or not. So this is up to you how you are going to check it. I have already mentioned, just put out your copy and pen and try to do yourself, and this is very easy. And if you are facing any problem regarding this, you can ask me, I will here to give you answer. Only you have to do a comment in comment box and I will explain it again. So here you can see how this is working. This is right side. Now we are talking about rotate accumulator left, RLC means here we are just doing the reverse of right. Here we are shifting the content one bit by left, means here to here, here to here. So you can see the content of this will be, the content of this will be carry flag and this will be again, and each bit will shift to the left. You can ignore this because the value of carry is not transferring here, that's why I am saying. Okay. So in this you can find out. Okay. Now you can check the example. A equal to 0 5, find the output after following instruction. Suppose the content of A is 0 5 and you have to perform RLC. Then what happened? Just let me explain it. Just let me take a pen. Firstly, you have to write 0 5 means 0 0 0 and 0, again 0 1 0 again. So this is 0 5 and you have to perform RLC. Okay, so you have to perform RLC. Means in RLC, one bit shift by left position. Okay, so check it here. Means this will be here, 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 and this will be here. Now make it. Okay. This will be here. Firstly draw 0 and this will shift one position 1 0 1 0. Okay. Now 0 0 and 0. So this will be output. This is 0 and this is A. Okay. So after performing one time RLC, you can get double of this number also. So here you can see the output, and by this method this is going to work. So you can easily try by yourself by putting by taking some copy and pen. Now this is example for you, you can say assignment for you. Just try to do it yourself, you can easily do it. Okay. Here for one 0A, second time 14, third time you will get 29, and fourth time you will get 52. So just try to yourself and you can find it. Okay. Now talking about RAL, rotate accumulator left through the carry, means here we have to also consider the value of carry. So in this example you can see here what happening. This value will be in shift in carry, and the value of carry will be shifted here, and this will be shifted by 1 bit left. So this is working of RAL. Okay. So here you can see the example. Suppose the content of A is 0.5 and the C is equal to 0.4, and you have to perform RAL. So let me explain it for you again. Firstly, you have to draw 0.5, 0, 0, 0 and 0. Okay. Here 0, 1, 0, 1. Value of carry is 0. Now what will happen? 0 will be here, and this 0 will be here, and this will be transferred 1 by left. So draw your output. 0 will be here, 0, 1, 0, 1, 0 and 0, 0 and 0. So this will be 0 and this will be A. So this is your output. So here you can see your output is 0A. Okay. So this is output, and next program for your exercise. So here what will be final output after 1 RAL? You will get 0A, 14, 28 and 50. So also by using this method you can find reverse and double, but here condition is very different. Firstly, you have to set the value of carry, then you can perform this operation. Otherwise, you have two options. One is RRC and RLC, because in those instructions we are not going to consider the value of carry. So you can use those value for find negative number, positive number, even number, odd number, double, half, whatever you want to do. So this is working of all the rotate instruction, and I hope you can got my point, and you can easily understand how this instruction will work in 8085 microprocessor. Here talking about CMA complement accumulator, means this instruction will do complement of the content of accumulator. Whatever content is available in accumulator will be complemented by using this instruction. Here you can see, suppose the content of accumulator is 9A. When you are going to perform this operation, that will be 65. What happen? 0 will be converted in 1, 1 will be converted in 0. So here you can see this is 9A, 0 will convert into 1, 0, 1 is 0. So basically this is complement. Also you can say this is example of NOT gate. Now we have CMC, means complement the carry. Basically whatever value of carry is available, when you are going to execute this instruction, that will complement it. Means if value of carry is 0, that will be 1, if value of carry is 1, that will be 0 after this operation. STC means basically this is used to set the value of carry. Means suppose the value of carry is 0, when you are going to perform STC, that will be 1. If the value of carry is 1, and if you are going to perform STC, it will be again 1. What is branching instruction in 8085 microprocessor? When we are talking about branching instruction in 8085, means we are talking about some condition. because the branching instruction alter normal sequential program flow either unconditionally or conditionally, because just branching instruction just like if else, because I think you have studied about if else in C program, C++ program, and also there are many languages in which you have already studied about if else. So you can say branching instruction is same like if else. Whenever if you want to check condition or uncondition in 8085 microprocessor, means we have to use branching instruction. So by using branching instruction, we can get desired output whatever we want to get on the basis of some condition. So there are three types of branching instructions, and these are, first one is jump, and jump is also divided in two parts. One is unconditional and second is conditional, and we have call. Call is second type of branching instruction. Call is also divided in two parts. One is unconditional and second is conditional, and return have also two parts. One is unconditional and conditional. So I am going to discuss each and every instruction one by one, and just I will give overview so you can easily understand where you are going to use conditional instruction and where you are going to use unconditional. So firstly we are talking about jump instruction, and jump instruction transfer the program sequence to the memory address given in the operand. Means this is standard format of jump. Here you can see in this instruction, here you can see jump. What happened? Transfer the program sequence to describe memory location, because if you want to move your program counter at a specific location without checking any condition, then you can use jump, and whatever address you are going to mention with jump, that program sequence will be jump at that address. Suppose here there is a program, okay, and here you have mentioned GMP, and you just given address of this data, okay. Here what happened, this program will execute sequentially, okay, and after that this will be jump at this without checking anything, because jump only jump whatever location you are going to give with jump, that will be jump at that location without checking any condition, because this is unconditional, means we are not checking any condition. But when we are talking about condition, so transfer the program sequence to the described memory address only if the condition is satisfied. Here we are not mentioning any condition, that's why the program counter will be jump at this location. But when you are talking about conditional jump instruction, means firstly you have to check the condition. If condition is satisfied, whatever address you have mentioned with that instruction, that will jump at given memory address. So here we are talking about, now this is jump instruction and conditional jump instruction. So here you can see JC means jump on carry, okay. If carry will be 1, then this instruction will be jump whatever address you have given. Suppose you have written JC 3000, okay. So this instruction firstly will check the condition of carry, okay. Carry flag will, suppose carry flag is set, means that instruction will jump at this location. Suppose this is here, okay. So this will be jump here, but after checking the condition, if condition is satisfied, then. But in case of unconditional, we are not considering any condition, okay. Second is jump of no carry. This is second, it will check if carry value is reset, then jump whatever address you have given at that particular memory location, your program counter will jump. JP means jump on positive, JM jump on minus, JZ jump on 0, JNZ jump on no zero, JPE jump on parity even, JPO jump on parity odd. So these are some example of conditional jump, and according to your program you can use any of this. And suppose if you are going to add two numbers, so definitely you are going to check carry, if there is carry or not, so you can use JC and JNC. And if you are talking about checking the value of counter, it is 0 or not, so you can use JZ, JNZ. And in case of positive or negative number, you can check JP and JM, and for checking parity you can use JPE and JPO. It totally depend upon program, in that program what you want to do. Now second type is call instruction. As we have already discussed, call has also two types. One is unconditional call instruction, second is conditional call instruction. So the call instruction transfer the program sequence to the memory address given in the operand. Before transferring, the address of next instruction after call is pushed into the stack. Call instruction are two types, unconditional and conditional. So same here you can see this is standard format to mention call, and this represent unconditionally, means if you want to call any program unconditionally by using this you can call. Suppose what happen, mostly call use when you are going to use some routine. Suppose this is main program and this is sub program, okay, sub address of this is okay, and suppose you have used call here and you just given okay, what happen, program will be execute sequentially, and after this will be jump at this unconditionally because we are not checking any condition here. But when we are talking about condition, so we have some conditional call instruction as CC call on carry. If value of carry is 1 or carry is set, then CC. CNC call on no carry, CP call on positive, call on minus, CZ call on 0, CNZ call on no 0, CP call on parity even, and CPU call on parity odd. So we have already talked about jump. So same as we can say call, because we have same instruction which we have already discussed in jump. That's why I can skip this, because you can, I hope you can easily understand. Okay, whenever you are going to call any program, any subroutine program on basis of condition, so you have to use this CC, CNC, CP, and if you want to call that subroutine without checking any condition, then definitely you can use call, means unconditional call. So it's totally depend upon your program and your requirement. Now talking about third type of branching instruction, that is return. The return instruction transfer the program sequence from the subroutine to calling program. The 2 bytes, okay, the 2 bytes from the top of stack are copied into program counter and program execution begin in the new address return. Okay, so let me discuss how return works. Okay, what happens? Just take an example of program here, and this is main program suppose, and you have written suppose you have written here call, okay, 4x, and this is subroutine program, start from 4x, and you have written some line, okay, and here you have written return, and here you have written something. Now what will happen in this program? Okay, suppose it will execute sequentially. There is no doubt, whenever program counter get call, it will jump at this location. So your counter is jump here. Now counter will execute this program sequentially. As soon as counter find return, means what happen, from here this will return here, means basically transfer the sequence from this subroutine to the calling program, because you have called this subroutine from this location. That's why after executing this, the program counter will return from here to
here, means from where you have call. Okay, so when you are talking about some conditional, so we have same which we have already discussed into call instruction and jump instruction. So we have return on carry. If in this conditional you have to check particular value, then your program counter will be jump according to the condition. If condition is satisfied, then program counter will work, otherwise no. So we have RC means return on carry, RNC return on no carry, RP return on positive, RM return on minus, RZ return on 0, RNZ return on no 0, RP return on parity even, and RPO return on parity odd. So this is all about branching instruction which we are going to use in 808 for microprocessor, and it's totally depend upon your program where you have to use a conditional and where you have to use unconditional. But if except subroutine program, mostly time we use conditional operator as like jump off now carry, jump if carry, jump if no 0. But when you are going to make a a subroutine program, so mostly we use call, JMP and return means unconditional. This type of instruction control machine functions such as halt, interrupt or do nothing. This type of instruction alter the different type of operation executed in the microprocessor, and most of the instruction operate by machine itself, and user cannot use those type of instruction. There are many instruction which just comes under machine control instruction. So here you can see these are some instruction which comes under machine control instruction. These are halt and nope, EI and DI, rim and sim, push and pop, XTHL, PCHL and SPHL, in and out. So in this video I am going to discuss each and every instruction with detail, and also you can say by considering some example and also overview. So first instruction is nope. Nope means no operation. Basically this instruction tells that there is no operation happening within the microprocessor. So no operation is performed. The instruction is fetched and decoded, however no operation be executed. Because suppose you are writing a program and if you want after this line there should be nothing happen, then you can use nope. That is no operation. Now talking about halt means halt and intermediate state means, and also sometimes people used to refer it just end the program. Suppose you have written a program and if you want to end that program, so you have to mention halt. Means what happen when you are going to write halt, the CPU finishes executing the current instruction and halt any further execution. Means after a halt you can't perform any operation. Means suppose you have written a program 5 line, in 6 line you have mentioned halt, in 7th line if you are going to write anything, that code written in 7th line that is not going to be executed, because halt means just your program is just end, and after halt your counter will be exit, and that is not going to execute further instruction. Just let me take example. Suppose you have written 4 line program and here you have mentioned halt, and again here you have written something. Okay, what happened? This will execute each and every line. Whenever program counter will get halt, means from that position your program counter will be come out, means this line will be not executed. So this is use of halt. Okay, now we have 2 instructions जो mostly used for enable and disable. So DI used to enable interrupt and DI used to disable interrupt. DI used to disable interrupts and EI used to enable interrupts. So all the interrupt except tap or disable when you are going to use DI, and in case of EI, all the interrupts which are available in 8085 microprocessor will be enabled by using this simple instruction. So we have rim and sim. Rim means read interrupt mask and sim means set interrupt marks. So this is a multi-purpose instruction used to read the status of interrupt. By using rim instruction you can read the status of all the interrupt which is present within the microprocessor. As you can take example as like 7.5, 6.5, 5.5, and the read serial data input bit. The instruction load 8 bits in the accumulator with the following interpretation. Actually, whatever instruction we are discussing in this, mostly instruction works with accumulator by default. And sim means set interrupt mask. This is multi-purpose instruction and used to implement the 8085 interrupts and serial data output. So basically, you can see RIM is going to work for input and sim is going to work for output. Now, this is a very much important instruction under the machine control. This is push. RP means register pair. So you can use push with register pair like BC pair, HL pair, DE pair, and also you can. Okay, basically you have to use register pair. Now just discuss what is push. Push instruction is used to store data in stack. Basically push and pop. There are two instructions work with stack. A register pair is always specified with push instruction as a push B, push D and push H. Basically first letter of register pair is written with instruction. Suppose someone is written push B, and as we know push is work with 16-bit data, that's why B represent BC pair, D represent DE pair and H represent HL pair. The content of register pair specified in the operand or copied into stack. The stack pointer is decremented and the content of higher order register in pair such as D and B in BC pair are copied into stack. Okay. The stack pointer is decremented again and the content of lower orders, means your stack pointer is going to decrement two times. First time stack pointer will decrement to load value in D, and second time the content of lower order register, and in second time that is going to work with lower order. So here you can say the just I have chosen the example. You can see LXI SP and 2605 means this is value of stack pointer. LXI B 2550, this is a memory address, or you can say the data is stored in the BC pair, means B is stored 25 and C is stored 50. Here this is value of higher address, this is value of lower address. If you are talking about B, that represent BC, means B is stored 25 and C is stored 50, and this is value of stack pointer. Then what happen when you are going to execute push B? So what happen? Firstly, SP is initialized. So I think I have already told, and this is okay here. Now push instruction will be executed. The stack pointer will be decremented by 1. Okay. Then now it will become 2604, and the content of B will be copied at memory location this. Okay, means here 2604 and here 50 will be 25 will be copied. Higher bit again it will be decremented, when 2603, and here the content of lower address or lower byte will be copied, means 2050. So basically this is working of push. So this is simple example. By this example you can understand. Now talking about pop. Pop is just opposite of push. What we have discussed in push, this is just opposite. Pop instruction used to retrieve data from the stack, where we are inserting the data in the stack. Here we are retrieving the data from the stack. A register pair is always specified with pop instruction as like pop B, pop D and pop H. The content of register pair specified in the operand or copied into the stack. The content of topmost location of stack or copy into lower register such as C, BC, ED. Okay, so here what happen in push, your stack pointer is decremented by 2 times. Here stack pointer is going to increment by 2, and first data first memory location that will be copied into lower register and second will copy into higher register. So here you can see the example. Suppose the value of SP is FE and the content at this location is 10 and this is 10. What happen when you are going to execute pop? Okay, so see here, you can see what happened. First time value will be incremented, okay, and the content of this location will copy at H, means talking about lower byte, and again this will be incremented, and that copy of that data will be copied into H, because here finally we get stack pointer, value of stack pointer is 2300. Why? Because when you are going to add FE plus 1, we will get 2020 FF. Again, if you are going to add, we will get 23. Okay, and the data at this location will copy into lower byte, and the data this will be copied into H. So this is simple, and this is just reverse of push. Now talking about XTHL, this instruction exchange the content of memory location pointed by stack pointer with the content of L register and the content of next memory location with the content of register H. So here you can see the example, if the content of HL is 5601 and the value of SP is 2000. Okay, so by executing this, and the content at 2000 H is 30 H and 2001 is 20 watts. So when you are going to execute XTL, this instruction will scan the content of memory location, means we are talking about 2000 30 H with the content of L, means by 01 here, and the content of next memory location, means that is 20 H content with the content of 56, means this content will be exchanged with this, and this will content will be exchanged with this. So this is working of XTHL, and so here you can see the example. Okay, so here by using this picture, by looking at this picture, you can easily understand how stack input how XTHL is going to work with the memory location. Now talking about last instruction of machine control, one is SPHL. SP means stack pointer, HL means HL. As we know, this instruction copies the content of HL register pair to the stack pointer, means here we are going to copy the data of HL into stack pointer. Okay, so here by looking at this example, you can easily understand. Suppose the content of HL is 2030, then what happen? SPHL, this instruction will copy 2030H into SP. So SP will point the memory location 2030, means we are just transferring the data of HL into SP, you can say, or just you can say we are going to make memory location whatever HL is containing, and that will be assigned, that value will be assigned to SP, and the address will be, stack pointer will be 2030H. So here you can see this instruction copies the content of HL register pair to stack pointer. This is very simple. And when you are talking about PCHL, PC means program counter, HL means HL. So here load program counter with HL content, means the content of register H and L are copied into the program counter, and the contents of H are placed as the higher address byte, and the content of L has been lower byte. So this is very simple instruction. And when we are talking about output, so output data from accumulator to a port with 8-bit address, because out and in instruction generally works with 8-bit data, and by default works with accumulator. You can say you can store the value of accumulator at output port, and also the value of output port you can move into accumulator by using same instruction, move a comma b. So you can write move comma out, move comma in. So that is work fine. Output data from accumulator to a port with the 8-bit address, the content of the accumulator are copied into the input output port, and here in case of input data to accumulator from a port with 8-bit address, the content of the input port designated in the operand are read and loaded into the accumulator. So here in case of out, we are fetching the data from accumulator. In case of in, we are inserting data in accumulator. So my friend, these all about machine control and stack input output control in 8085 microprocessor. So in this lecture I will cover basic concept. By using that you can draw timing diagram of any instructions. Okay, so here what is meaning of timing diagram? So it is one of the best way to understand the process of microprocessor, how microprocessors working and how the instruction is queued within the microprocessor. And with the help of timing diagram you can understand the working of any system step by step, working of each instruction and how that instruction is going to execute within the microprocessor. So by using timing diagram we can understand each and everything, and basically it is a graphical representation of process in steps with respect of time. So the timing diagram represent the clock cycle and duration, delay, content of address bus, data bus and type of operation, read, write, signal. Means timing diagram with the help of graph is going to represent everything which is required to know us about any instructions. So here there are some important terms which are used in timing diagram. First one is instruction cycle. So this term is defined as the number of steps required by the CPU to complete the entire process. Means entire process means executing the one instruction. Whatever number of steps required, that is called instruction cycle. You can take fetching and execution of any instruction, that comes under instruction cycle. So basically this gives number of steps to required by CPU to complete the process of any instructions. Now machine cycle, it is time required. Okay, in first we are talking about number of steps, here we are talking about time. It is the time required by the processor to complete the operation of accessing memory device or input output device. Means how many time microprocessor is going to take to complete the operation which is accessing the memory device or input output device. So if you are talking about 8085 microprocessor, so there are many operations which belong to machine cycle as like opcode fetch, memory read, memory write, input output read, input output write, and these are operations basically performed within machine cycle. And talking about T state, each clock cycle is called T state. So in next slide, means in this slide we can know more about T state. So T state may be defined as the time taken by the clock to complete one period. Here we are talking about one period. So how many time microprocessor is going to take to complete one period is called T state. To perform a particular task by a programmer on a computer, a programmer writes a set of instructions and called program and data are stored in the memory. Okay, and how microprocessor is going to perform? Basically microprocessor fetch one instruction from memory at a time and execute, then again fetch second instruction and then execute. So here how you can measure the T state? So here in this diagram you can see a T state is measured from the falling edge. So here we are talking about falling edge of one clock plus to to next falling edge. So here you can see from here to here, this is called one T state because we are talking about falling edge. So here falling edge and this is falling edge. So this is called T state. Now instruction cycle can be defined as time taken to complete the instruction, we have already discussed about. And when we are talking about instruction cycle, so instruction cycle contain two things, one is fetch cycle and execute cycle, and both combinedly going to make a instruction cycle. Means instruction cycle contain fetch cycle as well as execute cycle. When you are going to combine fetch and plus execute, that represent complete instruction cycle. So, now talking about fetch operation, because in this slide you can see we are talking about fetch cycle and execute cycle. So, here we are going to discuss what is basically meaning of fetch operation. Okay. So, when we are talking about fetch means we are going to retrieve data. So, the first byte of any type of instruction is the opcode, whatever instruction you are going to take. Just I am taking an instruction. So, for easily you can understand, suppose I have taken an instruction MVI and A05, and this is 2 byte instruction. By previous by following previous my video, you can easily know how you can define this instruction in 1 byte, 2 byte or 3 byte. So, here if we are talking about first byte, so first byte of any instruction is opcode. So, here we are talking this is first byte and this is opcode, and second byte and third byte is operand. So, in this instruction 05 is operand. The PC keep the address of next instruction, means whatever instruction you are going to, suppose you have written 2000 MVI. So, PC always contain the address of that instruction which is going to execute. In the beginning of fetch operation, the content of program counter, which is address of the memory location where opcode of instruction is stored, is sent to the memory, and the memory places opcode of that instruction on the data bus. So, is transferred to CPU, and this is called fetch operation. Basically, in fetch operation we have to fetch data from the memory. Okay. So, here you can see what happened. To fetch an opcode an instruction, 3 clock cycle are required. If you are going to talk about fetching operation, so this is compulsory, we require 3 clock cycle. So, here you can see there are 3 clock cycle. So, and if you are talking about a slow memory, so maybe your clock cycle can be increased. So, yes, slow memory may take more time. In the case of slow memory, the CPU has to wait till the memory send the opcode, the clock cycle. Okay, so here you can easily see how opcode fetch operation is going to work within the microprocessor, that is send address to memory, and memory gets opcode from the memory location and transfer opcode to CPU. So, this is first cycle. In first cycle, send address to memory, this is going to happen. In second, memory get opcode from the memory location and transfer that opcode to CPU, and by using this process opcode fetch operation is going to happen in microprocessor. So, execute operation, now we are talking about executing any instruction. Firstly, your instruction will be fetched from the memory and then execute will be happen, means execute followed by fetch operation you can say. After the opcode of an instruction fetched from the memory, the execution begins. Okay. The opcode fetched goes to the data register and then it goes to instruction register. From the instruction register, it goes to the instruction decoder, which decode the instruction and tell the microprocessor which type of operation you have to perform. And after a decoding of the instruction, the task specified in the instruction is carried out, and this is called execute operation. Means that execute operation is going to happen in CPU. Firstly, microprocessor has to fetch data from the memory, and that will go to data register transfer the data into instruction register, and instruction register transfer the data in decoder, and decoder basically decode that information and decide which type of operation microprocessor has to perform. So, by using control signal, they pass control to microprocessor, and microprocessor perform the operation according to that signal. Okay. And that is called execute operation. Now, when we are talking about how execute operation is going to happen on instruction, if you are talking about 1 byte, 2 byte, 3 byte, and okay. So, here in 1 byte instruction, the operand is a general purpose register, and opcode and operand are specified by 1 byte, means this type of instruction going to take only 1 byte, or you can say only one memory location. Though the execution of 1 byte instruction is immediately performed, the time taken in execution is 1 clock cycle. Okay. And in case of 2 and 3 bytes, so we required 2 memory location. Okay. So in the 2 byte or 3 byte instruction which contains data or address which is still lying in the memory, the CPU perform the read operation to get the desired data. After receiving the data, is perform the execute operation, and a read operation is similar to fetch operation because we are reading the data, not inserting. When we are talking about inserting data, means we are talking about writing the data. So firstly you have to fetch the data from the memory and then you can perform you can say then microprocessor is going to perform any operation. Now talking about read operation, so here we are talking about fetching the data, you can say in a very layman language. In the read operation, the quantity received from the memory or data or operand address, whereas in the case of fetch operation it is opcode. Okay. And some instruction the write operation is performed, means in the write operation data are sent from CPU to the memory. In just see what is difference between read and write. Basically in read we are accessing data from the memory, in write we are sending data to the memory, means in read we are fetching the data and in write we are inserting the data in memory. So this is okay. Now basically the 8085 microprocessor has 5 basic machine cycle. One is opcode fetch machine cycle, memory read machine cycle, memory write, input output read cycle, input output write cycle. And if you understand the concept of these 5 machine cycles, so you can draw any diagram of any instruction. Okay. And now there is some rule, so how you can identify how many number of machine cycle is required. Okay. If addressing mode is direct, immediate or implicit, then number of machine cycle equal to number of byte, means we are talking about instruction. So suppose any instruction that has only one machine cycle, means you are going to draw only opcode fetch. If there are 2 machine cycle, then you are going to draw opcode fetch and a memory read cycle. And if there are 3, so you have to check first one will be opcode, maybe there should be 2 memory read or 1 fetch, memory read and write. Is totally depend upon the instruction how that instruction is going to work and what is basically working up that instruction. By assessing the concept of that instruction, you can find how many machine cycle that instruction required, and when you define the number of machine cycle, then you can draw your timing diagram. Okay. So in this next slide we are going to discuss opcode fetch cycle, memory read cycle, memory write cycle, input output read cycle and input output write cycle. So you can easily and draw, and also here there is some rule you can follow this. These rule are now 100% correct, but at least it is applicable for 80% of instructions. Okay. So now talking about opcode fetch machine cycle. Okay. And there are 3 to 4 things you have always remember. One is input output memory, ALE and clock, F15, 8. These are some 5 to 6 signal which we are going to mention in every timing diagram. Okay. So here if you are talking about opcode fetch, so these are some rules which is fixed, and during when I taught you pin diagram of 8085 microprocessor, I have already discussed about this. Okay. Basically the value of this is going to tell us which operation currently microprocessor is performing, means that is opcode fetch, memory read, memory write, something like that. Okay. So here during when we are talking about opcode fetch machine cycle, so we require 4 T state. So here these are 4 T state, and already we have discussed how you have to draw the T state by falling edge to next falling edge. Okay. This is one T state. So I think there is no problem to draw T state. Okay. And this is clock. Now talking about during the T state, microprocessor uses input output memory bar S0 S are used to instruct microprocessor to fetch. It means this value of this is telling okay, this is code fetch operation is going on. Then how you have to draw for every instruction, you have to draw as like this, just provide and just write the value of this. So, this is going to tell which operation microprocessor is performing. In suppose you are going to draw a second machine cycle, that is read. So, the value of this will be changed. Okay. So, value of this is going to tell us yes, this is opcode fetch or read or write. Okay. During this operation 8085 transmits 16-bit address and also uses ALE signal for addressing latches, because in the first T state it will be high, because it always tells about the address, means in first T state microprocessor is going to fetch the address, or you can say the data from the memory location. That is why ALE is high signal. Okay. In this state, now we are talking about 2 and 3. In this state microprocessors also check the ready, because in first state this is not going to do anything. That is why its high is high, means it read is 0, because here read bar is mentioned, here read signal is 0, but in second and third it is going to perform read operation. That is why here you can find this is high. Okay. And when you are talking about T4 state, so at T3 microprocessor read opcode and store in the instruction register to decode it further, and during 2/4 microprocessor perform internal operation like decoding, opcoding, provide necessary action. So, basically you have to draw read in 2 and 3. In first here we are mention read bar, that is why it is high, means read operation is 0, because in first state just remember only operation related address is going to happen. Okay. And now talking about here, so by using this you can mention higher address, this is unspecified and this is represent low address. Here you have to give opcode. Just I will take example of one instruction. So, by that instruction you can easily understand what you have to mention here. Okay. In same, this is about memory read, and memory read have only 3 T state. Okay. T1, T2, T3. So, we have already discussed about T state and clock, and this is you have to give write memory address. Here ALE in T state is going to work with address, and this is for lower address and data from the memory, and this is for representing yes memory read operation is happening. Here we have already discussed this will be 0, because in the first state we are not doing nothing, means we are doing nothing, and here it is high, means we are doing read operation in T state 2 and 3. In same case of write, so here in when you talk about T state 2 and 3, we are write signal is high, means we are doing write, and this is same, this is same, this is same, and this will change, because you have to check the value of S0 and S1, and this is going to tell us which operation microprocessor is performing. And in same case input output read cycle. So, I have already discussed about opcode fetch and write read, same as you can see it, and also you can read, and also you can easily understand. So, without wasting your time, just let me take the example of A instruction, so you can easily understand. Here just I am going to discuss about there is an instruction that is move B, C, and this is a 1 byte instruction. So, we require only one machine cycle, and in one machine cycle, that is basically opcode fetch machine cycle. In opcode fetch machine cycle we have 4 T state. So, here let me discuss it. So, here 4 T state already mentioned, and from falling edge to falling edge, first this represent 1 T state. So, I think there is no any problem. Okay. Now, question is that this instruction is stored at 2000, means that is as like this: move 2000, move and B comma C. So this is your instruction. Okay, here we have already discussed. Okay, the value of this is going to tell us which operation is performing. So here we have to provide the value of fetching, because we are discussing about fetch machine cycle. And about read and write we have already discussed. In fetch means we are only reading the data, so that's why read is high, and we are not writing any data, that's why in whole period this is low. I think there is no problem in this, in this. And first T state it will be high, because we have already discussed in first T state we assess the content of memory address, or you can say we work with memory address, or microprocessor basically work with microprocessor. So I think in 4 and 5 signal you have no problem. Now talking about A15 to A18, so we have to give here high address. So when we are talking about this address means 2000. Okay, so this is high address and this is low address. So provide here high address 20h, no problem. Here we are providing low address, and this is opcode of move BC. So here you have to provide opcode of BC. So this is very simple how you can draw timing diagram of any instruction. So let me discuss it again. Okay, and move, this is 1 byte instruction, means it will contain 1 machine cycle. 1 machine cycle means opcode. Fetch machine cycle means we are reading the data, that's why here read will be high, we are not writing, that's why it will be low. And in first T state microprocessor work with address, that's why it is low. Why I am saying low? Because we are talking about read, and here we have to provide the value of input output S1 S0 that is applicable for opcode. So there is no problem. In first T state TL ALE will be high, because we are discussing about address. Here from following edge to next following edge, so these are 4 T state, no problem. Here you have to provide higher address, so in this case 20 is higher address, here no problem. Here we have to give low address, so here 00 is low, and opcode of this is move BC 41. So this is all about the timing diagram. Basically what happened in 8085 microprocessor, every instruction has 2 parts. Suppose I am writing any instruction move A comma B. So basically every instruction has 2 parts. One is opcode, second is operand. Opcode means which operation you are going to perform, and operand means on which you are going to perform. So in this case you can see that this move is just you are going to copy from source to destination. So these are operand or these are opcode, both combined called mnemonics. Hope you have heard this term mnemonics. Or this is a complete instruction. In instruction there are 2 parts. One is opcode, OPCOD, second is operand. So opcode means which operation you are going to perform, operand means on which you are going to perform. So basically this is basic difference between these 2 terms. Now if you are talking about any instruction, so the operand, that is also can be source, that is also can be destination. The source can be a register, a memory address, a memory, a input output. Same as destination can be same as like register, memory address, or something like this. So basically what happened there are many various format to specify operand with a instruction opcode. So the different technique of specifying data are called the addressing mode. Addressing means how you are going to represent the operand within any instruction. So that process is called addressing mode. Suppose there are some instruction STA 2000. If you are talking about this, so this is operand. कि हाउ वी आर गोइंग टू स्पेसिफाई ऑपरेंड विथ ए इंस्ट्रक्शन दैट प्रोसेस कॉल इज एड्रेसिंग मोड। तो इन इजी लैंग्वेज कहने का मतलब है कि एड्रेसिंग मोड बेसिकली होता क्या है कि हम ऑपरेंड को ऑपकोड के साथ कैसे रिप्रेजेंट करते हैं, दैट प्रोसेस इज कॉल्ड एड्रेसिंग मोड्स। In 8085 microprocessor there are 5 addressing mode. One is immediate addressing, second one is register addressing, third one is direct addressing, and fourth one is indirect addressing, and fifth one is implicit addressing. Basically these are type ki how you are going to represent a data or operand with a opcode. So in this video I will discuss every addressing mode with a example to make you understand ki how addressing work in 8085 microprocessor. So let's start from first addressing mode, that is immediate addressing. Now what is meaning of immediate addressing? In the immediate addressing mode, the operand or data is present within the instruction. Load the immediate data to the destination which is given in the instruction. Basically कहने का मतलब है, एक तो तरीका होता है कि इमीडिएट एड्रेसिंग आप कैसे पहचानेंगे। अगर कोई भी इंस्ट्रक्शन है उसमें अगर आई मेंशन है लास्ट, तो समझ लीजिए कि वो इमीडिएट एड्रेसिंग को रिप्रेजेंट करेगा। और इसमें क्या होता है, विद इन इंस्ट्रक्शन डेटा ऑपरेंड गिवन होता है। जैसे हमने लिखा MVI-A05 मीन्स हियर इज आई दैट रिप्रेजेंट इमीडिएट एड्रेसिंग। ये बेसिकली पहचानने का तरीका है, लेकिन जो डिफिनेशन है इन द इमीडिएट एड्रेसिंग मोड द ऑपरेंड या डाटा इज प्रेजेंट विद इन द इंस्ट्रक्शन। हमने एक लिखा LXI H2050 आई है मीन्स ए भी रिप्रेजेंट करता है। CPI हमने लिख दिया, सपोज CPI B, दिस इज ऑल्सो रिप्रेजेंट इमीडिएट एड्रेसिंग मोड। और ऑपरेंड कैन बी डेटा, कैन बी रजिस्टर, कैन बी मेमोरी एड्रेस, ऑलरेडी आई हैव टोल्ड इन द बिगिनिंग ऑफ दिस वीडियो। So this is example of basically immediate addressing mode. Suppose I am writing ADI05H. This is I, means I represent immediate addressing mode. Same moving forward, second is register addressing. देखिए रजिस्टर एड्रेसिंग मोड में क्या होता है कि जो भी वर्क होता है ना वो विद इन रजिस्टर होता है। मीन्स आपका सोर्स कर सकते हैं, डेस्टिनेशन ऑपरेंड बेसिकली रजिस्टर होता है। जैसे हमने लिखा ऐड C मूव A, B सब B। तो बेसिकली देख सकते हैं कि इन इंस्ट्रक्शन में कहीं भी एक भी डेटा या सेक्शन भी डेटा नहीं आ रहा, सिर्फ आ क्या रहा है, रजिस्टर। तो दिस टाइप के एड्रेसिंग मोड्स ओनली वर्क्स ऑन register. In the register addressing mode, one of the register A, B, C, D, E, H and L can be used as a source of operands. तो आप देख सकते हैं कि ये जो C है एज ऑपरेंड काम कर रहा है, A और B भी ऑपरेंड काम कर रहे हैं, डेस्टिनेशन भी काम कर रहे हैं। यहाँ पर देखा जाए तो ये डेस्टिनेशन है, ये सोर्स है, यहाँ पे सोर्स है। तो बेसिकली क्या होता है रजिस्टर एड्रेसिंग मोड में जो भी हमारे रजिस्टर हैं 8085 माइक्रो प्रोसेसर में, दे कैन वर्क एज डेस्टिनेशन एज वेल एज सोर्स। Now moving forward, our third, that is direct addressing. In direct addressing, the address of operand always exists within the instruction. This mode can be used to read data from the output device and store in the accumulator or write the data content of the accumulator to the output devices. Basically this is a basic definition. In this addressing mode, the address of operand always given within the instruction. Means there are some example 00H, STA 2000H, LDA 2000। तो basically these are example of direct addressing, क्योंकि इसके साथ एड्रेस ऑलरेडी गिवन है, चाहे हम इनपुट आउटपुट की बात करें, चाहे एसटीए की बात करें, चाहे एलडीए की बात करें। तो बेसिकली ये हमारा डायरेक्ट एड्रेसिंग को रिप्रेजेंट करता है। उसके बाद आते हैं इनडायरेक्ट एड्रेसिंग। इनडायरेक्ट एड्रेसिंग, इनडायरेक्ट एड्रेसिंग में बेसिकली क्या होता है, इनडायरेक्ट एड्रेसिंग की अगर बात करें तो इसमें क्या होता है कि इन द रजिस्टर इनडायरेक्ट मोड द कंटेंट ऑफ स्पेसिफाइड रजिस्टर आर यूज्ड टू स्पेसिफाई द एड्रेस ऑफ द ऑपरेंड। कहने का मतलब है इस एड्रेसिंग मोड में क्या होता है कि जो भी एक रजिस्टर गिवन होता है वो उसके एड्रेस को रिप्रेजेंट करता है। जैसे आप इसकी बात करें LDX B, STX B, अगर इन दोनों की हम बात करें तो इसका मतलब क्या है कि इन दिस इंस्ट्रक्शन द कंटेंट ऑफ मेमोरी एड्रेस विच इज स्पेसिफाइड बाय BC पेयर विल बी स्टोर इन एक्यूमुलेटर। कहने का मतलब है कि ये जो BC पेयर है बेसिकली एक एड्रेस को कंटेन करता है, जिसको हम बोल रहे हैं इनडायरेक्ट एड्रेसिंग। बेसिकली क्योंकि इसमें एड्रेस गिवन नहीं है, ये इनडायरेक्टली एक एड्रेस को रिप्रेजेंट कर रहा है। इन दिस केस क्या होता है कि कंटेंट ऑफ एक्यूमुलेटर विल बी स्टोर्ड एट मेमोरी एड्रेस विच इज स्पेसिफाइड बाय BC पेयर। मीन्स कहीं ना कहीं हमारा एड्रेस है जो हमें डायरेक्ट दिख नहीं रहा है, वो इनडायरेक्ट है, या कह सकते हैं कि हाइड है। तो बेसिकली दिस टाइप के एड्रेसिंग मोड दैट इज कॉल्ड इनडायरेक्ट एड्रेसिंग। लास्ट वन इज इम्प्लिसिट। इम्प्लिसिट addressing. In this addressing mode of certain instruction can be implied by the instruction function. Actually these instructions work on the content of accumulator and there is no need of address of the operand. कहने का मतलब है इसमें वो इंस्ट्रक्शन आते हैं कि जो डायरेक्टली एक्यूमुलेटर पे काम करते हैं, इनमें कोई भी ज़रूरत नहीं होती किसी रजिस्टर को मेंशन करने की या एड्रेस को मेंशन करने के लिए। तो दो इंस्ट्रक्शन और कॉल्ड इम्प्लिसिट एड्रेसिंग मोड। जैसे एग्जांपल लेते हैं CM में कॉम्प्लीमेंट ऑफ द एक्यूमुलेटर, कोई ज़रूरत नहीं है कोई भी ऑपरेंड या रजिस्टर मेंशन करने की। जैसे D डेसिमल एडजस्ट एक्यूमुलेटर, CMA हो गया। STC की बात करें, RAL की बात करें, RLC की बात करें, RAR की बात करें, तो बेसिकली दीज आर एग्जांपल ऑफ इम्प्लिसिट एड्रेसिंग मोड। बेसिकली क्या होता है कि ये बाय डिफ़ॉल्ट एक्यूमुलेटर पर काम करते हैं, इसमें कोई ज़रूरत नहीं है कोई एड्रेस मेंशन करने की या रजिस्टर मेंशन करने की, क्योंकि एज यूजुअल है खुद एक फंक्शन होते हैं या खुद इम्प्लाइड होते हैं दिस टाइप एड्रेसिंग मोड। तो बेसिकली फ्रेंड्स दीज आर 5 एड्रेसिंग मोड विच आई ऑलरेडी डिस्कस: इमीडिएट एड्रेसिंग, रजिस्टर एड्रेसिंग, डायरेक्ट एड्रेसिंग, इनडायरेक्ट एड्रेसिंग और इम्प्लिसिट एड्रेसिंग। यहाँ से आप देख सकते हैं कि इमीडिएट एड्रेसिंग मैंने आपको पहचानने का तरीका बताया कि जिस भी अगर कोई इंस्ट्रक्शन दिया है उसमें आई है मीन्स दैट रिप्रेजेंट इमीडिएट एड्रेसिंग। अगर हम बात करें रजिस्टर एड्रेसिंग की तो बेसिकली दिस आर इंस्ट्रक्शन वर्क्स विद इन दी रजिस्टर। कोई ना कोई एक रजिस्टर आपको जरूर गिवन होगा, चाहे ऐड C हो चाहे मूव AB, C हो, जो भी एग्जांपल यहाँ पे दिए हैं। उसके बाद मैंने बताया था आपको डायरेक्ट एड्रेसिंग। डायरेक्ट एड्रेसिंग में क्या होता है कि जो भी इंस्ट्रक्शन होता है उसके साथ एक एड्रेस गिवन होता है, वो 8 बिट का एड्रेस हो सकता है या 16 बिट एड्रेस हो सकता है। इनडायरेक्ट एड्रेसिंग मैंने आपको बताया था कि जो भी हमारा रजिस्टर पेयर गिवन होता है वो इनडायरेक्टली किसी न किसी एड्रेस को रिप्रेजेंट करता है, दैट इज कॉल्ड इनडायरेक्ट एड्रेसिंग। लास्ट वन इज इम्प्लिसिट एड्रेसिंग। इम्प्लिसिट एड्रेसिंग बेसिकली इसमें वो इंस्ट्रक्शन आते हैं कि जो डायरेक्टली एक्यूमुलेटर के साथ काम करते हैं, इसमें कोई एड्रेस की जरूरत नहीं पड़ती, ना किसी एक अदर रजिस्टर की जरूरत पड़ती है।
Machine code or language that is written in form of bit or hexadecimal, that is called machine code or machine language. A computer programming language consisting of binary or hexadecimal instruction which a computer can respond to directly is called machine code. Means when we are talking about microprocessor, whatever we are going to do, we will do in form of bits. Actually if you see my last video, in video I have already discussed कि microprocessor take input in form of bits and that pattern of bits is called machine language, and that machine language microprocessor can understand. Now 8085 microprocessor uses a total of 246 bit pattern to form its instruction set. Instruction means a command which is given to microprocessor to tell which operation the processor has to perform. Here this 246-bit patterns represent only 74 instructions. Why? Because most of instructions have multiple different format. And you know what happens, sometimes it is very difficult to enter the bit pattern correctly, so they are usually enter into the hexadecimal instead of binary. When we talk about microprocessor, we are going to do everything in form of hexadecimal number. And suppose you have to enter any number, suppose you have write 05, that will consider as hexadecimal in processor. For representing decimal number, you have to write 05D. D means decimal. And if you have write 05H, that will consider as hexadecimal, and you have written 05, that will also consider as hexadecimal number. But when you are going to represent different form of number, then you have to mention as like D. Okay. Now, for example, just I am giving an example. There is an example you can see here is written 0011 and 1100. Meaning of this is increment the content of accumulator. This is very easy to machine to understand what is meaning of that. But for a programmer, for a third person, it is not easy to understand what is meaning of this. Then they converted this bit pattern in hexadecimal. This is hexadecimal of that number. This is somewhat you can say easier compared to this. This is 3C. But when we talk about what is meaning of 3C, means it is still difficult to understand what is meaning of 3CH. Then to remove this type of confusion, this type of difficulty, so each company define a symbolic code for the instructions. These codes are called mnemonics, and the mnemonics for each instruction is usually a group of letters that suggest the operation to be performed. Now, taking same example here, this is 00111100C, means the hexadecimal of this bit pattern is 3C, and this symbolic code of this 3C is INR. Now, if we look at this pattern, 3C is much easier compared to this bit pattern to enter. Now this is much easier to understand what is meaning of that. If we are talking about INR represent increment, A means register A, or you can say accumulator. The meaning of this is increment the content of accumulator. Now we can say this is much easy compared to this one to understand what we are going to do. So basically this is called symbolic code, sometimes it's called mnemonics, and this is the program written in form of mnemonics, that is called assembly language program. So basically in microprocessor we are going to do program in form of assembly language. Now here INR is a much easier to understand compared to 000 and 3CH. Now just I am taking a second example. Here you can see there is a bit pattern 1 and 7 times 0 that represent 80 in hexadecimal, and that represent in mnemonics, that is add B. Add means addition, B means register B. Means what will do this instruction? This instruction will do add the content of register B with the accumulator and store output in accumulator. So means add B is much easier to understand compared to this bit pattern, and this is part of assembly language. Now it is important to remember that a machine language and its associate assembly language are completely machine dependent. In other words, the code written in a microprocessor is not transferable for others. For example, Motorola has 8-bit microprocessor that is called 6800, or the 8085 machine language is very different from 6800, so the assembly language also will be different. and a program written in 8085 microprocessor cannot be executed on the 6800 and vice versa. Now, the language written in form of letter or English like language is called assembly language, which I have already discussed. INR A, add B, basically this is a part of assembly language, because that symbol or that code is written in terms of letter or English like language. Now, a assembly language implements a symbolic representation of machine code. Your CPU does not execute assembly, the assembler converts into machine code, and this process depends upon both the particular assembly language and the target computer architecture. Now, today assembly language is still used for direct hardware manipulation, access to specialized processor instructions, or to address critical performance issues. Typical uses are device drivers, low-level embedded system, and real-time system. Now, the main difference between machine code and assembly language is that machine code is a language consisting of binary that can directly be executed by computer, while an assembly language is low-level programming language that requires a software called an assembler to convert into machine code. And the symbolic programming of assembly language is easier to understand and saves a lot of time and effort of the programmer. It is easier to correct error and modify program instructions. Assembly language has same efficiency of execution as the machine level language, and this is assembler here source code which we are going to provide in assembly language that will convert into machine language, and that machine language will save in memory of microprocessor. Now, instruction is just like a command to given to the computer perform a specified operation on a given data. Every instruction has two parts, opcode and operand. Opcode means which operation you are going to perform, operand means which you are going to perform. Just you can take example of INR A. INR means you are going to increment, that is opcode, on which means A is operand. In second example, add B, add addition is that operation you are going to perform, that comes under opcode, and on B that comes under operand. INR, here you can see the now register. There are mainly 8 registers, 8 register used in microprocessor to store the data. One is accumulator, flag register, and B, C, D, H, L. And just I am giving overview on this. In my theory classes you can learn more about this register. Here you can see in bracket there is mentioned 8, means this register is going to store only 8-bit data. Here SP16 that will store 16-bit data, program counter that will store 16-bit data, and flag register only tells the status after any operation you perform. The condition and the value of flag register depend upon the content of accumulator after performing the operation. Now, already I have discussed this, and yes, I have discussed. Now, yes, one point I just left. Suppose in 8085 you want to store 16-bit data, then there are 3 possibility of register pair. By making a register pair, we can store only 3 possible register pair. One is BC, DE, HL. BC, DE, HL means B will store 8-bit, C will store 8-bit. Both can store 16-bit data. And when we are talking about register pair, the first content will consider as higher byte, and second content is considered as lower byte. Accumulator is called special purpose register because it store input, also is store output by default, and none operation can be performed without using accumulator. Means for any operation one data should be in accumulator. Now, whenever an operation is performed in microprocessor, the status of flag depends on its output, and it is 8-bit register in which 5 of the bits are used to represent the status, and these are In theory classes, I will discuss in detail what is sign flag, zero flag, auxiliary carry, parity flag, and carry flag when they are set, when they are become reset. So I will discuss in theory classes because it will take at least one class to discuss. So, and we have no time. I have to tell you what is standard way to write a program. So just moving towards the program. Now here, just we are talking about a program. We have to write a program to add A and B where the content of A is 05 and B is 0 phase. So there are some steps you must to follow. First one is load the data in register A, and second data in register B, and add and B, store the result and end the program. So how to load? So MVI is an instruction which is used to store the data in a given register. Suppose here I have mentioned MVI A, 05 means you are going to load 05 in register A. MVI B means you are going to load 05 in B. MVI C means you are going to load data in C. Here second is MVI B. Now add and B. Here I have written add B. Add B means you are going to add A plus B, and this instruction will store the output by default in accumulator. Suppose here written is add C. Add C means A plus C. Add D means A plus D, add A means A plus A, and by default that will store the output in accumulator here and the program. Same here, add B and C. Oh sorry, actually I just forget to mention and I will correct this. Okay, so firstly load data in B, C and move a data in register A, because why? I have already mentioned that without using accumulator you can't perform any operation in microprocessor. One data should be in accumulator, but in this case no data in accumulator. So firstly you have to move a data in A, either B or C. Now add B and C and store result. Now talking about the program, so here MVI B, MVI C. Now move A comma C. This is a standard format. Move is used to copy data from destination to source register. It will copy the data, not move. So don't be confused about this. Means when I written move A comma C means after execution of this instruction the content of C will be 06 and the content of A will be 06 also, because that will going to copy the data, not moving. Okay. Now add B. Add B means A plus B. Here you can see data of A is data of C, means indirectly we are going to add B plus C and the result. This is a program. When we are talking about a standard program, then we require three things. One is memory address, mnemonics and remarks. Okay. Now same program, and you can see here this is a standard way to write a program. Here memory address, we are talking about memory address means by default the value of program counted is 0, and when I have written this 2000 means at that time the value of program counter is 2000, and that represent this is a location from where you are going to write your program. So in any time if you require to see data, so by assessing this location we can find data, which type data are stored on this location. Now here is mnemonics. Mnemonics means that instruction which are passing, and here comments. Comments means in which line what you are going to do, and here you can see after 2000 there is 2002 mentioned, because it's totally depend upon instruction size which type of instruction we are using. In theory classes I will tell classification of instruction where instruction also divided on the basis of length, means 1 byte instruction, 2 byte instruction, 3 byte instruction. In this program only I am telling some easy logic to understand. 1 byte instruction, that instruction only work with register. Here you can see move A comma C, add B and end, because they are working within the register. So these are called 1 byte register. To store this type of instruction we need only one memory location. Here we can see if you are using 8-bit data in any instruction means that instruction will be 2 byte instruction, and to store those instruction we require 2 memory address. So that's why MVIB 06H8-bit data is required 2 byte, means 2000 and 2001 reserved for this, same 2002 and 2003 reserved for this. So this is a standard way to write a program.
हेलो फ्रेंड्स, मैं प्रदीप यादव फिर से आपका स्वागत करता हूं अपने चैनल द नॉलेज अड्डा में। आज हम बात करने जा रहे हैं 8085 सिमुलेटर की, कि इस पर हम कैसे काम कर सकते हैं, कैसे किसी भी प्रोग्राम को रन कर सकते हैं, उसका इनपुट आउटपुट हम कैसे देख सकते हैं। देखिए, सिमुलेटर यूज करने का सबसे जो बड़ा बेनिफिट ये होता है कि हम कहीं भी अपने लैपटॉप पे, डेस्कटॉप पे कहीं भी बैठ के इसको यूज कर सकते हैं। और बेसिकली जो हमारा ट्रेडिशनल मॉडल है किट पे परफॉर्म करना, उसमें क्या होता है कि आपको एक किट की रिक्वायरमेंट होती है, देन आपको पावर सप्लाई की रिक्वायरमेंट है, देन आप परफॉर्म कर सकते हो। बट इन केस ऑफ सिमुलेटर क्या है कि बस सॉफ्टवेयर आपके सिस्टम पे इंस्टॉल होना चाहिए, जहाँ चाहे वहाँ आप बैठ के आराम से प्रोग्राम को स्टडी कर सकते हैं, उसको वेरीफाई कर सकते हैं, उसको परफॉर्म कर सकते हैं। तो बेसिकली जो मैं सिमुलेटर यूज कर रहा हूँ, ये बेसिकली B.Tech सॉफ्टवेयर कंपनी का 8085 सिमुलेटर है, जो इंटेल बेस्ट असेंबली लैंग्वेज के लिए बनाया गया है। अब सबसे पहले बात करते हैं कि इस सॉफ्टवेयर को हम कैसे इंस्टॉल कर सकते हैं, कैसे फाइंड आउट कर सकते हैं। आपको कुछ नहीं करना, सबसे पहले आप गूगल पे जाइए, गूगल पे आपको लिखना है 8085 सिमुलेटर B.Tech सॉफ्टवेयर। तो जो सबसे पहला लिंक आएगा यहाँ पे आप लिख दे सकते हैं, उस पर क्लिक करना। जैसे आप क्लिक करते हैं तो सेकंड जो स्क्रीन आएगी हमारी, यहाँ पे ऐसे आ जाएगी B.Tech सॉफ्टवेयर करके। और यहाँ पे नीचे आप देख सकते हैं, यहाँ पर डिस्क्रिप्शन दिया हुआ है, डाउनलोड 8085 सिमुलेटर। देन आप यहाँ से डाउनलोड कर सकते हैं। ये डॉक्यूमेंटेशन के लिए, अगर आप डॉक्यूमेंटेशन भी डाउनलोड करना चाहें तो डाउनलोड कर सकते हैं। आइए बात करते हैं सॉफ्टवेयर की और कैसे काम करता है। आप देख सकते हैं कि हमने यहाँ पे इंस्टॉल किया था, तो इसकी exe फाइल जनरेट हो गई थी। मैंने इस पर क्लिक किया तो ये आपका इंटरफेस दिखाई देगा। यहाँ पर दिखा रहा है सिंपल, यहाँ एडवांस, यहाँ पे सेटिंग। बात करते हैं कि तीनों कंपोनेंट बेसिकली है क्या। अगर हम सिंपल की बात करें तो सिंपल बेसिकली क्या है कि ये आपको सिर्फ एक सिंपल प्रोग्राम या सिंपल सिमुलेशन करने में यूज होता है। इसमें जैसे आप 7 सेगमेंटल डिस्प्ले, इस टाइप के प्रोग्राम आप इजीली इसमें कर सकते हैं। अगर हम एडवांस की बात करें तो बेसिकली क्या है कि ये एडवांस सिमुलेशन अलाउ करता है। इसमें कि आप इंस्ट्रक्शन इंटर कर सकते हैं, कंट्रोल एजुकेशन स्पीड को सेट कर सकते हैं, फिर आप मेमोरी के डेटा को व्यू कर सकते हैं, फिर रजिस्टर की वैल्यू देख सकते हैं। मीन्स इसमें ज़्यादा फंक्शनलिटी गिवन है। जैसे हमने सिंपल पे क्लिक किया तो इसका जो इंटरफेस आएगा वो देखिए, बस सिंपल सा इंटरफेस आएगा। इसमें आप ना मेमोरी दिखाई देगी, ना कुछ दिखाई देगी। और जैसे हम एडवांस पे क्लिक करते हैं तो इसकी सबसे खास बात क्या है कि इसमें आपको मेमोरी स्पेस दिखेगा, रजिस्टर की वैल्यू दिखेगी। एट ए टाइम आप सारी चीज़ें आप देख सकते हैं। जैसे आपने एडवांस पे क्लिक किया तो आपके सामने जो इंटरफेस आएगा इस तरह से आएगा। आप यहाँ पे देख सकते हैं बेसिकली मेमोरी एड्रेस गिवन है। यहाँ पे आप देख सकते हैं फ्लैग, कैरी फ्लैग, जेड फ्लैग, ये साइन फ्लैग, पैरिटी फ्लैग, सारी फ्लैग की वैल्यू यहाँ पे देख सकते हैं। यहाँ पे सारे रजिस्टर आपके गिवन है, ए बी सी डी ई एच एल। यहाँ मेमोरी है, PSW की वैल्यू क्या है, CH क्या है। तो सारी चीज़ें यहाँ पे आप इस एडवांस वर्जन में आप देख सकते हैं। और यहाँ पे आप देख सकते हैं, यहाँ पर लिखा है इंस्ट्रक्शन पर मिनट्स। तो बेसिकली क्या है कि अगर हम सेटिंग की बात करें तो सेटिंग में जाने के बाद आप यहाँ पर देखिए डिफ़ॉल्ट एजुकेशन रेट को भी सेट कर सकते हैं कि 1 मिनट में कितने इंस्ट्रक्शन आप चाहते हैं कि ये जनरेट करें या एग्जीक्यूट करें। सेम एड्रेस लोकेशन की बात करें तो यहाँ पे आप एड्रेस रेंज भी अपनी सेट कर सकते हैं। जैसे आपने 2000 से स्टार्ट करना चाहें तो 2000 से स्टार्ट कर सकते हैं, 4000 से, 5000 से, जहाँ से भी आप स्टार्ट करना चाहें वहाँ से स्टार्ट कर सकते हैं। ये सारी चीज़ें हमारी सेटिंग करते आती है। और ये आपका एडवांस यूजर इंटरफेस हमने आपको दिखाया था। चलिए मैं दोबारा ओपन कर देता हूँ ताकि दिखाऊँ आपको कि प्रोग्राम इसमें कैसे हम परफॉर्म करते हैं। तो देखिए, ये हमारा एक बेसिकली यूजर इंटरफेस है। ये हमारा पूरा मेमोरी एरिया है। बेसिकली जैसे जैसे हम वैल्यू इंटर करते जाएंगे आपको इस मेमोरी एड्रेस पर दिखते जाएगा कि किस मेमोरी एड्रेस पर क्या वैल्यू सेव हो रही है और आपके ये रजिस्टर की वैल्यू कैसे चेंज हो रही है, फिर आउटपुट आपका कहाँ स्टोर हो रहा है। तो सारी चीज़ें इसमें हम देख सकते हैं। तो ये चलिए बात करते हैं कि कैसे हम एक सिंपल से पहले आपको बताते हैं कैसे इसमें हम एक प्रोग्राम एग्जीक्यूट करते हैं, कैसे हम उसका आउटपुट देख सकते हैं। तो उसके लिए सिंपल सा एक प्रोग्राम करते हैं ए प्लस बी का, कि हमें एक रजिस्टर ए में कोई वैल्यू है, बी में क्या वैल्यू है, उन दोनों को हमें ऐड करना है, फिर आउटपुट हमें किसी एक पर्टिकुलर लोकेशन या किसी एड्रेस पे स्टोर करना है। तो चलिए एक सिंपल प्रोग्राम की बात करते हैं। तो यहाँ पे देखिए क्या है कि आप जिस एड्रेस पे प्रोग्राम लिखना चाहते हैं, जैसे डायरेक्ट मैंने लिखा है यहाँ पे 4100, तो बेसिकली जो हमारा पॉइंटर है वो 4100 को रिप्रेजेंट करेगा। अब चलिए यहाँ से हम प्रोग्राम लिखते हैं। जैसे हमारा पहला इंस्ट्रक्शन है कि हमने सोचा है कि 05 और 06 को ऐड करेंगे। तो माइक्रो प्रोसेसर में आपको पता है कि जो भी एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन, जो भी लॉजिकल, जो भी ऑपरेशन होते हैं, बेसिकली जो आउटपुट आता है वो हेक्साडेसिमल वैल्यू आता है। तो सपोज हमने ऐड करना है 05 प्लस 04, दोनों का टोटल हुआ 11, बट 11 डेसिमल है। अगर इसका हेक्साडेसिमल दिया जाए तो डेट इज 0B। तो चलिए टेस्ट करते हैं कि कैसे इसमें हम कोई भी प्रोग्राम परफॉर्म कर सकते हैं। सबसे पहले हम चलिए एक्यूमुलेटर में 05 को लोड करते हैं। तो लोड करने के लिए जो इंस्ट्रक्शन होता है MVI A,05, हमने एंटर प्रेस किया। जैसे हम एंटर प्रेस करते हैं तो आपको पता है कि हर इंस्ट्रक्शन कुछ न कुछ स्पेस लेता है मेमोरी में डेटा को सेव करने के लिए। जैसे MVI A505 की बात करें तो ये 2 बाइट इंस्ट्रक्शन है, मीन्स इसको 2 मेमोरी स्टोर स्पेस चाहिए डेटा को स्टोर करने के लिए। तो देख सकते हैं यहाँ पे इसने 2 मेमोरी स्पेस लिया है, 4100 भी और 4101 भी। यहाँ पे देख सकते हैं जैसे हमने 4100 किया, एंटर प्रेस किया, जो नेक्स्ट मेमोरी लोकेशन आ गया 4102। 02 क्यों आ गया? क्योंकि इसने 2 स्पेस ऑलरेडी एक्वायर कर लिया है स्टोर करने के लिए। चलिए अब लिखते हैं हमने MVI B06, हमने प्रेस किया एंटर। सेम ये भी 2 बाइट इंस्ट्रक्शन है, तो इसने भी यहाँ पे 2 बाइट स्पेस ले चुका है। अब हमने डायरेक्ट लिखा ऐड बी। बेसिकली ऐड बी क्या करता है? A प्लस बी, जो भी आउटपुट आएगा उसका जो भी आउटपुट आएगा वो एक्यूमुलेटर में स्टोर हो जाएगा। मीन्स इस इंस्ट्रक्शन के बाद आपका एडिशन हो गया है और आउटपुट एक्यूमुलेटर में स्टोर हो चुका है। अब हमें क्या करना है कि किसी लोकेशन पे आपको आउटपुट को स्टोर करना है। सपोज हमें स्टोर करना है 4050। हमने यहाँ पे लिखा, ये देखिए यहाँ पे दिखा रहा है इसने क्या हुआ, ये 3 बाइट इंस्ट्रक्शन है, इसलिए इसने 3 बाइट 32 50 40 मीन्स 50 40 2 स्पेस ही लेगा और एक इसलिए एक स्पेस ले लेगा, मतलब 3 स्पेस। उसके बाद हमने किया हॉल्ट। बेसिकली आपका प्रोग्राम एंड हो चुका है। अब इस प्रोग्राम को हम एग्जीक्यूट करेंगे। एग्जीक्यूट करने के लिए क्या करना है? सबसे पहले हम ये बटन देख रहे होंगे, इस पर क्लिक करेंगे तो प्रोग्राम आपका एग्जीक्यूट होना शुरू हो जाएगा। अब देख रहे हैं कि ये प्रोग्राम मूव हो रहा है, मीन्स ये प्रोग्राम 1 बाई 1 एग्जीक्यूट हो रहा है। प्रोग्राम रुक चुका है, आपका साइन वापस आ गया, मीन्स ये प्रोग्राम एग्जीक्यूट हो चुका है। अब चलिए हम आउटपुट चेक करते हैं। आउटपुट बेसिकली हमें मिलेगा 4050 पर। तो यहाँ पे आपको लिखना है SU स्पेस 4050। अब आपको एंटर प्रेस करना है। एंटर प्रेस किया तो आप यहाँ पर देख सकते हैं, दिख रहा है आपको 0B, जो कि ये आपका आउटपुट है 05 प्लस 06 का। चलिए हमने क्या किया कि जब हम 2 नंबर का ऐड करते हैं तो बाय डिफ़ॉल्ट जो आउटपुट होता है वो एक्यूमुलेटर में स्टोर होता है, मीन्स 050B एक्यूमुलेटर में स्टोर होना चाहिए। तो आइए रजिस्टर की वैल्यू चेक कर लेते हैं। आप यहाँ पर देख सकते हैं कि एक्यूमुलेटर की वैल्यू क्या है 0B और रजिस्टर की वैल्यू 06। मीन्स हमने A प्लस B किया तो A में 05 था पहले स्टेज में, B में 06 था। जैसे हमने एडिशन किया A प्लस B हुआ, उसका आउटपुट A में सेव हो गया, बट B की वैल्यू चेंज नहीं हुई। तो यहाँ पर देख सकते हैं कि A की वैल्यू 0B है और B की वैल्यू 06। तो इस तरह से आप सिमुलेटर यूज करके कोई भी प्रोग्राम परफॉर्म कर सकते हैं। तो थैंक यू फॉर वॉचिंग दिस वीडियो। इफ़ यू लाइक दिस वीडियो प्लीज़ सब्सक्राइब दिस चैनल for more video. Thank you. Program about to swap 8-bit number stored at memory location 8085 microprocessor programming. Means I am going to use assembly language programming. So let me explain what is program for. Basically program is that suppose there are 2 memory location, one is 2050 at which memory location X is stored and second memory location 2051 where Y is stored. Now we have to write a program to exchange the content between the memory location. Means you have to store this X at this location and you have to store Y at this location. So basically you have to exchange the data between these two memory location. Means this is, if this is input, then output should be 2050 Y 2051 X. Means for this purpose you have to write a program to swap the content of memory location between them. Now friends, in this case we have to use a third variable. Now let me explain the step ki how we can perform this program easily. Suppose this is first memory location. Okay, now we have to store this data in a register, in third variable, and we have to store the content of this memory location at this. Then we have to store content of this particular third variable, the register C, into this memory location. Means your first step should be this, second will be this, and third will be this. So by following this circular phenomena, we can swap the number between two memory location easily. Now I have to write the program of three procedure. So firstly you have to store first number at this location, LXI H 2050. This represent a memory location. Now you have to shift this data into C in third variable. Just I have write move C comma M. This represent the content of 2050 location is moving to C. Means अब इसका मतलब क्या हुआ कि जो डेटा इस लोकेशन पे था वो C में स्टोर हो गया. Now we have to follow the second step. Means we have to store this data at this location. Now we have to write LDA 2051. This represent कि this instruction, when this instruction will be executed, means that कि the content of this location is stored in accumulator. This is LDA, load accumulator directly. Means इसका मतलब क्या हुआ कि इसके साथ जो भी आपका मेमोरी लोकेशन गिवन है उसका जो कंटेंट होगा वो accumulator में स्टोर हो जाएगा. Now we have a instruction STA 2050. This represent store the content of accumulator at this location. Now what happen कि the content of A will be stored at this location. इसका मतलब क्या हुआ कि इस लोकेशन की वैल्यू जो A में आई थी means Y, now Y will be stored at this location as this. Means your first step is complete. Means your first step and your second step has been complete. Now we have to follow third step. In this case, firstly we have to store data into accumulator again. Just I have write move A comma C. Means the content of C will be transferred in accumulator, means in A. Now at this point content of accumulator will be content of 2050, that is X. Now I have write STA 2050. Now content of accumulator will be stored at this location. Means at 2051 content of A is X, and then the program. So by this instruction we can swap the content between two memory locations. Now by this program you can easily understand कि how you can swap the data. In place of this instruction, if you want to use LDA, then definitely you can use LDA also. So it's depend upon कि which instruction या which memory location you want to use and how you want to perform this type of program. So now Let me again explain कि what you have to do. I have already discussed कि there are two memory location 2050 and 2051. There is a data store X at this location, Y at this location. We have to perform sweep, means you have to score X at this location and Y at this location. I have already explained कि how you can perform. Firstly, we have a declare variable C. In C, we move the content of first location in C. Then in second step, you have to transfer data from this location to this location. In third step, just we store the content of third variable this location. So by using this process, you can swap the data between two memory locations. Now, from this program, you can easily understand how you are going to perform this. In first step, I have just stored the content of this location into variable C. In second step, I have stored the content of this location at this location. In third step, just I have stored the content of C at this location. So this is program of swapping data between two memory location. So this is whole program. यहाँ पे लिखा है ट्रांसफर ब्लॉक ऑफ n बाइट डेटा. बेसिकली क्या है कि मैंने ऑलरेडी एक वीडियो डाल रखा है कि हम एक लोकेशन से दूसरी लोकेशन में डाटा कैसे ट्रांसफ़र करते हैं या कैसे एक्सचेंज करते हैं. बट यहाँ पे जो बात हो रही है वो हो रही है ब्लॉक ऑफ n बाइट डेटा. n बाइट डेटा मीन्स n की वैल्यू 1 भी हो सकती है, 2, 3, 4, 5, 6, 7, 8, 9 कुछ भी हो सकता है. मीन्स हमें एक पूरे ब्लॉक ऑफ डेटा को ट्रांसफ़र करना है दूसरे लोकेशन पे. मीन्स जो सोर्स हमारा है उस डेटा को हमें डेस्टिनेशन पे ट्रांसफ़र करना है. जैसे बेसिकली प्रोग्राम क्या है कि यहाँ पे आप देख सकते हैं, ये हमारा जो है ये इनपुट डेटा है, इसको हमें ट्रांसफ़र करना है इस लोकेशन पे. मीन्स ये हमारा डेस्टिनेशन है और ये हमारा इनपुट लोकेशन है. मीन्स हम ब्लॉक ऑफ डेटा कहने का मतलब है, देख सकते हैं यहाँ पे हम 5 डेटा की बात कर रहे हैं, सिंगल डेटा की बात नहीं कर रहे हैं, 5 डेटा है. मीन्स n की वैल्यू इस केस में 5 हो जाएगी. मीन्स 5 ब्लॉक ऑफ डेटा को हम ट्रांसफ़र करने जा रहे हैं टू डेस्टिनेशन. तो चलिए दोस्तों हम स्टार्ट करते हैं कि इसको हम कैसे कर सकते हैं. मीन्स यहाँ पे n की वैल्यू 5 है, आप इसको 10, 20 जो भी लेना चाहें आप ले सकते हैं. तो बेसिकली मैं एक ओवरऑल आपको कंसेप्ट बता दूं कि बेसिकली इसमें एक कंसेप्ट हमें करना कैसे है. इसको सबसे पहले देखिए, जितने नंबर ऑफ डेटा को आपको ट्रांसफ़र करना है उसका सबसे पहले हम एक काउंटर इनिशियलाइज करेंगे. मीन्स कहने का मतलब है कि मान लीजिए हमें 5 डेटा ट्रांसफ़र करना है तो जो हमारे काउंटर की वैल्यू होगी वो 5 हो जाएगी. काउंटर कहने का मतलब है कि आप कोई भी रजिस्टर इसको यूज कर सकते हैं. जैसे हमने रजिस्टर जनरली देखिए किलोमीटर हम यूज करते नहीं है. जैसे रजिस्टर हमने B यूज कर लिया, C यूज कर लिया, D कर लिया, E कर लिया, तो डिपेंड करता है कि आप किस रजिस्टर को यूज कर रहे हैं एज काउंटर. अब क्या करना है, आपने एक काउंटर इनिशियलाइज कर दिया जिसमें आएगा कि नंबर ऑफ डेटा हम कितने ट्रांसफ़र करने जा रहे हैं. सेकेंड क्या करना है आपको, एक आपको सोर्स लोकेशन डिसाइड करना है. मीन्स उसमें सोर्स लोकेशन की वैल्यू हो जाएगी 2100. फिर आपको एक डेस्टिनेशन लोकेशन डिसाइड करना है. अब क्या करना है कि सबसे पहले जो इस लोकेशन पे डेटा है उसको हम ट्रांसफ़र इस लोकेशन पे करेंगे. कैसे, मतलब जैसे आपने सोर्स इनिशियलाइज किया, इस लोकेशन पर जो डेटा है उसको हम 1 किलोमीटर में ले लेंगे. उस 1 किलोमीटर को डेटा को हम इस लोकेशन पे स्टोर कर देंगे. मीन्स ये डेटा ट्रांसफ़र हो गया. अब क्या करेंगे, हमने क्या किया, सोर्स के काउंटर को इंक्रीज कर दिया, फिर डेस्टिनेशन के काउंटर को इंक्रीज कर दिया. मीन्स हमारा जो सेकेंड टाइप पॉइंटर होगा इसको डिनोट करेगा और इसको डिनोट करेगा. अब हम क्या करेंगे, काउंटर की वैल्यू को चेक करेंगे कि काउंटर की वैल्यू 0 है कि 0 नहीं है. अगर काउंटर की वैल्यू 0 नहीं है मीन्स हम क्या करेंगे, सेम इस डेटा को 1 किलोमीटर में फिर इसको इस लोकेशन पे स्टार्ट कर देंगे. तो ये प्रोसेस हम तब तक रिपीट करेंगे जब तक काउंटर की वैल्यू 0 न हो जाए. जैसे ही काउंटर की वैल्यू 0 हुई मीन्स हमारा प्रोग्राम स्टॉप हो जाएगा. इसका मतलब ये हुआ कि जो भी आपके डेटा थे वो ट्रांसफ़र हो चुके हैं. तो आइए अब हम इस प्रोग्राम की बात करते हैं कि हम करते कैसे हैं. देखिए मैंने कहा कि सबसे पहले हम एक काउंटर इनिशियलाइज करेंगे. तो जैसे हमने लिख दिया MBI C, 05. इसका मतलब ये हुआ कि रजिस्टर सी में हमने 05 स्टोर कर दिया। बेसिकली 05 यहाँ पे एन की वैल्यू है। अगर यहाँ पे डाटा 10 होता तो हम यहाँ पे लिख देते 0 है, मीन्स 10 डाटा होगी। 6 होता तो 6 कर देते। तो चलिए हमने यहाँ पे 5 कर लिया, मीन्स हमने रजिस्टर सी को एज काउंटर इनिशियलाइज कर दिया। हमने यहाँ पर कमेंट लिख दिया सी एच काउंटर। अब सेकेंड है, हमने क्या कहा आपसे कि हम सोर्स लोकेशन को डिफाइन करेंगे। हमने यहाँ पे लिख दिया LXI H 2100H, ये हमारा हो गया सोर्स पॉइंट। और सेकेंड हमने डिसाइड कर लिया LXI D 22H, ये हो गया हमारा डेस्टिनेशन। H मीन्स हो गया यहाँ पे HL पेयर, D मीन्स हो गया D पेयर। ये सोर्स भी इनिशियलाइज हो गया, आपका डेस्टिनेशन भी इनिशियलाइज हो गया। अब हमें क्या करना है कि सबसे पहले हम बात करते हैं फर्स्ट डेटा को ट्रांसफ़र करने की। मीन्स जो 2100 पे डेटा है उसको हमें 2200 पे ट्रांसफ़र करना है। तो अब क्या करेंगे, जो इस लोकेशन पे डेटा है, इस लोकेशन पे उसको हम डेटा को पहले एक्यूमुलेटर में स्टोर करेंगे। एक्यूमुलेटर में स्टोर कैसे होगा, मीन्स उस लोकेशन के डेटा को हम एक्यूमुलेटर में मूव कर देते हैं। तो हमने लिखा यहाँ पे मूव A, M। अब देखिए M क्या होता है कि जो भी HL पेयर में डेटा होता है, मीन्स जो भी HL पेयर में लोकेशन स्टोर होगा उसका जो डेटा होगा वो M रिप्रेजेंट करता है। मैं HL पेयर की बात कर रहा हूँ, D पेयर की बात नहीं कर रहा हूँ। तो देखिए HL पेयर में इस समय लोकेशन क्या स्टोर है 2100। 2100 पे डेटा क्या था हमारा 01, मीन्स इस लाइन के बाद एक्यूमुलेटर की वैल्यू हो जाएगी 01। अब हमें क्या करना है, इस जो एक्यूमुलेटर की वैल्यू 01 है उसको हमें इस लोकेशन पे स्टोर करना है। तो हमने यहाँ पे लिखा स्टैक्स D। इसका मतलब ये हुआ कि एक्यूमुलेटर की वैल्यू D पेयर जिस करंट लोकेशन को रिप्रेजेंट कर रहा है वहाँ पे स्टोर हो जाएगा। मीन्स इसके बाद हमारा 2200 पे जो डेटा स्टोर हो जाएगा वो हो जाएगा 01H। इस लाइन के बाद ये आपको लिखना नहीं है, बेसिकली ये हमारा कमेंट है जो आपको दिख रहा है, ये हमने कमेंट लिखा है इसलिए इसको अवॉइड कीजिएगा। ये आप प्रोग्राम में अलग से लिख सकते हैं, बट प्रोग्राम जो ये लेफ्ट हैंड साइड में वही है। तो यहाँ तक क्या हुआ कि जो एक्यूमुलेटर की वैल्यू थी वो डी पेयर पे स्टोर हो गई, मीन्स 2100 का डाटा 2200 पे स्टोर हो चुका है। अब हमें क्या करना है, 2101 का डाटा 2201 पे स्टोर करना है। मीन्स अब हमने यहाँ पे क्या लिखा INX H A क्या करेगा, HL पेयर की वैल्यू को 1 से इंक्रीज कर देगा, मीन्स यहाँ पे आ गया 2101। सेम हमने किया INX D, ये आ जाएगा 2201। अब मीन्स 2101 का डाटा 2201 में स्टोर करना है। अब देखिए ऑलरेडी डाटा मूव हो गया है, इसलिए हमें यहाँ पे काउंटर को 1 डिक्रीज कर दिया, मीन्स यहाँ पे हो जाएगा डिक्रीज द काउंटर बाई 1। अब देखिए इसके बाद बेसिकली क्या है कि हम काउंटर की वैल्यू को चेक करेंगे। अगर काउंटर की वैल्यू 0 है मीन्स सारे डेटा आपको ट्रांसफ़र हो चुके हैं। अगर काउंटर की वैल्यू 0 नहीं है मीन्स आपको नेक्स्ट डेटा ट्रांसफ़र करना है। तो देखिए क्या हुआ कि जैसे हमने यहाँ पे काउंटर की वैल्यू चेक की तो यहाँ पे C की वैल्यू 5 है, जैसे आपने DCR C किया इसकी वैल्यू होगी 4, मीन्स ये 0 नहीं है। यहाँ पे आएगा आपका J and Z, जंप इफ नॉट 0। अगर इस C की वैल्यू 0 नहीं है तो जंप करो। बेसिकली हमें क्या करना है कि जब तक C की वैल्यू 0 नहीं होगी तब तक डेटा को एक्यूमुलेटर में ट्रांसफ़र करके स्टोर करना है। तो अब क्या होगा, यहाँ से सीधे आपका प्रोग्राम जंप करेगा, आपका हमने यहाँ पर लिख दिया XX जंप करेगा यहाँ पे x x x। अब देखिए इस लाइन का मतलब है क्या, मैं इस लाइन को एक्सप्लेन करता हूँ। आपने देखा यहाँ पे 1 किलोमीटर में 0 1, यहाँ पे आपने फर्स्ट डाटा स्टोर कर लिया। हमने क्या किया, यहाँ पे सोर्स की लोकेशन को 1 से इंक्रीज किया, ये आ गया 2101। आपने डेस्टिनेशन इंक्रीज किया 2201। हमने DCR C किया, C की वैल्यू चेक की, C की वैल्यू यहाँ पे क्या है, 0 नहीं है, मीन सीधे यहाँ पे जंप आ गया। अब आ गया मूव A, M। अब देखिए यहाँ पे M की वैल्यू क्या होगी, एक्चुअल पेयर में जो भी करंट लोकेशन होगा उसके डेटा की बात कर रहे हैं। अब देखिए यहाँ पे एक्चुअल पेयर में करंट लोकेशन क्या है आपका 2101, इसका डेटा क्या है आपका 02। मीन्स इस केस में सेकेंड टाइम यहाँ पे A की वैल्यू हो जाएगी 02 और यहाँ पे D की वैल्यू हो जाएगी 2201। मीन्स यहाँ पे हो गया 2201, यहाँ पे स्टोर हो गया 02। ये आपका सेकेंड डाटा स्टोर हो गया। अब क्या होगा, फिर से हमने -H किया, तब इसकी वैल्यू हो जाएगी 2, क्योंकि 2101 तो ऑलरेडी था उसमें, इसमें 2201 है, ये भी 2 हो जाएगा। फिर DCR C हो गया, क्योंकि अब C की वैल्यू 4 हो गई थी, अब C की वैल्यू हो जाएगी 3, ये फिर नॉट इक्वल टू 0 है। फिर ये जंप करेगा, फिर मेमोरी लोकेशन मीन्स 2102 का डाटा फिर 1 किलोमीटर में आ गया, फिर ये 2202 में स्टोर हो गया। फिर C हुआ, अब C की वैल्यू 2 हो गई, फिर 0 नहीं है, फिर ये जंप करेगा। मीन्स इस तरह से क्या होगा, ये आपका सोर्स भी बढ़ता रहेगा, डेस्टिनेशन भी बढ़ता रहेगा, काउंटर की वैल्यू डिक्रीज होती रहेगी। ये सेम प्रोसेस यहाँ से और यहाँ तक, ये प्रोसेस तब तक रिपीट होगा जब तक C की वैल्यू 0 ना हो जाए। जैसे C की वैल्यू 0 होगी, ये कंडीशन आपकी ट्रू हो जाएगी, फिर हमारा प्रोग्राम यहाँ पे एंड हो जाएगा।
Sum of series of 8-bit number means you can send it कि you have to add 8-bit number more than 2, 3, 4, 5, 6 means totally depend upon कि how your series is your series long is. That series contain 5 number, that can contain 6, 7 to 8 number, 10 numbers is totally depend upon you कि how many number you are going to assume in that particular series. So let me explain the program, basically what is program. So here you can see that key there are 4 number. This is a series which is starting from 2301 or this is last memory address, means I am considering only 4 number to add in this series. This is 8-bit number, 8-bit number, 8-bit number, 8-bit number. This 4 number is 8-bit number. We have to going to perform addition of this all 4 number. Here you can see that there is a memory location where I have written 04. So basically what you have written here, that will be length of series, means that number of number you are going to add. Suppose मैंने यहाँ पर लिखा 06, means हम जो हमारी सीरीज है उसमें 6 नंबर है, उनको हम ऐड करने जाने। तो बेसिकली हमारा प्रोग्राम क्या है कि हमें एक 8 बिट की सीरीज है जिसके जो भी कंटेंट है सारी कंटेंट को ऐड करना है और उसका आउटपुट हमारे पास 2 लोकेशन है, एक 2500 जिस पे हमें सम स्टोर करना है एंड 2501 हमें यहाँ पे कैरी स्टोर करना है। तो मैं एक बार आपको प्रोग्राम बता देता हूँ, वो प्रोग्राम है क्या। बेसिकली हमारे पास एक 8 बिट सीरीज गिवन है, इस सीरीज़ के जो भी नंबर हैं उन सबको हमें ऐड करना है, उसका सम हमें यहाँ स्टोर करना है। यू हैव टू स्टोर कैरी एट दिस मेमोरी लोकेशन। ये बताता है कि कितने नंबर है। अगर सपोज यहाँ पे 06 है, मीन्स जो लेंथ है आपकी सीरीज की वो 6 नंबर्स की है। अगर यहाँ पे 7 है तो 7 की है। तो बेसिकली दिस इज ए बेसिक प्रोग्राम और नाउ यू हैव टू राइट ए प्रोग्राम टू परफॉर्म दिस होल ऑपरेशन। तो नाउ लेट्स step by step. What will be first step, then second step, third step. So first step is, firstly you have to set a counter कि how many number are present in that particular series. So for that I have write LXI H 2300, that is first memory location. यहाँ पे क्या है कि हमें उस वैल्यू को स्टोर करना है, मीन्स यू हैव टू स्टोर द लेंथ ऑफ series. Store length of series. Now move C एम, मीन्स जो भी आपकी लेंथ होगी दैट विल बी वर्क एज ए काउंटर. तो हियर सी इज counter. Now this is first step. If you have stored here 07 means value of C will be 07. If you have stored here 10 means value of C will be 10. Basically what happen, M means M always represent the content of memory location which is stored in HL pair. So in this case in HL pair memory location is stored in 2300. Whatever value of this location will be, that will be represent the value of C. Now here C is a counter कि how many number you are going to add या how many number are present in particular that series. Now second step, just MVI A00 clear the accumulator. Clear the accumulator. Now MVI B use store the कैरी. देखिए हमने बी को इसलिए यूज किया है कि मान लीजिए जब भी हम दो नंबर ऐड करेंगे तो मे भी हो सकता है हमारा कैरी जनरेट हो या ना हो, क्योंकि कैरी या तो 1 होगी या तो 0 होगी. अगर कैरी जनरेट होगी तो उसको हम बी में स्टोर करते जाएंगे, बी में स्टोर कर लेंगे. अगर कैरी नहीं होगी तो उसकी कोई प्रॉब्लम नहीं है. तो बस इसलिए यहाँ पे हमने एक किलोमीटर लिया है, क्योंकि आपको पता ही है कि जो भी ऑपरेशन हम माइक्रो प्रोसेसर में करते हैं बाय डिफ़ॉल्ट आउटपुट एक्यूमुलेटर में स्टोर होता है. तो फर्स्टली यू हैव टू क्लियर द वैल्यू ऑफ एक्यूमुलेटर. इन एक्यूमुलेटर देयर शुड बी ओनली 00, देन यू कैन proceed. Second step, I have declared B as a register. I have taken a B register to store the value of carry. If there will be carry, then you will increment the value of B and store this. Now this is basic. Now working on data. So here I have written LXI H2301. Here get first data. Now we have to add this data. Add M means A plus M. Here is 00, M means first data. So you have add first data. Now what happened, जब भी हमने डाटा ऐड किया है तो हम चेक करेंगे कि भाई इसमें कैरी जनरेट हुई कि नहीं हुई. जैसे कि मैंने ऑलरेडी बताया कि अगर कैरी जनरेट होगी तो बी की वैल्यू को इंक्रीमेंट कर देंगे. अगर कैरी जनरेट नहीं होगी तो हम दूसरा डाटा उसमें ऐड करते जाएंगे. तो सपोज हमने यहाँ पर लिखा JNC, जंप इफ नो कैरी. अगर हम बात करते हैं कि मान लीजिए कैरी जनरेट नहीं हुई तो हमें क्या करना है. कैरी जनरेट नहीं हुई तो हमें क्या करना है, हमें लेना है नेक्स्ट डेटा मीन्स INX H दैट विल बी इंक्रीमेंट दी दिस मीन्स यहाँ पे H की वैल्यू हो जाएगी 2302 means this represent second data. Now decrement the counter. Decrement हम इसलिए कर रहे हैं क्योंकि ऑलरेडी हम एक डाटा ले चुके हैं, मीन्स एक एडिशन हो चुका है. उसके बाद हम C की वैल्यू चेक करेंगे. चेक द वैल्यू ऑफ C. JNZ होता है जंप इफ नो 0. ये बेसिकली C की वैल्यू चेक करेगा. जब तक C की वैल्यू 0 नहीं होगी तब तक हमें क्या करना है, डेटा को ऐड करते रहना है. तो मान लीजिए यहाँ पे एक डाटा ऐड हो गया. C की वैल्यू क्या है 3, 0 नहीं है. तो हमें क्या करना है, नेक्स्ट डाटा ऐड करना है. तो ये जंप होगा नेक्स्ट डेटा पर. नेक्स्ट डाटा ऐड हुआ, फिर हम चेक करेंगे कैरी है कि नहीं है. कैरी नहीं है तो फिर ये पॉइंटर यहाँ पर 3 कर देगा. C की वैल्यू 2 हो जाएगी. फिर चेक करेगा, 0 नहीं है, फिर जाएगा. फिर यहाँ पे इसकी वैल्यू 4 हो जाएगी, इसकी वैल्यू 1 हो जाएगी, फिर जाएगा. मान लीजिए इसकी वैल्यू हो गई 5, इसकी वैल्यू हो गई 0. जब 0 हो गई तो ये होगी कंडीशन फेल, क्योंकि इसका मतलब ये हुआ कि सारे डेटा आपको ऑलरेडी ऐड हो चुके हैं. तो उसके बाद हमें क्या करना है, STA 2500 यहाँ स्टोर हो जाएगा आपका सम एंड मूव A, B और STA 25001 and the प्रोग्राम। देखिए इस केस में क्या हुआ, जो भी सम आया आपका यहाँ स्टोर हो गया। यहाँ पे क्या है, बी की वैल्यू 0 है तो यहाँ पे 0 आ गया, यहाँ पे स्टोर हो गया 0 0 कैरी। ये तो वो केस हुआ कि जब कैरी आपकी जनरेट नहीं हो रही है। सपोज कि मान लीजिए कि कैरी जनरेट हो गई तो क्या होगा। इस प्रोग्राम को दोबारा मैं रिवाइंड कर रहा हूँ। आप ये था कि भाई जंप इफ नो कैरी, जब कैरी नहीं होगा तो हम नेक्स्ट डेटा लेते जाएंगे, ऐड करते जाएंगे, जब तक सी की वैल्यू 0 नहीं होगी तब तक आपको ऐड करते रहना है, और देन यू हैव टू स्टोर फाइनली सम एंड कैरी। नाउ व्हाट हैपन, सपोज आपने 2 नंबर ऐड किया, कैरी जनरेट हो गई। कैरी जब जनरेट हो गई तो ये कंडीशन आपकी हो जाएगी फेल। देन व्हाट यू हैव टू डू, देन यू हैव टू इंक्रीमेंट द वैल्यू ऑफ बी। जैसे आपने बी की वैल्यू इंक्रीमेंट की तो यहाँ पे बी की वैल्यू क्या हो जाएगी 0 1, ये हो जाएगी 0 1। तो ये हमारा कैरी क्या हो जाएगा, यहाँ पे 0 1 स्टोर हो जाएगा। तो बेसिकली ये एक सिंपल सा प्रोग्राम है कि जिसको यूज करके आप किसी भी 8 बिट सीरीज की सम को ऐड कर सकते हैं। सिंपल सा लॉजिक है, सिंपल सा प्रोग्राम है। तो लेट मी एक्सप्लेन अगेन ताकि आप इजीली अंडरस्टैंड कर सकें कि इस प्रोग्राम में हो क्या रहा है। तो दोस्तों मैंने ऑलरेडी बताया था कि ये मैं बात कर लेता हूँ। यहाँ पे हमारा फर्स्ट मेमोरी लोकेशन है जो रिप्रेजेंट करता है कि हाउ मेनी नंबर या लेंथ ऑफ दिस सीरीज, कि हाउ मेनी नंबर आर प्रेजेंट इन दैट पर्टिकुलर सीरीज, एंड दीज आर मेमोरी लोकेशन वेयर नंबर आर स्टोर्ड। दीज आर 8 बिट नंबर which number you have to going to add, and here you have to store sum, here you store to carry. Now what is concept, कि firstly we have declared the location of length of series. This location going to store the length of series. After this we have to make C as a counter by considering the length of series. Now just clear accumulator 0 0 and B has taken 0 0 to store the carry. If there will be carry, then value of B will be 1, otherwise it will remain as 0. Now LXI H2301 get this represent first data of this series, and this is 2301, this is first data of 2 series, and add M means you are going to perform addition between accumulator and the first data. After that you have checked the carry. If there will be carry, then you have to increment the value of B. If there is no carry, then you have to get second data, decrement the counter, check the value of counter C. If the value of C is 0, then program will be end. If C is not 0, then you have to perform addition again and again till C became 0. So this is simple. This is simple a program to how to add 8 bit number. Hope you understand how this program is going to perform and how this program is working. If you are unable to understand, then definitely just do a comment. I will try to explain again.
You have to write a program to add starting 10 natural number and store output at given location. As we know, by default your output will be stored in accumulator, and we have to shift the value of accumulator to at this location. Okay, so let me make you understand what is basically program. You have to write a program to add 10 natural number. These are natural number 9. If you are going to start from 0, then you can consider 0, otherwise 1 2 3 4 5 6 7 8 9 10. So you have to write a program to add this number. Okay, so this is basically program. Then what is concept? Let me discuss the concept. Firstly, you have to initialize the counter by containing how many number you are going to add. So here we are going to add 10 numbers, means the value of counter will be 10, means 0A in hexadecimal. Okay, 0A, and C, this is a register. You can take any register to initialize as a counter, but I have taken C. So this is counter. Now what you have to do, after that, firstly initialize the counter. Okay, initialize the counter with how many number you are going to add. Suppose you have to add 10, then value of counter will be 0A. Second is clear the accumulator, because finally we have to store output in accumulator. Okay, here store first number in register. You can take here register B, and add first number into accumulator. Okay, here get second number and here decrement the counter by 1, okay, by 1, and check the value of counter, if counter equal to 0, then store output. If counter equal to not 0, then add next number, and finally store the output and end the program. So basically this is concept, and now you have to write program. So let me discuss line by line so you can easily understand how you can write program for this. Okay, so firstly you have to initialize counter. So here MBI C 0A. Why 0A? Means this is hexadecimal, that's why we have taken 0A, and 10 is a decimal. If you are going to represent 10 in hexadecimal, as you know, that is represented by 0A. Okay, second line is clear the accumulator. So we have multiple way to clear the accumulator. So I am taking one of them is XOR A. XOR A means if you are going to perform XOR operation A with A, then it will return 0. Means after this the content of accumulator will be 0. Also you can use MBI A comma 00, that is also okay, there is no any problem. Here store the first number in register B. So I have stored first number in register B, MBI B 0 name, because here I have taken first number as 1. Okay, so store first number in accumulator, add first number in accumulator. Okay, so add B. After this what we get? Accumulator has 00 and 01. We get 01 and that will by default store in accumulator. Okay, now get second number means just increment B. Now value of B will be 02. Here 01, then 02. Now check the value of counter DCR C. We decremented counter by 1. Now we have to check the value of DCR C. So here value of C will be 09. Check J and Z. If C is equal to 0, then store output means STA 4050 and end the program or halt. Okay. If value of counter is not 0, then add next number. Okay, then it will be jump here. Now what happened? Let me explain one by one. Firstly here value of accumulator is 01, B is 02, 9, this is not equal to 0, then again it jump. Now add B means A plus B. Now value of B is 02, then it will add 01 plus 02, that will be 03. Now accumulator have 03, again value of B will be 03, here value of C will be 08, not equal to 0, again add. Now what happened? 03 plus value of B is 03 again. Now after this accumulator have 06, again this is 7, not equal to 0, again. Means it will process till C become 0. When C becomes 0 means all number is already added and you can store your output. So this is program. So let me explain it again so you can easily understand by considering that example. Just I want at least you can understand, then you can make many program which is generally based on this type of concept. So let me write the program and then I will explain. Okay, so this is program MBI. See, I have taken 5 number only to make you understand. Okay, and here XOR A, and here MVI V, first number I have taken, add B, increment B, DCR C, J and Z. If it is not equal to 0, then what we have to do? We have to do this, and if it is 0 means we have to store output at and this is end of program. Okay, you can write halt as well as, there is no any issue. So let me discuss it again. Suppose you have to add 01, 02, 03, 04, 05. Okay, so I have taken 5 here. After this, value of accumulator is 00. This is first number. When you are going to add B means 00 plus 01. Now 01 and current value of accumulator is 01. Here now value of B will be 02. Here value of C will be 9. This is not equal to 0. Again jump. Add B means A plus B. So here A is 01 and value of B is 02. Okay. Now after this, value of accumulator will be 03. Okay. And here it will be 3. Here it will be 8. It is not equal to 0. Then what happen? Add A plus B means 03 plus 03, 06. Now value of accumulator is 06. Here here 4, 3, 2. Okay. Not equal to 0. Again jump. It will add means here I think there is some confusion. Let me explain it again. Okay. B, add B means 00. After this, value of accumulator is 01 and B is 02. And here DCR C means that will be 4. Not equal to 0. Again add means 01 plus 02. The value of 03 and it will become 3 and it will become 3. Not equal to 0. Again add 03 plus 03. Okay, now value of 06 and here it will be 2, not equal to 0. Again add. So here you can see the value of B is 06 plus 04. Again it will become 04 and it will become 1, not equal to 0. Then again. So basically this process will be followed till your C became 0. Means when your counter will be 0 means you have already added each and every number. Then after that you can store the output. So this is very simple program. After following this concept you can add even number, odd number. In starting 5 even number, suppose you have to add 5 starting odd number you have to add. So by using this concept you can easily do. Hello friends, in this video I am going to discuss a program of multiplication of two 8-bit number using memory location. Friends, some day ago I have already uploaded a video regarding multiplication of two number using register. The basically difference between that program and this program is only of register and memory location. In that program I had used register to storing the number. In this program I am going to use memory location to store the number. All procedure are basically same, but their difference is register and memory location. Now let me discuss what is basically program is this. Program is this, we have two memory location. This is first memory location, there is a number stored is x. Second is 2501, there is store number is y, and you have to store output at this location, that will be x multiply y. And next memory location, that is 2053, we have to store carry. In microprocessor maximum value of carry can be 01 or 00. If there will be any carry, then you have to store 01 at this location. If there is no carry, then you have to store 00 regarding carry. Now as you know, there is no any instruction to direct multiplication in 8085 microprocessor. So for multiplication you have to use a repeated addition method. So let me explain what is repeated addition method. Suppose you have to multiply 2 into 3 that will be equal to 6. In repeated multiplication method means you have to add 2 3 times or 3 2 times. In both case we get 6. So this process is called repeated addition method. Basically in what happen in this type method, you have to add
a single number multiple times. Multiple times means what is second number. In this case we are going to add 2 3 times or 3 2 times. So this type of procedure is called repeated addition method. So in 8085 microprocessor, if you want to multiply two number, then you have to follow this type of procedure, that is called repeated addition method. So same you are going to use in this particular program. Now I have already explained what is program. Now in this case you have to, suppose this number is fixed and you have to add x y times. So in simple language you can say that this will be a number, and we can set y as a counter to perform multiplication. Now just start our program. Firstly you have declare, suppose declare MVI D00. I have used this register only to store the value of carry. Store the value of carry. What is use of the register? Suppose if there will be carry, then we have to increment the value of D and store the value of D at this memory location. If there will be no carry, then we have to store 00 at this memory location. So initially you will declare a register D to store the value of carry. Now MVI A00, just clear the accumulator. We have cleared the accumulator because we have to store output in accumulator. So firstly make it clear. Now get first number, that will be LXI H2050. Just we store this number into register B. Here we get first number in B. Now move to second location and move C comma M. This will be second number that is in C. मतलब C रजिस्टर में हमने सेकेंड नंबर को सेव कर लिया. Now what you have to do, you have to add B C times. Means B will be number, C will be just act as a counter. Because suppose, just taking an example, कि content of B is 04 and content of C is 05. Content of B is 04, C is 05. In this case we have to add 04 5 times. 04 is value of B, or this 05 is value of C. So here C is working as a counter, means you have to add 04 5 times. So in this case B is number and C is act as a counter. Now just add first number, add B. What happen? This will be add 0004. If we are considering this example, then 04. In this case what happened? 04 is already added, means now value of counter will be 05 minus 1. Now suppose there is no carry, then what happened? Add B. There is no carry, JNC. Just this instruction used to check the carry. Jump if no carry. If there is no carry, then what we have to do? We have to decrease the value of C. Then it will be jump DCR C. Means your first number is added, then value of counter is 5 minus 1. Here 5 minus 1 means C minus 1. Now check the value of counter. What is value of counter? So we use instruction that is J and Z. This instruction is used to check the value of C. Okay, now what is value of C? If value of C is equal to 0, then your program is finished. If value of C is not 0, then you have to repeat the process again. That is called repeated addition. Suppose in this case, what is value of C? C is, if you are taking this example, then after addition of 0 4, value of C will be 0 4. Here that is not equal to 0, then we have to again add B. This will be jump at this location. Now what happened? We are going to again add 0 4. Suppose again there is no carry. Now value of C will be 0 4 minus 1 0 3. GNDs, check the value of C, that is not equal to 0, then again 0 4. This will be add until C becomes 0. When C becomes 0, this will be end the program and you have to store output STA 2052. Here store output and move A comma D, store the value of carry in A or STA 2050 and end the program. So this is program. In that case, suppose there is no carry generated. Now let's consider if there is carry generated, then what will be happen? If suppose carry is generated, means this instruction will be false, because this will be jump when carry will be generated. Suppose carry is generated, this instruction is false, not executed, then what happen? Increment D, again DCRC JNZ. Here value of D will be 0 1 in this case. So this is a simple program to multiply two number using memory location. Now let me recap the whole program again. Here you can see that there is two memory location 20501 where X is stored, 2051 where Y is stored, and here you have to store X multiply Y, and here you have to store the value of carry. Here I have written 0 1 or 0 0. Reason is behind that, in maximum value of carry will be can be 0.8085 microprocessor or 0, minimum 0, maximum 0 1. Now what is logic? We are going to use repeated addition method to perform multiplication in this program. Repeated addition means suppose you have to multiply 2 into 3, then you have to add 2 3 times or 3 2 times. In this case 1 is a fixed number, second number is work as counter. Now we have just taken example of suppose content of B is 0 4, C is 0 5, you have to multiply, means you are going to add 0 4 5 times. Now when first time 0 4 is added, value of counter will be 5 minus 1, second time added, value of counter will be 5 minus 2, 5 minus 3. So we have to add 0 4 until 5 0 5 minus 0 5, means value of C will be 0 until C becomes 0. Now let me explain the program. Firstly we have declared MBI D00 to store the value of carry. If there will be carry, then we increment the value of D and store that value in 2050 location. Now second line I have declared accumulator 00. Reason behind is that we have to store output in this particular accumulator. The value of accumulator should be clear, should be 0. There should be no any duplicate value value already stored in accumulator. Now LXI S2050, that point the first number in means we can say X. Here move B comma M means we store X into register B, INX H and X represents second pointer, we get second number is C. Now we have to add B C times. So here C is X as counter. First add B means 0004. After that we check the value of carry, if there is carry generated or not. Suppose there is no carry generated, so that will be jump at DCRC, means decrement the value of counter by 1 and check the value of counter. If counter value not equal to 0, then again we have to add B. This process repeat until C becomes 0. Now store output, move A comma D, store carry here and end. Now second scenario is that suppose there is a carry generated. If carry generated means this instruction will be not work. this will be false, then this pointer moves increment d, this will increment the value of d, means d equal to 0 1 after this point, dcrc j and z, check the value of c, now it equal 0, again add, process is repeated again. Here in this case if carry is generated तो 0 1 will be stored. So basically this is a simple program कि how you can perform multiplication of two 8-bit number in 8085 microprocessor by using repeated addition method. So hope student you got my point. तो दैट इज
से मैंने पिछले वीडियो में आपको बताया था कि कंपेयर इंस्ट्रक्शन कैसे काम करता है। आज हम बात करने जा रहे हैं उसी इंस्ट्रक्शन को यूज करने जा रहे हैं। मतलब आज का जो प्रोग्राम है, राइट ए प्रोग्राम टू फाइंड लार्जर नंबर बिटवीन टू नंबर। बेसिकली लार्जेस्ट नंबर और स्मॉलेस्ट नंबर फाइंड करने से पहले आपको ये आना चाहिए कि लार्जर नंबर और स्मॉल नंबर कैसे फाइंड करते हैं, देन यू कैन फाइंड लार्जेस्ट एंड स्मॉलेस्ट नंबर्स विद इन ए प्रोग्राम। तो चलिए प्रोग्राम स्टार्ट करते हैं। बेसिकली हमें क्या करना है कि हमारे पास दो नंबर गिवन है कि मान लीजिए एक लोकेशन हमारी 2050 जिस पे एक नंबर स्टोर है x, 2051 पे y। हमें फाइंड करना है कि इन दोनों में लार्जर कौन है। जो भी लार्जर है हमको इसको इस लोकेशन पे स्टोर करना है। तो अगर आपने हमारे पुरानी वीडियो देखे होंगे तो आपको पता चलेगा कि 2050 क्या है और कैसे करते हैं। तो प्लीज़ देखिएगा, ज़रूर आपको ये समझ में आएगा। चलिए स्टार्ट करते हैं। देखिए इस केस में क्या होगा कि सबसे पहले हमें इस लोकेशन को स्टोर करना पड़ेगा। तो इसको स्टोर करने के लिए जो हमारा इंस्ट्रक्शन यूज होता है वो होता है LXI H2050। देखिए इसका मतलब क्या हुआ कि ये जो हमारी लोकेशन है इस HL पेयर में स्टोर हो गई। मीन्स L में 50 स्टोर हो गया, इसमें स्टोर हो गया 20। तो ये हमारा HL स्टोर हो गया। अब देखिए मैंने कहा था कि जो भी हमारा इंस्ट्रक्शन कंपेयर में यूज होता है वो बेसिकली एक्यूमुलेटर के साथ काम करता है। जैसे आपको याद होगा CMP R, इसका मतलब ये हुआ कि R कंपेयर विथ A। अब देखिए तो इन दोनों में से कोई ना कोई एक डेटा एक्यूमुलेटर में होना चाहिए, तभी दूसरा डाटा एक्यूमुलेटर के साथ कंपेयर करेगा। तो हमने यहाँ पर लिखा है कि एक इंस्ट्रक्शन मूव A, M। देखिए इसका मतलब समझने की कोशिश की कि M होता क्या। देखिए M HL पेयर में जो भी करंट लोकेशन स्टोर होगी उसके कंटेंट को रिप्रेजेंट करेगा। अब देखिए HL में क्या स्टोर है 2050, इसका कंटेंट क्या है X। तो यहाँ M का मतलब है X। तो इसको समझने की कोशिश कीजिए। अब क्या हुआ, हमने लिखा मूव A, M। इसका मतलब ये हुआ कि जो भी M का डाटा है A में कॉपी हो गया। तो इस इंस्ट्रक्शन के बाद A की वैल्यू हो गई X, M की वैल्यू हो गई X। तो एक डाटा आपका एक्यूमुलेटर में आ चुका है। सेम हमने दूसरा लोकेशन स्टोर किया 2051। ठीक है। अब देखिए मैंने यहाँ पे लिखा M। अब इस M का मतलब क्या हुआ, मैंने जो प्रीवियस लाइन बोला था कि करंट लोकेशन ऑफ HL पेयर। अब देखिए HL पेयर का करंट लोकेशन क्या है 2051, इसका डेटा क्या है Y। तो मीन्स यहाँ पे M की वैल्यू हो जाएगी Y। ये में क्या है X, यहाँ आ गया Y। अब X Y में कंपेयर होगा, मीन्स ये हो जाएगा CMP M। अब इस लाइन का मतलब हुआ कि कंपेयर M विथ A। अब M की वैल्यू यहाँ पे है Y, A की वैल्यू है X। अब हमने क्या कहा था कि अब A माइनस M होगा। उसके बाद हम चेक करेंगे कि कैरी फ्लैग सेट हो रहा है कि नहीं सेट हो रहा है। अगर कैरी फ्लैग सेट नहीं हो रहा है मीन्स एक्यूमुलेटर की वैल्यू बड़ी है, उसको हम स्टोर कर लेंगे STA 2052। इसका मतलब क्या होता है, स्टोर द कंटेंट ऑफ एक्यूमुलेटर एट गिवन लोकेशन। ये हो जाएगा हमारा प्रोग्राम एंड। मान लीजिए हम मान लेते हैं कि एक्यूमुलेटर की वैल्यू बड़ी है। ठीक है, तो उस केस में क्या होगा, एक्यूमुलेटर की वैल्यू यहाँ पे स्टोर हो जाएगी। ठीक है, और मान लीजिए एक्यूमुलेटर की वैल्यू बड़ी नहीं है, तब क्या होगा, M की वैल्यू यहाँ पे स्टोर होनी चाहिए। अब देखिए
कि कैसे हम चेक करेंगे कि कैरी फ्लैग सेट हो रहा है या नहीं हो रहा। तो हमारे पास एक इंस्ट्रक्शन है JNC, ये होता है जंप विथ नो कैरी। जंप विथ नो कैरी, अगर आपके पास कैरी नहीं है तो जहाँ भी आप जंप कराना चाहो कर सकते हो। तो यहाँ पे हम लिखते हैं JNC, ठीक है। मान लीजिए कि कैरी नहीं है, तो इसका मतलब क्या हुआ, एक्यूमुलेटर की वैल्यू स्टोर नहीं चाहिए, तो ये जंप कर जाएगा यहाँ पे, ठीक है। अभी मैं एक्सप्लेन करूँगा पूरा प्रोग्राम। अब मान लीजिए कि एक्यूमुलेटर की वैल्यू छोटी है, इसका मतलब क्या हुआ, y बड़ा है, तो हमें y को यहाँ पे स्टोर करना है। तो यहाँ लिखेंगे मूव a, m। ये हमारा पूरा प्रोग्राम है। अब मैं आपको एक एक लाइन एक्सप्लेन करता हूँ कि हो क्या रहा है। अगर कुछ भी ना समझ में आए तो आप कमेंट बॉक्स में लिख सकते हैं, मैं दोबारा इसको एक्सप्लेन कर सकता हूँ आपके लिए। अब देखिए, सबसे पहली लाइन में क्या कर रही है, LXI H2050। इसका मतलब ये हुआ कि ये लोकेशन हमारा HL पेयर में स्टोर हो गया। उसके बाद हमने लिखा मूव A, M। इसका मतलब ये हुआ कि जो X की वैल्यू है, M का मतलब हुआ कि जो भी HL पेयर में करंट लोकेशन है उसका डेटा, कंटेंट ऑफ HL पेयर, कंटेंट ऑफ करंट लोकेशन ऑफ HL पेयर। तो इसमें 2050 स्टोर है, इसका डाटा X है, तो M की वैल्यू X। मूव A, M का मतलब हो गया M की वैल्यू X, और यहाँ A में भी स्टोर हो गया X। सेम हमने सेकेंड लोकेशन के लिए किया, LXI H2051। अब इसने क्या किया, HL पेयर की जो प्रीवियस वैल्यू थी उसको रिप्लेस कर दिया। अब यहाँ M का मतलब हो जाएगा, इस पे जो डेटा है वो हो जाएगा Y। अब CMP M का मतलब हो गया कंपेयर विथ A एंड M। अब यहाँ पे हो गया M की वैल्यू Y और A की वैल्यू X। अब X Y में कंपेयर होगा। उसके बाद इंस्ट्रक्शन आता है JNC, जंप विथ नो कैरी। अब मान लीजिए हमने A और M को कंपेयर किया। A की मान लीजिए 2, 3 है और इसकी वैल्यू 2 है, तो 3 - 2 किया, 1 आया। मीन्स आपका कैरी भी जनरेट नहीं हो रहा, 0 भी नहीं हो रहा। जब कैरी जनरेट नहीं हो रहा है तो जंप विथ नो कैरी, जब कैरी नहीं है तो यहाँ पर जंप कर जाएगा। तो B क्या करेगा, स्टोर द कंटेंट ऑफ A एट दिस लोकेशन। तो A का कंटेंट क्या था, 3। तो 2052 केस में क्या हो गया, यहाँ पे 3 मीन्स लार्जर नंबर स्टोर हो गया, ठीक है। अब मान लीजिए यहाँ पे 2 है और यहाँ पे 3 है, इस केस में क्या हुआ, 3 नहीं जाएगा, कैरी जनरेट हो गया। कैरी जनरेट हुआ तो ये कंडीशन हो गई फेल, क्योंकि ये जंप तो तब करेगा जब कैरी जनरेट नहीं होगी। अब ये कैरी जनरेट होगी तो कंडीशन हो गई फेल। अब वो नीचे आएगा मूव A, M। अब M की वैल्यू क्या थी, 3, तो A में आ जाएगा 3 और यहाँ स्टोर हो जाएगा 3। तो इस तरह से बेसिकली ये कंपेयर का प्रोग्राम काम करता है। कैसे हम लार्जर और स्मॉलर नंबर फाइंड कर सकते हैं, तो इस तरह से आप लार्जर नंबर फाइंड कर सकते हैं। अगर यहाँ पर आप JC लिख दोगे ना तो ये स्मॉलर नंबर का प्रोग्राम हो जाएगा। सिर्फ इसको रिप्लेस करना है JC से, देन ये स्मॉलर नंबर देगा। तो इस तरह से हम दो नंबर को कंपेयर करके लार्जर और स्मॉलर नंबर फाइंड कर सकते हैं। ए प्रोग्राम टू गेट लार्जेस्ट नंबर इन एन गिवन एरे यूजिंग 8085 microprocessor means here I am going to do assembly language programming to get largest number within an array. So just let me make you understand what is basically program is that. Suppose here is array, okay, this is array of memory location, or you can say the data, and every memory location contains some data. So you have to find which number is largest. Means you can take another example. Suppose these are number which are stored at various memory location, something like this, and we have to write a program to find largest number within this array. Okay, so we have to write assembly language program. So this is program. So how you can do this program? Firstly, just let me explain the concept, how you can do this. Firstly, you have to find the number of data which is available in array. Means this can be 5 data, this can be 6 data, this can be 7, 8, 9, 10, whatever number of data can be possible. So firstly you have to initialize a counter for number of data. Suppose here 5 data are given, then firstly you have to initialize a counter of 5 data. Means you have to compare 5 data to each other and then you have to get output. So concept is that firstly store first number in accumulator, okay, and compare with
second data. If data which is available in accumulator is larger than this data, then compare with next data. This is first condition. And suppose the data at memory location is larger than accumulator, then firstly store this number in accumulator, then compare with third number. And same, compare accumulator with third. If data of accumulator is larger than this, then compare with fourth number. If the data in accumulator is less than this, then firstly move this data in accumulator, then compare with fourth number. So basically you have to repeat this process till all the data compared with accumulator or to each other. Okay, so firstly what you have to do, first step is that initialize the counter, and that will contain how many number you are going to compare to each other. Okay, initialize the counter just using register C. You can initialize the counter, and then get first number, get the first data. First data means data which is available is first memory location. Okay, so get the first data, move that data into accumulator. Okay, and here decrement the counter. Why we are decrementing the counter? Because already we have taken one data in accumulator, so we have remaining 4 to 5 data. Suppose I have taken 10 data, so one data I have taken in accumulator, that's why -1. Now we have 9 data, so the content of accumulator have to compare with this 9 data. That's why we decrement the counter here. Okay, now get the second data. Okay, and compare first data and second data. First data means which is available in the accumulator, and this is current memory location. Now you have to compare first data means accumulator with second data. Now let's see, if carry is generated, then move second data in accumulator. Okay, second data in accumulator, and decrement the counter by 1 again. Why we are decrementing? Because here if carry is generated means your second data is larger than accumulator, so just move that data in accumulator, means we have completed comparison of 2 data already. That's why we are decrementing the counter here by 1 again. Now check if counter value is not equal to 0, then we have to compare again, get the next data and follow this process again, and then store the result and end the program. Okay, so just write program. So firstly let me explain again. This program is this. Suppose this is memory location. Okay, here number is x1 is store, here x2, here x3, x4, x5. Okay, and suppose these are for only for understanding purpose, 22, 42, 23, 45 and 23, and we have to find which number is largest. So basically we have to write a program. Okay, so what I have discussed, let me explain step by step. Firstly we will declare a counter, and suppose these are 5 numbers, so here MBI see 05 till now I think you have no any issue, and get the first data. So LXI H 4050, we get first data. I move that data in accumulator, means move accumulator A comma M. Till now you have no any problem, I can hope. And here decrement the counter by 1, so DCR C. Now value of C is 04 here, because here 05. Okay, now we have to get second data. So INX H, when I am going to do INX H, means incrementing the pointer location of this, so this is going to represent the second data. Now we have to compare CMP M, means M means this represents second data, and comparison will be held between A and M. And as I have already told in my previous video, basically in comparison, firstly you have to subtract this M from M and then check the value of carry flag and zero flag. If just look at here, if A is less than M, then what happen? Carry will be generated, because suppose this is 05 and 04, when you are going to subtract 05 from 04, definitely this will be not happen, then you have to take carry. Means if carry is generated, so the content of memory location is larger than accumulator. If accumulator is given, means there will be no carry. If A equal to M, then zero flag will be set. So by this concept, basically we have to find which number is larger. So here when you are going to comparing A and M, suppose there is a carry. Okay, if carry generated, means the second number, the number which is represent M, is larger than accumulator, so then we have to move this number into accumulator. So here move A comma M. If this is fail, if there is a carry, means firstly if there is a carry, means second data is larger than accumulator, so we have to move second data in accumulator. So here, and again DCR C, because we have already completed comparison of two number. Now check value of DCRC J and Z. If it is 0, means your comparison is complete. If it is not 0, then we have to get next data. Okay, so here we get next data, means now I am talking about third data, and compare with accumulator, because here second data is stored in accumulator. If you are following the concept, if there is carry generated, okay, then again this process will be held. Now here value of C will be 2, this is not equal to 0, again that will perform INX H, and by this method we are going to compare, and here store the output, whatever location if you want to store, this is output and this is end of program. So this is very simple program. Now let me discuss by taking this example, so you can easily understand how this is going to work. Okay, and here this will be jump here. Let me explain. Now you have to consider this number. Okay, this number. Firstly, here M means 22. So after this value of A is 22. Okay, and C value will be 04. Now INX H means this is pointing this 42. Here M is 42. Now you have to compare 22 and 42. When you are going to subtract 42 from the 22, means that will be not happen, then you have to take a borrow, means carry flag will be set, means there will be carry generated. So in this case this condition will be fail, because here jump if no carry. If there is no carry, then it will be jump, otherwise this will be not execute, your pointer will be down. Move A comma M. After this, the value of A will be 42 and value of C will be 3. Now check the value of C. If it is 0, if it is not 0, then jump and this. Now INX H means now this will be point X3. So here value of M will be 23. Okay, and the value of accumulator is 42. Now 42 and 23 will be compared to each other. So here you can see the value of accumulator is means when you are going to subtract, so there is no carry, means now this condition is true, then it will be jump here. Now DCR will be 2, again it is not 0, then again it will jump, now it will point 45. What happened? Now value of M is 45 and content of accumulator is 42, then again we are going to subtract, this will be not happen, then this condition again fail. Now move A comma M, after this content of accumulator will be 45, here value of C will be 1 and again it will not 0, again it will take next number, and then by doing this we can find finally which number is largest. So let me explain it again with a clear picture so you can easily understand. Here okay, so let me draw the diagram. This is memory location. Whatever number you want you can change. I am only considering 4 numbers, so I can understand. Suppose here 23, 44, 46 and 26. You have to find which number is largest. So firstly you have to declare counter, means MBI C04, because we are going to compare 4 number. Now you have to take first number, so LXI H 4050 and move this number in accumulator, move A comma M. Till now there is no problem, and here we have to DCRC because already we have taken one number, so DCRC. Now get second number INX H, here we can get second number. Now we have to compare first number in second number, so compare M, means we are going to comparing A and M, so A minus M you can write. So here the value of A is 23, M is 44. Definitely this will be not happen, so carry flag will be set. Okay, if your carry flag is set, then you have to move this number into accumulator, so move A comma M. Now again DCRC because we have compared one number more. Okay, now check the value of C, J and Z. If it is 0, then store your output and the program. If it is not 0, then again get next number. Then what will be next number will be 46. So here value of M is 46, content of accumulator is 44. Again 44 minus 46, this will be not happen, means your carry flag will be set, this condition is failed. Again after this content of accumulator will be 46, DCRC, here value of C is 1, again it is not 0, again jump, now it will take 26 here, then 46 minus 26 means there is no carry, this condition is true. Now then it will jump here to here, value of C is 0 and it is 0, then it will be come out, and what will you get? We will get 46 in accumulator, and this is largest number. So by using this method we can easily find which number is largest. Ones complement and twos complement of a given number using microprocessor programming. So let me explain what is basically program about. If you have a study about digital electronics and microprocessor, definitely you know what is ones complement and twos complement. So program is this: suppose X is a number that is stored at this memory location, and
we have to find ones complement of this given number x, and we have to store this ones complement in this location and twos complement in this location. So basically this is basic program, and we have to write assembly language program to perform this particular operation. Now let me discuss what is ones complement. Suppose there is a number 0 1. If you write hexadecimal, basically microprocessor 8085 works in hexadecimal number, so I am trying to write this in hexadecimal number. So this will be 00, this will be 001. Now what is ones complement? Ones complement of 01 will be 1 1 1 1 1 0, means 1 is converted in 0, 0 is converted in 1. Now you have to find twos complement, then just ones complement plus 1. When you add 1 in ones complement, that become twos complement. So basically we have to write this program to perform operation. Means program for ones complement and twos complement. So basically this is program which you have to perform. Now first step will be just store the number in accumulator, find ones complement of this of accumulator. Third, store ones complement at 3050, and fourth step, get twos complement and store at 3051. Now every step we have to perform in assembly language program. So just for the first line we have to store the number in accumulator. Now just I write LDA 2050, means what will happen in this instruction, the content of this location will directly store in accumulator. Means suppose at 05 there is x, means after this instruction A have x, means we just transfer this number from this location into accumulator. तो डायरेक्टली लोड डेटा accumulator, मीन्स आप इसको कह सकते हैं कि लोड accumulator डायरेक्टली, मीन्स इस पे जो भी नंबर गिवन होगा, नाउ दैट नंबर विल शिफ्टेड इन accumulator. नाउ we have to find ones complement. So in 8085 microprocessor you have an instruction that is called CMA. This what does? It complements the accumulator, means number that is given in accumulator, just find out complements of this instruction. कहने का मतलब है accumulator में जो भी नंबर स्टोर होगा ये उसका क्या करेगा, ones complement फाइंड कर देगा, निकाल देगा. तो बेसिकली दिस इंस्ट्रक्शन यूज टू फाइंड वंस कम्प्लीमेंट ऑफ एनी गिवन नंबर इन एक्यूमुलेटर. नाउ इन फर्स्ट लाइन में हमने क्या किया, उस नंबर को एक्यूमुलेटर में लिया, सीएमए ने क्या किया, एक्यूमुलेटर में जो भी डाटा है उसका वंस कम्प्लीमेंट निकाल दिया. तो मतलब सेकेंड स्टेप इज कंप्लीट. इन नाउ थर्ड स्टेप वी हैड टू स्टोर वन कम्प्लीमेंट एट 3050, मीन्स जस्ट राइट STA 3050. Now meaning of this instruction is store the content of accumulator at given location. तो accumulator का जो भी content होगा that will store at given location 3050. Now we have to find twos complement. तो already have said कि if you add 1 in one's complement, then usually you can find twos complement of a given number. Now there are two methods to add 01 in accumulator. One is just make increment A. This will be increase the content of accumulator by 1, then you can store STA 3051, and that is end of program. This is one method. Second is you can replace this line by ADI01. This will also add 0 in accumulator. So basically these are two methods to find twos complement, then store at this location. So basically this is a simple program. By using this you can find ones complement and twos complement of a given number. तो लेट मी रिपीट द प्रोग्राम अगेन कि हाउ यू कैन परफॉर्म दिस प्रोग्राम. नाउ firstly you have to store data accumulator. This is location. Now move this content of this location accumulator, already done. Now you have to find complement to CMA, that will be find ones complement of given number. After that just store ones complement at 3050. Now find twos complement INR A or ADI 01. One of them you can use, so that will find twos complement, store twos complement at 3051 and the program. So this is a simple program to find ones complement and twos complement of a given number by using assembly language programming. How to find the square of a given number in 8085 microprocessor means I am going to perform assembly language programming for finding square of a given number. देखिए there are various method. By using this method you can find square, but in this method I am going to use of odd number. By using odd number, how you can find square of a given number. So let's start the video.
Every single day I'm gonna make something great.
तो ओके दोस्तों, अपना वीडियो स्टार्ट करते हैं. तो सबसे पहले मैं बेसिक जो मेथड होते हैं स्क्वायर फाइंड करने की, हम उसकी बात कर लेते हैं. हम बचपन से पढ़ते आ रहे हैं कि भाई अगर किसी नंबर का स्क्वायर फाइंड करना है तो उस नंबर को उसमें से मल्टीप्लाई करो. जैसे 2 का स्क्वायर फाइंड करना है, इसका मतलब हुआ 2 × 2 = 4. तो ये एक बेसिकली एक सिंपल मेथड होता था स्क्वायर फाइंड करने के लिए. इस मेथड को भी आप प्रोग्रामिंग के थ्रू 8085 में आप स्क्वायर फाइंड करने के लिए यूज कर सकते हैं. तो इसका भी लॉजिक आप इम्प्लीमेंट कर सकते हैं. लेकिन इस वीडियो में मैं आपको बताने जा रहा हूँ एक दूसरा तरीका जिसको यूज़ करके हम किसी भी नंबर का स्क्वायर फाइंड कर सकते हैं. जैसे देखिए दोस्तों, मेरा कहने का मतलब है कि सपोज मुझे 2 का स्क्वायर फाइंड करना है. तो एक तो तरीका है कि आप 2 × 2 मल्टीप्लाई करो. एक सेकेंड मेथड क्या है जो इस वीडियो में डिस्कस करने जा रहा हूँ कि जिसका आपको स्क्वायर निकालना है उतने आप कंसेक्यूटिव ऑड नंबर को ऐड कर दीजिए. मीन्स इफ यू वांट टू फाइंड स्क्वायर ऑफ 2, देन यू हैव टू ऐड 2 कंसेक्यूटिव ऑड नंबर मीन्स 4. सपोज यू हैव टू फाइंड स्क्वायर ऑफ 3, देन यू हैव टू ऐड 3 कंसेक्यूटिव ऑड नंबर मीन्स 9. सेम एज लाइक फॉर 4, यू हैव टू ऐड 4 कंसेक्यूटिव ऑड नंबर. दिस इज 4 9 16. So by using odd number you can also find square of any given number. So in this video I am going to find square by using this process, means by adding odd number. Now talking about programming. तो जब भी हम प्रोग्राम करते हैं या जब भी हम कोई प्रोग्राम लिखते हैं तो सबसे पहले हमें उसका लॉजिक पता होना चाहिए कि लॉजिक हम क्या यूज कर रहे हैं. तो इसमें हम बेसिकली लॉजिक यूज कर रहे हैं कि जिसका भी हमें स्क्वायर फाइंड करना है उतने हम ऑड नंबर ऐड करेंगे. तो दोस्तों इसका जो फर्स्ट स्टेप है, जिस नंबर को या जिस नंबर का आपका स्क्वायर फाइंड करना है तो सबसे पहले हम उसको सेट कर देंगे एज काउंटर. काउंटर क्या होगा? वो नंबर होगा जिसका हमें स्क्वायर फाइंड करना है. सेकेंड स्टेप, हम फर्स्ट ऑड नंबर फाइंड करेंगे, फर्स्ट ऑड नंबर. थर्ड स्टेप क्या होगा? क्लियर द एक्यूमुलेटर टू स्टोर आउटपुट. उसके बाद ऐड फर्स्ट नंबर टू एक्यूमुलेटर. नाउ उसके बाद हमें क्या करना है? गेट सेकेंड ऑड नंबर and add to एक्यूमुलेटर। ये प्रोसेस हम तब तक रिपीट करेंगे जब तक हमारी काउंटर की वैल्यू 0 ना हो जाए। उसके बाद फाइनली हम आउटपुट स्टोर कर लेंगे, क्योंकि हमारा बाय डिफ़ॉल्ट जो आउटपुट स्टोर हो रहा है वो एक्यूमुलेटर में स्टोर हो रहा है। तो बेसिकली ये प्रोसीजर है, इसी प्रोसीजर को फॉलो अप करके अब हमें प्रोग्राम लिखना है। तो हमने क्या कहा कि सबसे पहले हम काउंटर सेट करेंगे। काउंटर की वैल्यू वो होगी जिस नंबर का हमें स्क्वायर फाइंड करना है। उसके बाद हम फर्स्ट ऑड नंबर गेट करेंगे। उसके बाद हमने एक्यूमुलेटर को 0 कर दिया, फिर फर्स्ट ऑड नंबर हमने एक्यूमुलेटर में ऐड किया, फिर सेकेंड ऑड नंबर हम गेट करेंगे, उसके बाद उसको एक्यूमुलेटर में ऐड कर देंगे। ये प्रोसेस हमारा तब तक चलेगा जब तक काउंटर की वैल्यू 0 ना हो जाए। तो दोस्तों ये तो रहा बेसिक कंसेप्ट। अब हम स्टार्ट करते हैं कि हम प्रोग्रामिंग इसकी कैसे करते हैं। अगर आपको थोड़ा भी आइडिया होगा, आपने असेंबली लैंग्वेज प्रोग्रामिंग की है, तो आप इजीली इसको अंडरस्टैंड कर सकते हैं। अगर आपको नहीं समझ में आ रहा है, इसका मतलब आप माइक्रो प्रोसेसर आपने पढ़ा नहीं है या आपको यह इंस्ट्रक्शन के बारे में पता नहीं है। अगर थोड़े बहुत इंस्ट्रक्शन के बारे में आपको आइडिया है तो इजीली इस प्रोग्राम को आप समझ सकते हैं। तो चलिए अब आगे बढ़ते हैं, हम प्रोग्रामिंग बताते हैं कि इसकी प्रोग्रामिंग कैसे होगी। तो दोस्तों बेसिकली ये हमारा प्रोसीजर है जिसको फॉलो अप करके हमें स्क्वायर निकालना है किसी भी नंबर का। तो दोस्तों सबसे पहले हम बात करते हैं सेट द नंबर हु स्क्वायर्स टू फाइंड एज काउंटर। सबसे पहले हम क्या है, जिस नंबर का हमें स्क्वायर फाइंड करना है उसका हम काउंटर सेट कर देंगे। तो चलिए मान लेते हैं हमारा किसी लोकेशन पे वो नंबर स्टोर है। तो जैसे हमने लिखा LXI H 2050, इसका मतलब क्या हुआ, ये हमने एक लोकेशन डिसाइड कर दिया कि इस पे हमारा नंबर स्टोर होगा जिसे हमें स्क्वायर फाइंड करना है। अब हमने लिखा मूव C, M। देखिए मूव C, M का मतलब क्या होता है कि इस लोकेशन पे जो भी नंबर स्टोर होगा वो C में कॉपी हो जाएगा। आपको अपने स्टार्टिंग में इंस्ट्रक्शन पढ़ी होगी, नहीं तो आप मेरे पुरानी वीडियो देख सकते हैं। मूव A, B का मतलब होता है कॉपी द डाटा ऑफ B इंटू A। इन सेम केस यहाँ लिखा है मूव C, M। M हमेशा क्या होता है कि HL पेयर में जो भी लोकेशन स्टोर होती है उसको कंटेंट को M रिप्रेजेंट किया जाता है। मीन्स अगर हमने लिखा है LXH 2050, मान लीजिए इस लोकेशन पे कोई डाटा हमारा X स्टोर है, तो इस लाइन का मतलब ये हुआ कि जो X है वो C में स्टोर हो जाएगा। मीन्स इस लाइन के बाद C की वैल्यू हो जाएगी X। इस तरह से क्या हुआ, C एज यहाँ पर हमने इसको काउंटर एज्यूम कर लिया। मतलब कि मान लीजिए इस लोकेशन पे 5 स्टोर है, तो इसका मतलब आपको 5 का स्क्वायर फाइंड करना है। अब हमने क्या किया, उस 5 को C में स्टोर कर लिया। मीन्स अब यहाँ पे C की वैल्यू हो गई 5। जैसे हमने माना है कि एज्यूम किया X है, तो यहाँ C की वैल्यू हो गई X। मीन्स अब हो गया X एज काउंटर या C एज काउंटर। तो ये आपकी जो पहली लाइन थी वो हो गई। अब लिखा है गेट द फर्स्ट ऑड नंबर। ओके, तो हमने लिखा एक MVI B, 01, क्योंकि जो हमारा फर्स्ट ऑड नंबर होगा वो 0 नंबर होगा, 01 होगा। और MVI यूज होता है किसी भी रजिस्टर में डेटा को स्टोर करने के लिए। जैसे हमने लिखा है MVI B, 06, मतलब 06 B में स्टोर हो गया। और आपको पता है कि जो फर्स्ट ऑड नंबर होता है 01, तो हमने यहाँ पे लिखा है MVI B, 01। मीन्स आपका फर्स्ट ऑड नंबर यहाँ पे मिल गया, मतलब सेकेंड लाइन आपकी हो गई। थर्ड होता है क्लियर द एक्यूमुलेटर। क्लियर द एक्यूमुलेटर का मतलब ये हुआ कि आपको एक्यूमुलेटर की वैल्यू को 0 करना है। तो हमने यहाँ पे लिख दिया 00। जैसे MVI B 01 था, ऐसे हमने MVI ये 00 कर दिया। अब यहाँ पे एक्यूमुलेटर की वैल्यू हो गई 00, आपकी तीसरी लाइन हो गई। अब उसके बाद हमने लिखा है ऐड फर्स्ट नंबर टू एक्यूमुलेटर। ऐड फर्स्ट नंबर मतलब जो आपका फर्स्ट ऑड नंबर है, तो हमने लिखा ऐड B। देखिए ऐड B का मतलब क्या होता है, A + B एंड स्टोर द आउटपुट इन A। तो A की वैल्यू क्या थी 00, B की वैल्यू क्या थी 01, तो यहाँ पे A में स्टोर हो गया 01। क्योंकि आपको पता होगा कि जो भी ऑपरेशन हम माइक्रो प्रोसेसर में परफॉर्म करते हैं बाय डिफ़ॉल्ट जो उसका आउटपुट होता है वो एक्यूमुलेटर में स्टोर होता है। तो इस लाइन के बाद हो गया A की वैल्यू 01, मीन्स आपका ये भी हो गया। उस पर लिखा है गेट सेकेंड ऑड नंबर। देखिए अगर पहला ऑड नंबर 01 है तो दूसरा ऑड नंबर 3 होगा। तीसरा 5 होगा, फोर्थ 7 हो गया। इसमें 2 का गैप है, इसमें 2 का गैप है, इसमें 2 का गैप है। तो अब देखिए हम क्या करेंगे, जैसे ही आपने एक और नंबर किया, सपोज हमें 5 का स्क्वायर फाइंड करना है, तो हमें ऐड करना है 1 3 5 7 9, 5 हमें ऐड करना। आपने एक ऐड कर दिया, मीन्स यहाँ पर आपका काउंटर हो गया एक कम। इसका मतलब हुआ कि अब आपको सिर्फ 4 नंबर ऐड करने। तो ये हो गया DCR-C। अब आपको सेकेंड ऑड नंबर गेट करना है, तो हमने लिखा INR-B और INR-B। देखिए INR यूज होता है टू इंक्रीमेंट द कंटेंट ऑफ रजिस्टर। अब क्या हुआ कि यहाँ पर देख सकते हैं वैल्यू की 0 1 है। जैसे हमने INR-B किया, यहाँ पर B की वैल्यू हो गई 0 2। एक बार और किया, यहाँ B की वैल्यू हो गई 0 3। ये आपका सेकेंड ऑड नंबर मिल गया। ओके, सेकेंड ऑड नंबर मिल गया। अब हम चेक करेंगे कि काउंटर की वैल्यू 0 तो नहीं है। अगर काउंटर की वैल्यू 0 हो गई मीन्स आपका स्क्वायर फाइंड हो चुका है। अगर काउंटर की वैल्यू 0 नहीं हुई तो इस ऑड को हमें दोबारा एक्यूमुलेटर में ऐड करना पड़ेगा। तो यहाँ पर हम इंस्ट्रक्शन लिखते हैं JNG। ये होता है जंप इफ नो 0। ये बेसिकली क्या करता है, ये काउंटर की वैल्यू चेक करेगा कि काउंटर की वैल्यू 0 है कि नहीं है। अगर 0 नहीं है तो जो भी ऑपरेशन बाबा परफॉर्म करना है वहाँ पे जंप कर जाएगा। इस केस में हमें क्या करना है, जब तक इसकी वैल्यू 0 नहीं होती है तब तक हमें वैल्यू को ऐड करना है। तो ये बेसिकली क्या हो जाएगा, जंप करेगा यहाँ पे। अगर वैल्यू 0 हो गई तो ये कंडीशन हो जाएगी फॉल्स, वो आगे बढ़ जाएगा। अगर वैल्यू 0 नहीं होगी तब तक ये ऑपरेशन रिपीट करेगा। अब देखिए क्या होगा, ऐड B। ऐड B का मतलब हो गया A + B। अब A की वैल्यू क्या थी 0 1। अब यहाँ पे B की वैल्यू क्या हो गई 0 थी। तो अब ये क्या करेगा 0 1 + 0 3। फिर आया यहाँ पे C की वैल्यू कितनी हो जाएगी, जो भी x था तो x - 2 हो गई। अब यहाँ पे B की वैल्यू कितनी हो गई 3 थी तो 4 हो गई। अब यहाँ हो गई 5। फिर ये चेक करेगा कि C की वैल्यू 0 है कि नहीं है। 0 नहीं है तो फिर जंप करेगा, यहाँ पे ऐड हो जाएगा 5। तो ये प्रोसेस ऐसे ही चलता रहेगा जब तक इसकी वैल्यू 0 ना हो जाए। मीन्स जब तक काउंटर की वैल्यू 0 नहीं होगी तब तक ये हमारा लूप चलता रहेगा। जैसे ही काउंटर की वैल्यू 0 हो गई तो ये हो गया गलत। अब ये जंप नहीं करेगा, सीधे नीचे आ जाएगा। अब हमने यहाँ पर लिखा STA 2052। अब ये क्या करेगा, स्टोर द कंटेंट ऑफ एक्यूमुलेटर एट गिवन लोकेशन। तो इस तरह से क्या होगा, फाइनली ये में जो भी स्टोर होगा इस लोकेशन पे आपका स्टोर हो जाएगा। वो कुछ भी हो सकता है और यहाँ पर आपका प्रोग्राम हो जाएगा एंड। तो इस तरह से आप प्रोग्रामिंग कर सकते हैं। चलिए मैं x की जगह पर कोई वैल्यू रख के इस प्रोग्राम को आपको दोबारा एक्सप्लेन कर देता हूँ ताकि अच्छी तरह से आपको समझ में आ सके। तो दोस्तों मान लेता हूँ कि काउंटर की वैल्यू 4 है, ठीक है। तो हमने यहाँ पे लिखा LXI H 2050। प्रोसेस सेम रहेगा। हमने यहाँ पे लिखा मूव C, M। अब मैं यहाँ पे एज्यूम करता हूँ कि C की वैल्यू 4 है, मतलब हमें 4 का स्क्वायर फाइंड करना है। उसके बाद हमने क्या किया, MVI ये एक्यूमुलेटर की वैल्यू हो गई 0 0। ओके, उसके बाद हमने MVI B फर्स्ट ऑड नंबर, ये हो गया आपका फर्स्ट ऑड नंबर। उसके बाद हमने किया ऐड B, इसका मतलब हो गया 0 0 + 0 1। एक्यूमुलेटर में स्टोर हो गया 0 1। आपका फर्स्ट ऑड नंबर मिल गया, मीन्स आपका काउंटर हो गया एक कम, DCR-C। अब यहाँ पर हो गया C की वैल्यू 3। उसके बाद हम गेट करेंगे सेकेंड ऑड नंबर, तो ये हो जाएगा INR-B। इस स्टेप में B की वैल्यू 0 2। INR-B किया तो यहाँ पर हो गया 0 3। अब हम करेंगे C की वैल्यू को चेक, JNZ। अब यहाँ पे C की वैल्यू 3 है, मीन्स ये नॉट इक्वल टू 0 है। जब तक इसकी वैल्यू 0 नहीं होगी तब तक ये ऐड करता रहेगा। इस केस में क्या होगा, ये हो गया यहाँ पे जंप। अब देखिए क्या होगा, फिर ऐड B करेगा और ऐड B का मतलब होता है A + B। अब A का कंटेंट कितना था 0 1 और B का कंटेंट क्या है 3, तो यहाँ पर ऐड हो गया 3। ये नीचे आएगा। अब यहाँ पे C की वैल्यू हो गई 2। इंक्रीमेंट B, यहाँ पे होगी इसकी वैल्यू 4 क्योंकि 3 था। यहाँ होगी 5, इसकी वैल्यू अभी 0 नहीं है। फिर जंप करेगा, यहाँ पे ऐड हो गया 05, ओके 05। अब अगेन आएंगे, यहाँ पे हो गया DCR की वैल्यू 1, फिर से एक कम हो गया, V की वैल्यू हो जाएगी 6, यहाँ हो जाएगी 7। अब देखेंगे C की वैल्यू 1 है, अभी भी ये 0 नहीं है तो यहाँ पर ऐड कर देगा 7, ओके। फिर अगेन आए, अब C की वैल्यू क्या हो गई 0, B की वैल्यू क्या हो जाएगी 8, यहाँ हो जाएगी 9। अब ये चेक करेगा C की वैल्यू 0 है कि नहीं है। अब देखिए इस केस में क्या हुआ, C की वैल्यू 0 है, मीन्स एक कंडीशन आपकी फॉल्स हो गई, ये आ जाएगा नीचे, यहाँ हो जाएगा STA 2052। अभी क्या करेगा, स्टोर द कंटेंट ऑफ A एट दिस लोकेशन। अब हम A की कंटेंट की बात करते हैं तो ये क्या है 4, 9, 16, तो ये 16 यहाँ स्टोर हो जाएगा 16। अब 4 का स्क्वायर कितना होता है 16। तो इस तरह से आप किसी भी नंबर का आप स्क्वायर फाइंड कर सकते हैं इन 8085 माइक्रो प्रोसेसर। अगर कोई नंबर गिवन है तो आप कैसे फाइंड आउट करेंगे कि वो नंबर इवन है और ऑड है। बेसिकली ये 8085 की प्रोग्रामिंग है, तो यू हैव टू राइट ए प्रोग्राम टू चेक कि गिवन नंबर इज ऑड या इवन। तो दोस्तों सबसे पहले हम समझते हैं कि भाई लॉजिक क्या है इवन और ऑड का इन टर्म ऑफ 8085 माइक्रो प्रोसेसर। तो हम पहले आपको मैं कुछ ऑड नंबर और कुछ इवन नंबर लिख के दिखाता हूँ, तो शायद आप इजीली अंडरस्टैंड कर सकते हैं कि इसका कंसेप्ट है क्या। जैसे हमने एक ऑड नंबर लिया 01, 03 और 05। अब इसको हम अगर 8 बिट के फॉर्म में लिखते हैं तो इसको हम लिख सकते हैं 4 टाइम 0 1, ये रिप्रेजेंट हमारा कर रहा है 1 का। अगर इसको हम 8 बिट के फॉर्म में लिखेंगे तो इसका जो होता है वो होता है 0 0 1 1। अगर हम 5 की करें तो ये हो जाएगा 0 1 0 1। ये हो गया हमारा ऑड नंबर। वैसे ही अगर हम इवन नंबर लिखें, इसकी बात करते हैं तो इसको हम लिखते हैं 0 0 0 0 0 0 1 0 0 0 0 1 0 0। अगर इसकी बात करें 1 1 0। तो देखिए दोस्तों आप देख सकते हैं कि जो हमारा ऑड नंबर है इसको हम बोलते हैं LSB, इसको बोलते हैं MSB, मतलब लिस्ट सिग्निफिकेंट बिट, इसको बोलते हैं मोस्ट सिग्निफिकेंट बिट। सेम इवन। तो आप देख सकते हैं कि ऑड नंबर के केस में क्या है कि जो आपकी D7 बिट है वो सब में 1 है। अगर आप 7 का भी लिखेंगे तो लास्ट में 111 आएगा, और इवन के में देख रहे होंगे तो लास्ट बिट हमारा 0 है। तो कहने का मतलब है अगर कोई भी नंबर है, अगर उसकी लास्ट बिट मतलब D0, क्योंकि जो बिट का नॉमेनक्लेचर होता है बेसिकली D0 से लेकर D7 तक होता है। तो जो D0 बिट है, आप इसको B0 भी बोल सकते हैं, आपकी मर्जी है। मतलब कहने का मतलब है कि जो LSB है अगर इसकी वैल्यू 1 है मीन्स वो ऑड नंबर होगा, अगर उसकी वैल्यू 0 है मतलब वो इवन नंबर होगा। आप कोई भी नंबर लेके इसको चेक कर सकते हैं। तो ये तो हो गया ऑड और इवन का। तो सिंपल सा कंसेप्ट है, अगर किसी नंबर का हमें ये बिट वाली पता चल जाए कि बिट क्या है तो हम बता सकते हैं कि नंबर इवन है कि ऑड है। अगर ये वाली बिट 1 है तो नंबर ऑड है, अगर 0 है तो नंबर इवन है। तो ऐसे हम फाइंड करेंगे कोई भी नंबर अगर गिवन है तो हमें बेसिकली इस बिट को फाइंड करना है कि ये वाली बिट है क्या, इवन है या ऑड है। मीन्स 1 है या 0 है। 1 है तो नंबर ऑड हो जाएगा, 0 है तो नंबर इवन हो जाएगा। तो ये बेसिकली हमारा इसी लॉजिक को इम्प्लीमेंट करना है। अब देखिए सर करना क्या है कि हम करेंगे क्या कि जो भी नंबर हमारा गिवन है किसी भी मेमोरी लोकेशन पे, सपोज हमारा एक नंबर गिवन है इस लोकेशन पे, कोई नंबर हमारा x है और हमें फाइंड करना है कि ये नंबर इवन है कि ऑड है। तो सबसे पहले हम क्या करेंगे, इस नंबर को हम किलोमीटर में मूव करेंगे। ये नंबर हमारा किलोमीटर में आ गया। अब हम क्या करेंगे, इसकी जो हमारी D0 बिट है या LSB है उसकी वैल्यू को चेक करेंगे कि ये इवन 0 है कि 1 है। अगर 1 होगा मीन्स नंबर हमारा ऑड हो जाएगा, अगर 0 होगा मतलब नंबर हमारा इवन होगा। अब देखिए, अब जैसे ही हमें पता चला, जैसे ही हमने चेक किया कि भाई ये जो D0 बिट है 1 है या तो 0 है। देखिए अगर 1 होगी तो नंबर ऑड होगा, 0 होगा तो इवन होगा। तो हमें कैसे पता चलेगा कि जो हमने नंबर फाइंड किया वो इवन है कि ऑड है। तो इसका मतलब है कि कुछ ना कुछ हमें एक सिंबॉलिक कैरेक्टर या आप कह सकते हैं कोई नंबर हमें स्टोर करना पड़ेगा जो हमें बताएगा कि नंबर इवन है कि ऑड है। तो दोस्तों इसके लिए हम क्या करेंगे, हम ए में 02 स्टोर करेंगे कि जो ये बताएगा कि नंबर इवन है, और ए में स्टोर करेंगे 01 जो बताएगा कि नंबर ऑड है। मीन्स सारी प्रोग्रामिंग करने के बाद, इस प्रोग्राम को एग्जीक्यूट करने के बाद ये जो हमारा फाइनल आउटपुट होगा ये हमें बताएगा कि नंबर इवन है कि ऑड है। कहने का मतलब ये हुआ कि मान लीजिए कोई एक्स नंबर है, हमने इसको चेक किया, अगर ये नंबर इवन होगा तो हम कैलकुलेटर में 02 स्टोर कर देंगे, अगर ये नंबर ऑड होगा तो हम कैलकुलेटर में 01 स्टोर कर देंगे ताकि हमें पता चल जाए कि नंबर इवन है कि ऑड है। तो बेसिकली हमारा ये कंसेप्ट है। और हमारा लॉजिक क्या है कि जो भी नंबर हमारे कैलकुलेटर में स्टोर होगा उसके D7 बिट को हम D0 बिट को चेक करेंगे कि 1 है कि 0 है। तो दोस्तों सबसे पहले हमने एक LXI H लिया 2050, ये बेसिकली हमारा लोकेशन है जिस पर नंबर गिवन है। इसको हम लिख देते हैं लोकेशन एट विच नंबर इज गिवन। अब हमने क्या किया, इस लोकेशन पे जो भी नंबर है उसको कैलकुलेटर में मूव कर दिया। हमने किया मूव A, M, ये हो गया हमारा मूव M। अब हमें क्या करना है, जैसा कि मैंने बताया कि कोई भी नंबर है, ये हमारा बिट है D7, D6, D5, D4, D3, D2, D1 और D0। कोई भी नंबर है, यहाँ पे 0 भी हो सकता है, 1 हो सकता है। अब हम क्या करेंगे, ये जो बिट है या तो ये 0 होगी या तो 1 होगी, इसको हम मूव करेंगे कैरी में C में, और फिर चेक करेंगे कि इसकी वैल्यू क्या है। अगर इस कैरी में एक बार मूव करने के बाद, मतलब हम राइट मूव कर रहे हैं, अगर इसमें 0 है तो नंबर हमारा इवन होगा, देन हम कैलकुलेटर में 02 स्टोर कर देंगे। अगर यहाँ पे 1 है तो ये हमारा ऑड नंबर होगा और कैलकुलेटर में हम 01 स्टोर कर देंगे। अब देखिए मूव करने के दो तरीके होते हैं। अगर राइट मूव की बात करें तो दो इंस्ट्रक्शन होता है, एक होता है RRC और एक होता है RAR। ये होता है रोटेट राइट बाय 1 बिट विद कैरी, विदाउट कैरी, ये होता है विदाउट कैरी, और ये होता है विद कैरी। रोटेट 1 बिट ऑफ एक्यूमुलेटर थ्रू राइट विद कैरी। कहने का मतलब है इस केस में कैरी कंसिडर करेगा, इसमें कैरी कंसिडर नहीं करेगा। तो हमने एक बार RAR किया, तो RAR करने से क्या होगा, ये जो बिट होगी वो इसी में आ जाएगी, मतलब कैरी फ्लैग में आ जाएगी। फिर हम चेक करेंगे कि कैरी फ्लैग की वैल्यू 0 है या 1 है। 0 है तो नंबर इवन हो जाएगा, 1 होगा तो नंबर ऑड हो जाएगा। तो ये है। अब इसके बाद हमने किया RAR। हमने एक बार RAR किया, इसका मतलब ये हुआ कि कैलकुलेटर में जो भी नंबर था वो राइट एक बार मूव हो चुका है। राइट एक बार मूव हो चुका है मीन्स जो हमारी ये वाली बिट थी वो कैरी में आ चुकी है। अब हम चेक करेंगे कि C की वैल्यू 0 है कि नहीं है। तो इसके लिए हमने यूज़ किया JC, जंप विथ कैरी। अगर कैरी होगा तो जंप कर जाएगा। देखिए अगर कैरी होगा तो इसका मतलब क्या हुआ कि हमें कैलकुलेटर में 01 स्टोर करना है। ठीक है, तो मान लीजिए कैरी है, हमने मान लिया कैरी है, तो हमने किया MBI A, 01, और जहाँ भी आपको आउटपुट स्टोर करना है, सपोज आपको स्टोर करना है STA 3050 पे, आपने आउटपुट स्टोर कर लिया, ये एंड हो गया। ए में 01 है, इसका मतलब जो नंबर हमें मिला है, जो नंबर गिवन है वो ऑड है। ये तो हमारी पहली कंडीशन हो गई कि मान लीजिए कैरी हो रहा है। कैरी हो रहा है मीन्स C की वैल्यू 1 है। 1 है मतलब नंबर ऑड है। तो हमने क्या कहा था कि नंबर ऑड होगा तो हम 01 स्टोर कर लेंगे। हमने 01 स्टोर किया, यहाँ पे आ गया 01 मीन्स जो भी नंबर गिवन है वो ऑड है। अब मान लीजिए कैरी जनरेट नहीं हुआ। कैरी जब जनरेट नहीं हुआ तो ये कंडीशन आपकी हो गई फेल। देन हम क्या करेंगे, हमने किया MVI A में 02। अगर कैरी जनरेट नहीं हुई, फेल हो गया, तो इसका मतलब वो इवन नंबर है। तो इवन नंबर के क्या केस में क्या करना है, हमें कैलकुलेटर में 02 स्टोर करना था, ठीक है। इसके बाद हमने क्या किया, यहाँ पे जंप, ये हमें कहाँ जंप करेगा, STA पे। अब देखिए इस केस में क्या होगा, एक्यूमुलेटर की वैल्यू 02 आ गई, यहाँ स्टोर हो गया 02, तो जो 02 स्टोर हो गया ये बताएगा कि भाई जो गिवन नंबर है वो हमारा इवन नंबर है। तो इस तरह से इस प्रोग्राम को आप फाइंड आउट कर सकते हैं। तो आइए इस प्रोग्राम को मैं दोबारा आपको रिपीट करके समझा दूं कि मैंने इसमें क्या किया है, ताकि आपको इजीली अंडरस्टैंड हो सके। सिर्फ मैं इसमें प्रोग्राम डिस्कस करूंगा। देखिए दोस्तों, सबसे पहले हमने क्या किया, ये हमारा इंस्ट्रक्शन हो गया LXI H205 नंबर, जिसमें हमारा नंबर गिवन है। इस नंबर को हमने एक्यूमुलेटर में लिया, मूव A, M। इसके थ्रू क्या होगा कि जो भी नंबर इस पर X Y जो भी होगा वो E में आ गया, यहाँ पे आ गया A की वैल्यू X, ठीक है। अब हमने लिखा RAR करने से क्या हुआ कि जो एक्यूमुलेटर है वो 1 बिट विथ कैरी मूव हो गया, मीन्स जो इसकी D0 बिट थी वो आपकी C में आ गई। अब हम चेक करेंगे कि क्या है, 1 है कि 0 है, मतलब 1 है तो कैरी है, 0 है तो कैरी नहीं है। तो हमने चेक किया जंप विथ कैरी। हमने पहली कंडीशन जूम की है कि मान लीजिए इसमें कैरी है मीन्स गिवन नंबर ऑड है। तो ऑड वाले केस में हमें क्या करना था, हमें करना था MVI A01, मतलब हमें एक्यूमुलेटर में 01 स्टोर करना था कि जो हमें बताएगा कि ऑड नंबर है। फिर हमने क्या किया, यहाँ लिखा है STA 3050 एंड कर दिया, मीन्स यहाँ पे स्टोर हो गया 01 हमें बताएगा कि गिवन नंबर ऑड है। ओके, नाउ मान लीजिए कि कैरी जनरेट नहीं हुई मीन्स ये कंडीशन फेल हो गई। ये जो गिवन नंबर होगा वो होगा इवन, और इवन के केस में क्या करना था, हमें एक्यूमुलेटर में 02 स्टोर करना था। तो हमने क्या MVI A, 02, उसके बाद हमने लिखा जंप, हम इसको जंप कराएंगे STA पे। तो डायरेक्ट क्या करेगा, एक्यूमुलेटर की वैल्यू 02 यहाँ पे स्टोर कर दिया, और ये 02 में बताएगा कि ये इवन नंबर है। तो दोस्तों इस तरह से आप सिंगल एक इंस्ट्रक्शन RAR यूज करके बता सकते हैं कि कोई भी गिवन नंबर निगेटिव है या ऑड है या इवन है। तो सिंपल सा तरीका था, जैसे मैंने आपको ऑलरेडी बताया था कि उस नंबर को आप 8 बिट के फॉर्म में लिखिए, और ये जो हमारी लास्ट बिट है ये बताएगी कि नंबर इवन है या ऑड है। मतलब अगर ये 0 है तो नंबर इवन होगा, अगर ये बिट 1 है तो नंबर ऑड हो गया। और इस प्रोग्राम के थ्रू आप फाइंड कर सकते हैं कि जो गिवन नंबर है वो ऑड है या इवन नंबर है। तो दोस्तों इस प्रोग्राम में इतना है कि हाउ यू कैन राइट ए प्रोग्राम टू काउंट नंबर ऑफ वंस इन ए गिवन नंबर in 8-bit number using assembly language programming. My program is that ki suppose there is a number x and we have to find ki how many number of 1 is present in particular this given number. Suppose I am taking example of 07. So if you write in term of 8-bit, so you have mentioned this like. So you can see that there is 3 number of ones. So for this basically we have to write a program to count number of ones. That x can be any number, this can be 01, this can be 05, this can be 07, this can be FF. So basically we have to write a program to count number of ones in particular a given number. So I am talking about 8-bit number. Okay, so now what can be step. Suppose you have to count, then definitely we have to initialize a register to count number of 1. कहने का मतलब है कि भाई अगर हम जहाँ काउंटिंग की बात करेंगे तो हमें कोई ना कोई एक रजिस्टर डिक्लेयर करना पड़ेगा कि उस काउंटिंग नंबर को स्टोर करे कि भाई जैसे कितने काउंट है। और दूसरी चीज़ क्या है इसमें कि जैसे हमने कहा कि 8-बिट नंबर, तो डेफिनेटली कोई भी नंबर हम एज्यूम करते हैं लेते हैं तो उसमें 8-बिट नंबर होगा। 8-बिट नंबर होगा मीन्स हमें इस हर नंबर को चेक करना पड़ेगा कि ये 1 है कि 0 है। अगर 1 है देन हम जो B हमारा इनिशियलाइज कर रखा है उसमें काउंटर हम 1 इंक्रीज कर देंगे। अगर 1 नहीं है तो इसको हम इग्नोर कर देंगे। कहने का मतलब है कि इसमें 2 चीज़ें आपको समझनी है। एक तो हमें एक रजिस्टर डिक्लेयर करना पड़ेगा
टू स्टोर काउंट नंबर कि 1 कितने हैं, और दूसरा जो नंबर ऑफ बिट्स कंटेन करेगा। नंबर ऑफ बिट्स का मतलब 8 बिट नंबर है तो 8 बिट। इसको स्टोर करने का मतलब क्या है कि हमें पता है कि हमें जो शिफ्टिंग करनी है, जिस भी नंबर को चेक करना है 8 बिट को चेक करना है। तो इसका कंसेप्ट क्या है कि जैसे हम कोई एक नंबर चेक करेंगे, इसमें से -1 कर देंगे, और ये प्रोसेस हम तब तक करेंगे जब तक हमारी सी की वैल्यू 0 ना हो जाए। मीन्स जब तक कि हमारे सारे बिट्स चेक ना हो जाए कि 0 है कि 1 है। तो सबसे पहले जो आपको करना है वो करना है MVI B00 ओनली टू स्टोर द नंबर ऑफ 1। देखिए ये नंबर जो x है कुछ भी हो सकता है, हमें नहीं पता है कौन सा नंबर है, बस हमें फाइंड करना है कि उसमें नंबर ऑफ 1 कितने हैं। उसके बाद देन वी हैव टू डिक्लेयर अनदर वेरिएबल या रजिस्टर दैट इज C स्टोर 0 बिट टू काउंट द शिफ्टिंग ऑफ बिट्स। इसमें हमें देखना है कि कितने बिट हमने शिफ्ट कर लिया, मतलब कितने बिट हमने चेक कर लिया। ओके, तो दिस टू बी फॉर स्टोर द काउंट नंबर, स्टोर द नंबर ऑफ वंस, दिस इज फॉर शिफ्टिंग प्रोसेस कि मैंने कितने बिट शिफ्ट कर लिया, कितने बिट हमने चेक कर लिया। नाउ जस्ट वी हैव टू फाइंड, वी हैव टू मूव गिवन नंबर इन एक्यूमुलेटर। Just if I write LDA 2050 means program is that there is a number X at this location and we have to find कि how many ones in present in particular that number we have to store at this location. That can be 3, 4, 5, 6, 8, maximum can be 8 or minimum can be 0. So basically we have to store here number of ones. So now this instruction will do this will be move the X into accumulator. After execution of this instruction, the content of A will be X and we have to find number of 1 in particular this number. After that we have a instruction RAR. In my previous video already I have discussed how RAR works. Basically it will be shift bit by bit to right direction. Means suppose this is 8 bit, when RAR will be queued, so this number will be shift in carry flag, then this will be shift this. So this process will done by using OR. If you write R only one time, then that will be shift only 1 bit. If you write RAR second time, then definitely it will be second bit, third bit, fourth bit, means every RAR will shift 1 bit by right using carry. कहने का मतलब है कि R बेसिकली क्या करता है कि ये जो भी हमारा बिट गिवन है उसको राइट डायरेक्शन में एक मूव कर देता है। हम जितनी बार RR लिखेंगे उतनी बार उस बिट को मूव करता जाएगा। और दोस्तों इसमें बेसिकली क्या करना है, हमें हर बिट को मूव करके चेक करना है कि उसकी वैल्यू 1 है कि 0 है। अगर 1 होगी तो B का पॉइंटर हम इंक्रीज करते जाएंगे, अगर नहीं होगी तो इसको इग्नोर करते जाएंगे। तो अभी तक हमने क्या किया, X को A में स्टोर कर लिया। अब हम इसमें चेक करेंगे, जैसे हमने लिखा RAR लिखने का मतलब क्या हुआ कि एक्यूमुलेटर का जो भी कंटेंट है वो एक बार मूव हो गया। मीन्स दिस इज 8 बिट, D0, D1, D2, D3, D4, D5, D6, D7, ये हमारा हो गया कैरी। जैसे हमने RAR लिखा मीन्स ये वाली बीट हमारी इसमें आ गई और ये वाली बीट हमारी इसमें आ गई। अब हमें चेक करेंगे कि इसमें शिफ्ट क्या हुआ है, 1 हुआ है कि 0 हुआ। वो चेक कैसे होगा, हमारे पास इंस्ट्रक्शन है JN से, जंप इफ़ नो कैरी। कहने का मतलब है अगर ये कैरी नहीं होगा तो जंप करेगा। अब जंप कहाँ करेगा, देखिए अगर जंप इफ नो कैरी, अगर कैरी नहीं है तो बेसिकली हमें क्या करना है, जो हमने पॉइंटर डिक्लेयर किया था 08, इसका मतलब ये हुआ कि एक नंबर हमारा चेक हो गया। तो हम क्या करेंगे, इसको जंप कराएंगे DCR
सी पे। जंप इफ नो कैरी, कहने का मतलब है जब कैरी नहीं है तब की हम बात कर रहे हैं। कैरी नहीं है मतलब बी में हमें कुछ ऐड करना नहीं है, जस्ट इसको इग्नोर कर देना है। तो दोस्तों हम बात कर रहे थे कि बेसिकली क्या करना है, जैसे हमने आर किया, इसका कंटेंट सी में गया, अब हम चेक करेंगे कैरी है कि नहीं है। देखिए दोस्तों, अगर कैरी होगी तो मीन्स हमें 1 मिल गया, तो उसको हम बी में ऐड करते जाएंगे। अगर कैरी नहीं है मीन्स हमारा 1 बिट चेक हो गया, तो हमने क्या किया, यहाँ पर DCR सी कर दिया। अब काउंटर की वैल्यू हो गई सी। अब हमें क्या करना है, दूसरी बिट चेक करना है, तो जंप इफ नॉट 0। इसका मतलब ये हुआ कि जब तक सी की वैल्यू नहीं होगी तब तक ये जंप करता रहेगा। ये अब जंप कहाँ करेगा, ये करेगा RAR पे। RAR पे इसलिए करेगा क्योंकि हमें पता है कि जब तक सी की वैल्यू 0 नहीं होगी तब तक हमें वैल्यू को शिफ्ट करते जाना है, तब तक शिफ्ट करते जाना है। तो यहाँ पे सी की वैल्यू हो गई 7 जो कि 0 नहीं है, फिर जंप करेगा, फिर एक बार RAR हुआ। अब क्या होगा, ये बिट इसमें शिफ्ट होगा क्योंकि ऑलरेडी ये बिट तो शिफ्ट हो चुकी थी और ये बिट यहाँ पे आ चुकी थी और फिर ये यहाँ पे आएगी, फिर आएगा, फिर आ गया मान लीजिए जंप इफ नो कैरी, फिर मान लीजिए कि 0 है, कैरी नहीं है, तो फिर आया, यहाँ पे सी की वैल्यू हो गई 6, फिर आया, देखा कि इसकी वैल्यू 0 नहीं है, फिर जंप किया, अब फिर RAR होगा। तो क्या होगा कि इसकी वैल्यू पहली बार में जा चुकी थी, इसकी दूसरी बार जाएगी, अब ये वैल्यू धीरे धीरे शिफ्ट करके यहाँ पे आएगी। जैसे शिफ्ट कैसे हो रहा है, ऐसे शिफ्ट हो रहा है, एक एक वैल्यू ऐसे शिफ्ट हो रही है। इसमें गया, फिर चेक करेंगे। अब मान लीजिए कि तीसरी वैल्यू जो हमने शिफ्ट की वो 1 है, 1 होगा तो ये कंडीशन हो जाएगी फेल, क्योंकि दिस कंडीशन सेज दैट कि जंप इफ नो कैरी, बट दिस टाइम द वैल्यू ऑफ कैरी इज 1 मीन्स कैरी फ्लैग इज सेट, देन दिस process will be wrong, this condition will be wrong. Then what happen, then in that case you have to add 0 1 b, means you have to write increment b. After this value of b will be 0 1, then same DCRC 5, फिर it will be check value of c, that is 5 not equal to 0, then again jump, then again process will follow. Finally after repeating this 8 times we can get ki how many numbers are present in particular number. Now that number we can store at given location at this. For this we have to write move a comma b, means this will be move the content of b into a. Now you can store the content of given location at this will be and the program. So by following this step you can easily count number of ones present in any given number. So let me explain the program again. Hope this time you can easily understand ki what is program about. Now so this is a memory location where is a number stored x. We have to find कि how many numbers present in that particular given number, and that number we have to store at this location कि how many number are present. So firstly we have to initialize a register B MBI B01 to store the count of 1, store another 08 to for the shifting process, because we are using 8-bit number, then we have to shift 8 times that particular given number to check if there is carry or not. Now I have stored LDA 2050, this will execute, and after execution of this instruction the content of this location will move into A, means after this instruction A have X, that particular given number. Now we have to check number of ones in particular is this number. So just we use RAR, rotate accumulator right by 1 bit, means suppose this is 8 bit D0 D1 D2
D3, D4, D5, D7, D6 and D7. After RAR, what happened? This is C carry. This will be moving to this. This will be moving to this. Means every bit will be shift by 1 through right. After this instruction, now we have to check what is content of C. This is 0 or 1. So then we have to use JNC. That means jump if no carry. Suppose assume that there is no carry. Then what happen? That means you have to jump at DCR C because वन प्रोसेस हैज कंप्लीटेड। कहने का मतलब है कि हमें पता है कि 8 बिट चेक करना है। जैसे हमने 1 बिट को मूव किया, हमने चेक किया कि उसकी वैल्यू क्या है। सपोज उसकी वैल्यू 0 है। 0 मीन्स कि वो 1 नहीं है, तो उसको हम काउंट नहीं करेंगे, तो हमको जस्ट इग्नोर करना है। तो ये हमारा जंप हो जाएगा DCR सी पे। सी पे इसलिए होगा क्योंकि 1 बिट तो हमने ऑलरेडी चेक कर लिया। अब हमारे पास बचा कितना? 07। अब क्या होगा? हमें 8 बिट चेक करना है, मीन्स हमें लूप को 8 टाइम चलाना है। अब क्या होगा? हम इसकी वैल्यू चेक करेंगे कि 0 है कि नहीं है। 0 जब तक नहीं होगी तब तक हमें लूप चलाना है। तो ये हो जाएगा JNZ, दैट विल बी जंप एट RAR। नेक्स्ट टाइम व्हाट विल हैपन? सपोज देयर इज अगेन नो कैरी, देन दैट विल बी इंस्ट्रक्शन एग्जीक्यूट। द वैल्यू ऑफ C विल बी 6, दैट इज नॉट इक्वल टू 0। अगेन मूव टू RAR। नाउ this time suppose कि value of C is 1, then what happen? In this case you have to count number of 1. In this case that instruction will be not execute. In that case this instruction will be execute, means that will be increment the value of B by 1. After this value of B is 01 and this process will be repeat till C equal to 0। जब तक C की वैल्यू 0 नहीं हो जाती तब तक ये प्रोसेस रिपीट करेगा। हो सकता है कि समटाइम C की वैल्यू 0 हो और समटाइम C की वैल्यू 1 हो। जिस टाइम 1 होगी उस टाइम ये इंस्ट्रक्शन एग्जीक्यूट करेगा, जिस टाइम 0 होगी ये इंस्ट्रक्शन एग्जीक्यूट करेगा। जब ये टाइम ये कंप्लीट हो जाएगा, देन फाइनली वी कैन स्टोर मूव A, B एंड ST है 2051 and then program will be end. So after completion of this program at this location we can find the number of 1 that is present in given. An assembly language program in 8085 microprocessor to reverse 8-bit number. As in this figure, this you can see that this is input location 2050 ये location where a number 89 is stored. Now you have to write a program to find out reverse of this number. Reverse of this number will be 98, that is stored 3050. तो बेसिकली दोस्तों ये हमारा प्रोग्राम है कि आप देख सकते हैं कि 2050 एक लोकेशन है जिस पे एक नंबर स्टोर है 89। हमें एक प्रोग्राम लिखना है जिसको एग्जीक्यूट करने के बाद हम इस लोकेशन पे इसका रिवर्स मीन्स 98 स्टोर कर सकें। तो बेसिकली वी हैव टू राइट ए माइक्रो प्रोसेसर प्रोग्राम फॉर this whole process. So now let me discuss in brief कि what we have to do. तो दोस्तों पहले हम बात कर लेते हैं कि हमें करना क्या है। सबसे पहले मैं इस 89 की बात करता हूँ। अगर इसको हम लिखते हैं इन टर्म ऑफ हेक्साडेसिमल, आई एम सेइंग इन हेक्साडेसिमल, दैट्स वाई बिकॉज कि 8085 माइक्रो प्रोसेसर वर्क्स इन हेक्साडेसिमल, मीन्स 8 is written as like this, 9 written like this. If you are talking about 98, so this will be 98. So between these two digit binary pattern, you can easily see that 9 is here, 8 is here. In this 8 is here, 9 is here. So basically you have to write a program to shift these 4 bits at this position और दिस बिट विल बी एट दिस पोजीशन। तो अगर आपने मेरी कुछ पुरानी वीडियो देखा होगा तो हमने एक रोटेट इंस्ट्रक्शन के बारे में डिस्कस किया था, क्योंकि इसमें हमें करना क्या है कि हमें एक एक बिट को शिफ्ट करना है। कहने का मतलब है कि चलिए अब देखते हैं कि मान लीजिए पहला हमारा कंटेंट 0101 है।
आप देखिए बाय यूजिंग राइट रोटेशन भी कर सकते हैं, बाय यूजिंग लेफ्ट रोटेशन भी कर सकते हैं, डिपेंड आप पे करता है कि आप कैसे यूज कर रहे हैं। तो चलिए मैं अभी यूज करने जा रहा हूँ आरएलसी के बारे में आपको पता होगा। आरएलसी बेसिकली क्या करता है, शिफ्ट द कंटेंट ऑफ एक्यूमुलेटर लेफ्ट बाय 1 बिट विदाउट कैरी। इसमें कैरी को हम कंसिडर नहीं करते हैं। तो बेसिकली जो भी हमारा एक्यूमुलेटर का कंटेंट होता है उस पर हमारा रोटेट इंस्ट्रक्शन अप्लाई होता है। तो हमने एज्यूम किया है कि मान लीजिए ये हमारा जो कंटेंट 89 है वो एक्यूमुलेटर में स्टोर है। तो जैसे हमने फर्स्ट टाइम आरएलसी इस पर अप्लाई किया तो क्या होगा कि फर्स्ट टाइम अप्लाई करने से 0001 हुआ क्या कि ये बिट यहाँ पे शिफ्ट हो गया और हर बिट आपका लेफ्ट शिफ्ट हो गया। तो सबकी पोजीशन चेक हो गई। ये तो वह फर्स्ट हुआ। जब हमने सेकेंड टाइम लगाया तो क्या हुआ, सेकेंड टाइम लगाने से 0 0 1 0 0 1 1 0, दिस इज फर्स्ट, दिस इज सेकेंड। एक एक बिट क्या हुआ, इसमें भी ये बिट आपकी यहाँ पे आ गई और ये बिट यहाँ पे, सारी बिट आपकी एक एक बाय लेफ्ट शिफ्ट हो गई। अगर हम थर्ड की बात करें तो 0 1 0 0 1 1 0, ये हमारी हो गई थर्ड। अगर हम फोर्थ टाइम की बात करें तो 1 0 0 1 1 0 0, ये हो गया हमारा फोर्थ टाइम। तो ये हो गया 9, ये हो गया 8। तो दिस इज ए प्रैक्टिकल रफ एक्सरसाइज। बाय लुकिंग एट दिस यू कैन फाइंड आउट कि इफ वी शिफ्ट द कंटेंट एक्यूमुलेटर 4 times देन वी कैन गेट रिवर्स ऑफ एनी गिवन नंबर। कहने का मतलब है अगर किसी नंबर का हम 4 टाइम अगर रोटेट करते हैं बाय यूजिंग आरएलसी देन वी कैन फाइंड आउट द रिवर्स ऑफ पर्टिकुलर दैट नंबर। अब हम बात करते हैं कि भाई इसकी प्रोग्राम हम लिखते कैसे हैं। तो दोस्तों सबसे पहले क्या है कि जो भी डेटा हमारा मेमोरी लोकेशन पे गिवन है उसको पहले हम एक्यूमुलेटर में स्टोर करेंगे। देन वी हैव टू अप्लाई आरएलसी 4 times, देन यू कैन गेट आवर डिजायर्ड आउटपुट। नाउ तो फर्स्टली वी हैव टू स्टोर content of this location in accumulator. So you can write just like this. What is the meaning of this instruction? This will be store the content of this at accumulator. Suppose at this location given is 89. So after this value of a will be 89 and you have to apply 4 times RLC. After this content of accumulator will be 98. By using this example already you have find out. Now we have to store this number, when the content of accumulator at this location. Then we have a instruction that is called STA. Meaning of this instruction is store the content of accumulator at the given location, means 3050. Now what happened in this instruction, this will be store the content of accumulator at this given location and just end the program and a halt. You can use both instructions. So now by using this simple 4 line of program you can find reverse of any given number at any given location. तो कहने का मतलब है दोस्तों अगर इस प्रोग्राम को एक बार आप समझने की कोशिश करें तो सिर्फ 3 लाइन लिखने के बाद आप किसी भी नंबर का रिवर्स फाइंड आउट कर सकते हैं। आप देख सकते हैं फर्स्ट लाइन इज एनडी है। इन दिस केस आई हैव ओनली स्टोर द कंटेंट ऑफ दिस लोकेशन इन किलोमीटर एंड आई हैव अप्लाई 4 times RLC। फॉर व्हाट पर्पज? बाय दिस एग्जाम्पल यू कैन इजीली अंडरस्टैंड कि अगर किसी नंबर का हम 4 बार रोटेट करते हैं तो हम उस नंबर का रिवर्स फाइंड आउट कर सकते हैं। हियर STA मीन्स स्टोर द कंटेंट ऑफ एक्यूमुलेटर एट दिस गिवन लोकेशन। नाउ कंटेंट ऑफ एक्यूमुलेटर इज स्टोर एट दिस लोकेशन। तो बेसिकली वी हैव टू राइट दिस प्रोग्राम जो कि हमने कर लिया। प्रोग्राम टू सर्च ए की वैल्यू इन ब्लॉक ऑफ डेटा यूजिंग लीनियर सर्च। बेसिकली दोस्तों मैं आज एक प्रोग्राम डिस्कस करने जा रहा हूँ जिनका इस प्रोग्राम में बेसिकली हमें क्या है कि एक ब्लॉक ऑफ डेटा में एक किसी की वैल्यू को फाइंड करना है यूजिंग लीनियर सर्च। तो सबसे पहले मैं बता दूं कि लीनियर सर्च का मतलब क्या होता है। बेसिकली द लीनियर सर्च इज ए सर्चिंग एलिमेंट्स सीक्वेंसली फ्रॉम स्टार्ट टू एंड पोजीशन। कहने का मतलब है कि एक ब्लॉक ऑफ डेटा गिवन है, आपको स्टार्टिंग से लेके एंड तक किसी एलिमेंट को फाइंड आउट करना है। दैट प्रोसेस इज कॉल्ड लीनियर सर्च। मीन्स यू हैव टू फाइंड आउट दैट पर्टिकुलर डेटा सिक्वेंसली। मीन्स सबसे पहले आप पहले डाटा से कंपेयर करेंगे, सेकंड से करेंगे, थर्ड से करेंगे, फोर्थ से करेंगे, देन यू हैव टू फाइंड की वैल्यू। की वैल्यू मीन्स सपोज कोई हमारे पास 10 डेटा गिवन है, उसमें से एक कोई भी डेटा की वैल्यू हो सकता है जिसको हमें उस पर्टिकुलर लोकेशन या उस पर्टिकुलर ब्लॉक ऑफ डेटा से फाइंड आउट करना है। जैसे मैं बताता हूँ कि मान लीजिए कोई हमारा डेटा है जिसकी मेमोरी लोकेशन 2002 से लेके और 8087 तक, ये बेसिकली हमारा मेमोरी लोकेशन है जिसमें हमारे डेटा स्टोर्ड है। और जो हमारा फर्स्ट लोकेशन है 8000, ये बेसिकली कंटेन करता है नंबर ऑफ डेटा, ये करता है नंबर ऑफ डेटा। और जो हमारा नेक्स्ट मेमोरी लोकेशन है 8001, ये कंटेन करता है हमारा की वैल्यू। की वैल्यू मीन्स इस पर्टिकुलर डेटा को यू हैव टू फाइंड फ्रॉम दिस मेमोरी लोकेशन। ये तो बताएगा कि नंबर ऑफ डेटा कितने गिवन है। मतलब जो मैं ब्लॉक ऑफ डेटा की बात कर रहा हूँ, ब्लॉक ऑफ डेटा का मतलब ये हुआ कॉम्बिनेशन ऑफ मेनी नंबर्स या मेनी डेटाज। की वैल्यू मीन्स यू हैव टू फाइंड दिस की वैल्यूज इन दिस नंबर ऑफ डेटा विच आर स्टोर्ड फ्रॉम 8082 टू 8007। ये बेसिकली हमारा एक मेमोरी लोकेशन की रेंज है जिसमें हमारा डेटा स्टोर है और आपको एक की वैल्यू फाइंड करना है कि ये वैल्यू किस लोकेशन पे स्टोर है। तो बेसिकली प्रोग्राम का कंसेप्ट क्या है कि अब हमें क्या करना है कि इस की वैल्यू को हर डेटा से कंपेयर करेंगे और जहाँ भी ये डेटा हमें मिल जाएगा उस पर्टिकुलर मेमोरी लोकेशन को हम स्टोर कर देंगे। और स्टोर कहाँ करेंगे? 9000H और 9001H पे। देखिए हम दो मेमोरी लोकेशन इसलिए ले रहे हैं कि जो भी हमारा एड्रेस होगा वो बेसिकली हमारा 16 बिट डेटा है और एक मेमोरी एड्रेस पे हम सिर्फ 8 बिट डेटा ही स्टोर कर सकते हैं। इसलिए हमें दो मेमोरी लोकेशन की ज़रूरत पड़ेगी ताकि जो हमारा की वैल्यू है उसका एड्रेस हम स्टोर कर सकें। तो सबसे पहले मैं आपको प्रोग्राम बता देता हूँ, एक रफ आइडिया की है क्या। जैसे मैंने कहा कि ये हो गया हमारा 8000 जिस पे हमने लिखा 06 मीन्स जो हमारा ब्लॉक ऑफ डेटा है वो 6 डेटा का है। उसके बाद हमने यहाँ पर लिखा 8001, सपोज यहाँ पर लिखा हमने 55 मीन्स ये हमारा की वैल्यू है जिसे हमें ब्लॉक ऑफ डेटा में फाइंड आउट करना है। अब ये हमारा एक मेमोरी लोकेशन है 8002, 8003, 8004, 8005, 8006 और 8007। अब मान लीजिए इस पे कोई डेटा हमारा स्टोर है 11, 12, 33, 44, 55, 66। प्रोग्राम क्या है कि ये जो आपका की वैल्यू गिवन है इसको हमें फाइंड आउट करना है इन डेटा से और जहाँ भी ये मुझे मिलेगा मीन्स जिस मेमोरी एड्रेस पे या मीन्स मेमोरी लोकेशन पे मिलेगा उस मेमोरी एड्रेस को हमें स्टोर करना है 9000H एंड 9001H पे। मान लीजिए आपने सर्च किया, आपका डाटा मिल गया, मिला किस पे? 8006 पे। तो बेसिकली आपको क्या है कि यहाँ पे 80 और यहाँ पे 06 स्टोर करना है, मीन्स ये पूरी मेमोरी लोकेशन इन पे स्टोर करना है। तो ये सिंपल सा प्रोग्राम है। अब मैं आपको कंसेप्ट बता देता हूँ कि प्रोग्राम होगा कैसे। देखिए ये दोस्तों बेसिकली प्रोग्राम हमारा कंपेयर से होगा। एक इंस्ट्रक्शन होता है CMP जो ऑलरेडी हमने अपने प्रीवियस 2-3 वीडियो में ऑलरेडी इसको डिस्कस कर चुके हैं कि इसको यूज कैसे करते हैं। अब हम क्या करेंगे, जो भी हमारा की वैल्यू है इसको पहले हम एक्यूमुलेटर में लेंगे। अब आ गया एक्यूमुलेटर में की वैल्यू, इस की वैल्यू को हम पहले डाटा से कंपेयर करेंगे। अगर देखिए कैरी की वैल्यू 0 है मीन्स दोनों डाटा सेम हो गए। अगर कैरी की वैल्यू 0 नहीं है, देखिए कंपेयर बेसिकली क्या होता है कि यू हैव टू सब्ट्रैक्ट कंटेंट फ्रॉम एक्यूमुलेटर, देन यू हैव टू चेक कि कैरी फ्लैग इज सेट या रीसेट। तो इन दिस केस when you going to subtract this content from accumulator, if output is 0 means both number are same, then you can find that this is key value. If output is not 0 means there is a carry means you have to compare with next data. Then if you find 0 then this will be location. If you not find 0 then you have to compare to next data, so on. You have to compare till z equal to 0 means 0 flag should be set. मान लीजिए आपने डाटा सर्च करते गए, यहाँ पे आए, आपने दोनों को कंपेयर किया, आउटपुट 0 आ गया मीन्स आपको लोकेशन मिल चुका है और इस लोकेशन को आपको स्टोर कर देना. तो ये बेसिकली एक प्रोग्राम है जिसको हमें 8085 असेंबली लैंग्वेज में लिखना है. तो चलिए मैं बताता हूँ प्रोग्राम आपको लिखना कैसे है. उम्मीद करते हैं कि आप देखेंगे तो स्टेप बाय स्टेप आपको समझ में आएगा कि कैसे क्या करना है. सबसे पहले दोस्तों हमें क्या करना है कि एक काउंटर इनिशियलाइज करेंगे. काउंटर जो बताएगा कि कितने डेटा को लेकर हम कंसीडर कर रहे हैं. तो जैसे हमने लिखा, आपको बताया था, हमने लिखा LXI H 8000. ये लोकेशन में बता रहा कि नंबर अब कितने साइज का एरे है या कितने साइज का ब्लॉक ऑफ डेटा है. उसके बाद हमने इसको कर लिया मूव C, M. इसका मतलब ये हुआ कि इस लोकेशन पे जो भी डाटा हम गिवन देंगे वो एज हमारा काउंटर सेट हो जाएगा. तो यहाँ पर C एज काउंटर, मान लीजिए यहाँ पर 6 डेटा है तो C की वैल्यू हो गई 6, ये हमारा काउंटर सेट हो गया. उसके बाद हमने किया INX H. इसने क्या किया, इसकी वैल्यू को 01 से इंक्रीज कर दिया मीन्स ये पॉइंट करेगा आप 8001 पे. ये 8001 पे हमारा क्या है, की वैल्यू है. तो हमने क्या किया, इस की वैल्यू को हमने मूव B, M कर दिया. इस तरह से क्या हुआ कि जो आपकी की वैल्यू थी वो B में स्टोर हो गई. की वैल्यू स्टोर इन B. अभी तक ये हुआ. तो पहले बता दूं मैं कि अभी तक हमने किया क्या है. सबसे पहले हमने फर्स्ट लोकेशन ली जो हमें बताएगा कि साइज ऑफ एरे क्या है या साइज ऑफ ब्लॉक ऑफ डेटा क्या है. उसको हमने C में लिया, वो हमारा काउंटर हो गया. मीन्स काउंटर हमने इसलिए इनिशियलाइज किया है कि जितने डाटा से हम कंपेयर करते जाएंगे उतने बार हम डिक्रीज करते जाएंगे. जैसे हमारा कंपेरिजन कंप्लीट होगा C की वैल्यू 0 हो जाएगी. C की वैल्यू 0 होने का मतलब है कि यू हैव कंपेयर ऑल दी गिवन डेटा. नाउ नेक्स्ट लोकेशन जहां हमारा की वैल्यू स्टोर है जिसको हमें फाइंड आउट करना है पूरी सीरीज में. अब हमने क्या किया, मूव A, B. मतलब जो आपका की वैल्यू था अब A में आ गया आपका की वैल्यू. अब आपको क्या करना है, इस की वैल्यू को हर लोकेशन से आपको कंपेयर करना है. तो सबसे पहले हमने लिखा INX H जो 8002 को रिप्रेजेंट करेगा. आपका पहला डाटा यहाँ पे मिल गया. अब इसको आपको A के साथ कंपेयर करना है. तो हमने लिखा CMP_M. इसका मतलब ये हुआ कि कंटेंट ऑफ दिस लोकेशन विल बी कंपेयर विथ A. A में हमारा की वैल्यू है. अब हम क्या करेंगे, चेक करेंगे कि कैरी है कि नहीं है. ठीक है, ये होगा जंप इफ 0. अगर 0 हो गया मीन्स आपका डाटा फाउंड हो गया. अगर 0 नहीं हुआ तो आपका डाटा फाउंड नहीं हुआ, आपको लूप चलाना है. तो मान लेते हैं कि आपने ये किया और आपका डाटा मिल गया. सिर्फ हमने कहा है कि चलिए हम रिज्यूम कर लेते हैं कि हमने कंपेयर किया, हमारा डाटा मिल गया. जंप इफ 0 हो गया मीन्स जंप इफ अगर 0 हो गया तो हमें करना क्या, ये आ जाएगा सीधे इस बेसिकली मेमोरी लोकेशन को हमें स्टोर कर लेना है. स्टोर कहाँ करना है, ऑलरेडी मैंने बताया था 9000, याद है ना, 8001 पे. तो यहाँ हमने लिख देंगे SHLD 9000H. ये हो जाएगा हॉल्ट. ये उस केस में है कि मान लीजिए हमने कंपेयर किया. ये उस केस में है कि मान लीजिए, तो एक मिनट, थोड़ा पेज हमारा छोटा पड़ रहा है इसलिए थोड़ा इसको बढ़ा लेते हैं, मैं दिखा देता हूँ. मान लीजिए हमने यहाँ पे डाटा लिया, इसको एक्यूमुलेटर के साथ कंपेयर किया मीन्स A से उसको सेपरेट करेंगे. आउटपुट 0 आ गया मतलब बहुत डाटा सेम है. जब डाटा सेम है तो इसका मतलब हमारा जो की वैल्यू था वो हमें मिल चुका है. अब हम क्या करेंगे, उसकी लोकेशन को यहाँ स्टोर कर लेंगे. सिंपल है, ये तो सिंपल हो गया. मान लीजिए कि सेम नहीं है, आउटपुट 0 नहीं आया, उस केस में क्या होगा? जब आउटपुट 0 नहीं आया तो हम करेंगे DCR-C, एक डाटा आपका कंपेयर हो चुका है। फिर J एंड Z हम इसकी वैल्यू को चेक करेंगे कि इसकी वैल्यू 0 है कि नहीं है। अगर 0 नहीं है मीन्स आपको क्या करना है, नेक्स्ट डाटा लेना है। तो ये जाएगा आप पे, इस पे, इसने INX कर दिया तो फिर इसकी वैल्यू हो जाएगी 8003। सेम इसकी वैल्यू को हम फिर एक्यूमुलेटर के साथ कंपेयर करेंगे, फिर चेक करेंगे 0 है कि नहीं है। अगर 0 है तो एड्रेस स्टोर कर लो, 0 नहीं है तो काउंटर की वैल्यू C करो, फिर C की वैल्यू चेक करो। जब तक C की वैल्यू 0 नहीं होगी तब तक ये लूप चलता रहेगा। लेकिन जैसे ही आपको की वैल्यू मिल गई फिर ये लूप नहीं चलेगा, डायरेक्ट उसका हमें एड्रेस स्टोर कर लेना है। तो ये हो गया आपका। उसके बाद मान लीजिए डेटा फाउंड नहीं हुआ, डेटा फाउंड नहीं हुआ तो आपको क्या करना है, इसमें मैं बताना भूल गया कि अगर डेटा फाइंड नहीं हुआ तो हमें क्या करना है, उस लोकेशन पे कोई भी वैल्यू आप स्टोर करना चाहें आप कर सकते हैं। तो मान लीजिए हमें 00 स्टोर करना है तो उस पर हम स्टोर कर लीजिए। तो ये हो गया जेन लूप। हमने यहाँ पे लिखा LXI H जो डाटा हमें स्टोर करना है 000। फिर इसको हम लिख देंगे SHLD नाउ रेंज। ये उस केस में है अगर डाटा हमें नहीं मिला तो, मतलब की वैल्यू आपकी सर्च नहीं हुई, ये तब का है। उसके बाद यहाँ पे हम कर देंगे JMP, ये हमारा जंप कर जाएगा होल्ड पे। तो ये आपका सिंपल सा प्रोग्राम है कि जो किसी भी की वैल्यू को सर्च करने में हम कर सकते हैं, इससे सर्च वैल्यू फाइंड आउट कर सकते हैं। तो चलिए मैं दोबारा इस प्रोग्राम को डिस्कस कर देता हूँ कि बेसिकली हो क्या रहा है। एक बार समराइज कर देता हूँ तो हो सकता है आपको इजीली समझ में आ जाए। देखिए दोस्तों, बेसिकली हमने एक प्रोग्राम लिखा है टू फाइंड ए की वैल्यू इन ब्लॉक ऑफ डेटा यूजिंग लीनियर सर्च। लीनियर सर्च के मीन्स होता है कि यू हैव टू फाइंड डेटा by searching a element in sequentially order, means you have to check first data, then second data, then third data, and so on. So basically there is a two memory location 8000, that is contain number of data कि how many data we want to compare या what is size of array. This is key value, means किस वैल्यू को आपको फाइंड करना है इन एरे में। और ये यहाँ पे जो लोकेशन दिया है बेसिकली इसलिए है कि जिस लोकेशन पे आपको की वैल्यू मिलेगी उसका मेमोरी एड्रेस को आपको स्टोर करना है। और ये हमारा रेंज है जहाँ हमारा डाटा स्टोर है। तो जैसे मैंने बताया यहाँ पे कि देखिए यहाँ पे 06 है, मीन्स जो हमारा एरिया साइज है वो 6 डेटा का है। जो 55 है बेसिकली की वैल्यू है जिसको हमें फाइंड आउट करना है। और ये हमारा डेटा स्टोर है 8002 पे 11, 22, 33, 44, 55, 56। और यहाँ पे आपको अब प्रोग्राम क्या कहता है, सबसे पहले हमने डिक्लेयर किया है फर्स्ट लोकेशन जहाँ पे हमारा साइज ऑफ एरे स्टोर है उसको हमने C में ले लिया। C को एज हमने काउंटर सेट कर दिया है क्योंकि यहाँ पे जो भी डेटा डालेंगे वही हमारा काउंटर होगा। उसके बाद INX H किया है, मतलब नेक्स्ट लोकेशन के लिए जो हमारा की वैल्यू को कंटेन कर रहा है, उस की वैल्यू को हमने यहाँ पे एक्यूमुलेटर में स्टोर कर लिया। अब हम क्या कर रहे हैं, INX H किया, मीन्स ये हमारा नेक्स्ट मेमोरी लोकेशन को रिप्रेजेंट करेगा। फिर उसका जो भी डाटा हमें मिला है उसको एक्यूमुलेटर के साथ कंपेयर कर रहे हैं। अगर आउटपुट 0 आ गया मीन्स वो डेटा सेम है, मतलब की वैल्यू और जो डेटा गिवन है वो सेम है, तो उसको हमने क्या किया, डायरेक्ट यहाँ पे स्टोर कर लिया। ये जो आपको दिखा रहा है इसको हमने यहाँ पे स्टोर कर लिया। आपका प्रोग्राम हो गया एंड, क्योंकि आपका डाटा मिल चुका है। दूसरे केस में मान लीजिए इसकी वैल्यू 0 नहीं है, 0 नहीं है मीन्स आपको डाटा फाइंड आउट नहीं हुआ है, तो आप नीचे आएंगे DCR-C, C की वैल्यू जो 6 थी वो 5 हो जाएगी। ये चेक करेगा कि C की वैल्यू 0 है कि नहीं है। अगर 0 नहीं है देन ये अगेन जंप करेगा, फिर नेक्स्ट मेमोरी लोकेशन को पॉइंट करेगा, फिर उसका कंपेयर होगा, फिर हम चेक करेंगे कि 0 है कि नहीं। 0 है तो स्टोर कर लो, 0 नहीं है तो फिर आएगा, इसकी वैल्यू 4 हो जाएगी, फिर ये जंप करेगा, फिर 8004 पे जाएगा। ये वैसे करता रहेगा जब तक C की वैल्यू 0 नहीं होगी। और ये इसलिए रखा गया है कि मान लीजिए कभी वैल्यू आपको कुछ फाइंड मिला ही नहीं, उस केस में क्या होगा, इस लोकेशन पे 00 हम स्टोर कर लेंगे। तो ये दोस्तों सिंपल सा प्रोग्राम है टू इन असेंबली लैंग्वेज प्रोग्राम using linear search to find any element in block of data by using linear search.
So in this video, I am going to cover all the aspect regarding introduction of input-output organization. Okay, how input-output organization is going to work within the microprocessor, and how microprocessor is going to communicate with external devices, as like you can say peripheral devices. So I will discuss each and every aspect regarding input-output organization, or you can say technique. So here, why we require input-output organization? The computer system input-output architecture is an interface which is used generally to connect microprocessor to the outside world. Here, what is meaning of outside world? So outside world means we are talking about peripheral device which we are going to connect through the microprocessor to communicate. So there are several reasons why input-output device or peripheral device is not directly connected to the system bus. So basically, there are some basic problems which occur when you are going to directly connect peripheral device to microprocessor. To avoid such type situation or avoid to such type of problem, we use input-output technique or input-output organization, so our data communication can be processed smoothly between the peripheral device and microprocessor. So what are some reasons? First reason is that there are wide variety of peripherals with various method of operation. It would be impractical to include the necessary logic within the processor to control several devices. Yes, every peripheral device which we are going to connect with microprocessor, they have various mode of operation, they have various method of operation. So in some cases, maybe it will happen microprocessor is not going to communicate in a nice or in a smooth way. Only why? Because various method of operation to each and every peripheral device. Means every device, suppose just I am taking example, suppose there are two peripheral devices, three, one is A, B, C. It is not necessary that the method of operation of each device is same. It may be different. So every time when microprocessor is going to communicate with this device, so microprocessor have to change their operation according to device which connected to microprocessor. Okay, so this is first problem. Second problem is the transfer rate of peripheral is often much slower than that of memory or processor. Thus, it is impractical to use the high speed system bus to communicate directly with peripheral. Now, second is for a good communication, data transfer rate of peripheral device and data transfer rate of microprocessor should be same. If there is any problem or any mismatch, so data communication is not going to happen in a smooth way. You can take example, suppose you have just tried to connect a printer and the data transfer rate of printer is much slower than microprocessor, then it is going to take more time to give output, and in vice versa also. So for a good communication or for a good data transfer rate, the speed of microprocessor and the speed of peripheral device should be equal. Okay, I am not forcing on the equal, but at least there should be very minimum difference, so data communication can be processed accordingly, and also we can get desired output in a very nice way or a very smooth way. If there is a difference between data transfer rate, maybe sometimes your machine or your system can generate also error due to mismatch of data transfer rate. And now third point, peripheral often use different data format and word length than the computer to which they are attached. Okay, sometime maybe suppose your printer is working on 16-bit and your microprocessor is working on 8-bit, and again you have connected second peripheral device, and that device has 16-bit and capacity of microprocessor also is 16-bit. Means if your word length data format is also different, then also it's going to affect the communication of data. Thus, to avoid all the reasons which I have discussed in this slide, we need input-output model. So, this is a basic block diagram ki how input-output technique or organization is going to work with the microprocessor, or you can say between the microprocessor and peripheral device. So, here you can see. And when we are talking about system bus, means we are talking about address bus, data bus and control bus combinedly. So, please don't segregate or don't confuse about it. System bus is nothing, it is just collection of address bus, data bus and control bus, and this is input output model or input output technique. And here we are going to add or connect multiple peripheral devices. Means you can connect as much as many peripheral device to input output model, and input output model is just a mediator between peripheral device and processor. Okay, so the major function of input output model are categorized as follows: control and timing, processor communication, device communication, data buffering and error detection. So these are major function of input output technique. So we are going to discuss one by one, so we can easily understand what is basically working of control and timing, processor communication, device communication, data buffering and error detection. So first is control and timing. So before starting this, we have some also conclusion. During any period of time, the processor may communicate with one or more external device in unpractical manner, depending on the program's need for input output technique, because we are going to add multiple peripheral device to microprocessor. The internal resources such as main memory and system bus must be shared among a number of activities, including data input output. So here in previous slide also you can see we have connected many peripheral device to input output model. So that's why system bus is also going to be shared among all the peripheral devices which are connected to microprocessor. So now first is control and timing. So when I was teaching about the pin diagram, in that time also I have discussed about control and timing. So basically the main responsibility of control and timing is to manage all the operation within the microprocessor. This is simple definition and simple working of control and timing. So the input output function include a control and timing requirement to coordinate the flow of traffic between the internal resources and external devices. Means the main responsibility of control and timing is to generate signal as per requirement, and that signal is going to communicate between microprocessor and external device, and also this signal tells whether microprocessor is ready to transmit data or not, and also it's pass information to peripheral devices. For example, the control of the transfer of data from an external device to the processor might involve the following sequence of state. First is the processor interact with the input output model to check the status of attached device. Yes, and how it will be happen through the control and timing signal. Firstly, processor will interact with input output model and check the status of attached device, means which type of device attached with input output model to communicate. And second, the input output model return the device address. Okay, so after getting the request from the processor, input output model return the device status, and if the device is operational and ready to transmit, the processor requests the transfer of data by the means of command to input output model. So what is going to happen between microprocessor and external devices? First, microprocessor generate a signal, and that signal will be carried by control bus to input output model to check which type of device is attached, and again input output will return signal with the information to telling microprocessor the status of device. When microprocessor receive the device status and input output model is ready to transmit data, then microprocessor start transmitting the data. So basically this is working how microprocessor and external device is going to communicate to each other, and the data are transferred from the input to output module to the processor. Okay, so now talking about processor and device communication. So during the input output operation, the input output module must communicate with the processor and with the external device. Okay, and now talking about processor communication involve the following. When you are going to, firstly, the input output model accept command from the processor, typically sent as a signal on control bus. Firstly, we have already discussed in previous slide. Firstly, whatever signal microprocessor will generate, that is accepted by input output model, and data are exchanged between the processor and input output model over the data bus. So we have control bus, data bus and address bus. Data bus used to exchange the data, control bus used to pass the signal, and the address bus used to carry the address. So these are now talking status reporting. There is a term. And now what happens? Suppose microprocessor is free, means microprocessor is not performing any operation. In that case, microprocessor will generate a signal by mentioning yes, I am ready. If microprocessor is ready, so input output model is transfer information to peripheral device. Yes, microprocessor is ready, so data transmission will begin. If microprocessor is performing operation, then microprocessor will generate a signal also containing that I am busy. Okay, and that signal will pass to external device, means peripheral device. Okay, then a peripheral device will be in a wait state. Whenever microprocessor will be free, again generate a signal, now I am free. So after free, data transmission will occur. So when you are talking about status reporting, the basically status reporting contain two terms. One is busy and second is ready. So because peripheral are so slow, it is important to know the status of the input output model. For the example, if an input output model is asked to send data to processor, it may not be ready to do so because it is still working on the previous input output command. This fact can be reported with status signal, common status signal, or busy and ready. We have already discussed. If microprocessor is busy, then microprocessor is going to generate a signal that is busy. If microprocessor is free, not performing any operation, in that case microprocessor will generate a signal that mentioning yes, I am ready. So now talking about address recognition. Just as each word of memory has an address, so thus each of the input device, and thus an input output model must recognize one unique address for each peripheral its control. Basically what happens if you are going to connect 5 to 6 peripheral device to microprocessor, so every peripheral device will have a unique address, and by that unique address microprocessor is going to recognize that on which address or in which peripheral device I have to work. Now talking about data buffering, I think everybody is just aware of data buffering. Why data buffering is occur? When speed of CPU and memory and peripheral device are mismatching. Means suppose you are opening YouTube video and also you have seen many times buffer. What is meaning? And we just assume that the speed of internet is not so good, so we can accept the data in good manner. Because why? Because the data transmission of data and the speed of internet is not matching. That's data buffering occurs. In same case, in microprocessor, when you are going to communicate with input output device and microprocessor, if speed is mismatching, data buffer will be occur. So, an essential task of input output module is data buffering. The data buffering is required due to the mismatch of the speed of CPU, memory and other peripheral devices. In general, the speed of CPU is higher than the speed of other peripheral devices. So, the input output module store the data in data buffer and regulate the transfer of data as per the speed of device. So, here we are using a term that is data buffer. Okay. So, input output store the data in data buffer and regulate the transfer of the as per the speed of the device. So, here we are using data buffer to managing the speed between the peripheral device and the microprocessor. So, now talking about error detection. Another task of input output module is error detection, and for the sequentially reporting error to the processor. There are two types of error, one is mechanical and second is electrical modification. Okay. So, another class of consists unintentional changes to bit pattern as is it transmitted from device to input output module. Sometimes this type of errors can be occur. So, here this is a simple block diagram of input output model. So, here you can see this is input output logic, and here we are talking about data register that is going to use to manage the speed. Here this is going to generate the signal, and that signal is passed through the input output module 3. Here this is address line, means data bus, address bus and control bus, and here many external devices is connected through this, and every external device will have data, status and command. So, this is pictorial diagram of input output module. So, now talking about addressing, which we have already talked. If you are going to connect as much as in external devices or peripheral devices to input output model. So, every input output model will have a unique address. By that unique address, microprocessor is going to recognize on which peripheral device microprocessor is working. So, there will be many input output devices connected through the input output model to the system. Each device will be identified by a unique address. When the microprocessor issues an input output command, the command contains the address of the device that is used by the command. Yeah, this is very important point. Whenever input output module going to return any status of device, that will contain also address. Okay, and that address will be passed through the processor, or if processor is going to generate any command, it also contain the address. I am generating this command for the particular device, because that signal is also contain the address of that device. So, by using that address, microprocessor is going to recognize that on which peripheral device microprocessor is going to work, and also input output module transfer that information to that particular device which contain same address. So, this is working how microprocessor is going to recognize and how input output module is going to communicate information to next level. And so, input output model, there are two type of addressing are possible. One is memory mapped and second is isolated. Okay. So, let us discuss what is basically difference between memory mapped and isolated, so you can easily understand. So, here I am going to talk directly what is difference between memory mapped and isolated. Okay. So, first, a method to perform input output operation between the CPU and the peripheral device in a computer that uses one address space for memory and device. So, this is point, and here a method to perform input output operation between the CPU and peripheral device in computer that uses two separate address for the memory and the input or devices. So here we are using one address space, here we are using two separate address. Here we use the same address for both memory and input output device. Here we just two separate address space for memory for different and input output for different. This is difference. As the memory mapped input output uses one address space for both input output module and memory, the available address memory or minimum, that is right. And here we are using separate memory, so that can be big. Uses the same instruction for both input output and memory operation. Okay, here we are using different for memory and different for input output, and memory mapped is less efficient because we are going to work on same address, so sometimes it's difficult to get data on desired time. That is more efficient because we are using separate code for separate things, separate address for separate thing. That's why it's smaller in size because we are using same address space, and that will be larger in size due to more bases because we are providing different addresses for different things. That's why. And simpler logic used as input output is also treated as memory only, and it is complex due to separate logic used to control. And in this video I will discuss about 8251 architecture and working of 8251 and interfacing of 8085 microprocessor with 8251 IC. So here we are going to start. This is little bit introduction of 8251. And 8251 USART is a universal synchronous and asynchronous controller designed by Intel basically to facilitate the communication between microprocessor and peripheral device. And when we talk about what is full form of USART, that stands for universal synchronous and asynchronous receiver transmitter, and works as an intermediate that allow serial and parallel communication between the microprocessor and peripheral device. So here USART is going to communicate between you can say USART is a just mediator between peripheral device and microprocessor, so transmission of data can be happen smoothly, because as you know microprocessor allow parallel communication. And what happen in parallel communication, the number of cable required for data transmission is equal to number of bits. Suppose if you are going to transmit 8-bit data, so we need 8 wire. So this is going to make your system bulky, and also this is very costly, because I have taken example of only 8 bits. Suppose you have to transport data of 16 bit, then you require 16 wires, and also you have to transport data in a long distance, then it is going to increase your cost. Also it's going to increase and also it's going to make your system very much bulkier. That's why USART is a very important device which is going to communicate between microprocessor and peripheral device. And what does USART does? Basically what happens, USART acts as a mediator between the processor and peripheral device, so that the parallel data from the processor can be converted into serial data and transferred to the peripheral device. In the similar way, the serial data from the peripheral device is converted by USART into parallel form, so that it can be accepted by the processor. Anyhow, microprocessor is going to transmit data in parallel form and also going to receive data in parallel form. Let me explain the concept by simple diagram. You can understand. This is your microprocessor, and this is USART, and this is your peripheral device. Okay, so microprocessor transmit data in parallel form, and this parallel form accepted by USART. USART convert this data in serial form, and this data will be converted transmitted to peripheral device in a
serial manner. Now what happened? Suppose peripheral device have to send data to microprocessor. In this case, it will transfer the data to USART in the serial form. USART will convert this data into parallel form, and that parallel form will be accepted by microprocessor. So basically this is a concept how USART is going to work between microprocessor as well as peripheral device. So here we are talking about architecture and working. So here you can see this figure. This is basically architecture of 8251, or you can say USART. In this lecture I am going to discuss each and every block, so you can easily understand what is basically working of this block during the operation. So first is data bus buffer, and basically data bus buffer is used to carry the data, and it is basically interface 8251 with the internal system bus of the processor. Means internal bus means we are talking about control bus, data bus and address bus. So as we know, data bus used to carry 8-bit data, address bus used to carry the address, and the control is used to carry the control information or signal information, you can say. Now question is that what is use of address bus here? So in my previous lecture I have already discussed about what if you are going to connect any peripheral device to input output device, so each device will contain a unique address, and by that unique address your microprocessor is going to recognize on which device you have to work. So you can connect many input out you can connect many peripheral device to any USART, or you can say any input output device. So every peripheral device contain a unique address, and by that unique address microprocessor is going to recognize yes, I have to perform operation with this device, because that address, because whatever data that device will transfer to microprocessor, or microprocessor will generate, that contain address of that particular device. So by that microprocessor is going to recognize. When you are talking about the read and write control logic, so this functional unit generate a control signal for the operation of 8251 according to the signal present in the control bus. Means basically control bus used to carry the signal, and that signal can be read or write. According to that signal USART is going to perform the operation. And now when you are talking about read, here you can see it have some other control logic unit. First one is CS. Okay, it is a chip select. So a low signal, please here it will be high signal, because here we are talking about CS bar. So a high signal at this pin shows that processor has selected 8251 in order to communicate with the peripheral device. Okay, when we are talking about C and D, when high signal will be present at this pin, so then meaning of that we are talking with control register address, and when low signal will be present means we are talking about data register, or data register is going to participate in operation. Now here we are talking about read and write. So both read and write are active low signal pins. A low signal at RD means we are talking about currently RD bar, that the processor is reading the control status, and while write indicates the write operation over the data bus of 8251. Means reading means we are fetching the data, and write means we are just inserting the data. When we are talking about clock and reset, reset means when the reset is active high signal means your 8251, or you can say USART is in idle mode. Now talking about transmit buffer. So basically this unit is used to change the parallel data received from the CPU into serial data. by inserting some necessary framing information. Once data is transformed into serial form, then in order to transmit to the external device, it means what is main use of transmit buffer is convert that parallel data which is received from the microprocessor into serial data, and that serial data is going to transmit it over peripheral device by using USART, or you can say 8251. But USART also contains two things, two registers. One is buffer register, second is output register. When we are talking about buffer register, so basically the data provided by the processor is stored in the buffer register. And as we know, CPU provides parallel data to 8251. So the processor load the parallel data to the buffer register. Okay, and this data further transmitted to output register. Now the main work of output register is to convert that parallel data into serial data. Okay, and here your parallel data will be converted into serial data, and that serial data is going to transfer to the peripheral device. Means USART had two components. Just let me explain by the diagram, you can easily understand. Here we have CPU, we have buffer register, you have output register, and here we have peripheral device, and this combinedly is 8251, you can say. Okay, now what happen? This will generate parallel data. This buffer register will contain this data, then again transferred to the output, and this output register will convert into serial data, and that serial data will be transmitted to peripheral device. In same case, when you are talking about reverse operation, serial data to output, output data will convert into parallel form, that will be here, and again that will be here. So this is basically working. Okay, so as we have already discussed that its perform, means we are talking about 8251 perform synchronous as well as asynchronous transmission. So in case of asynchronous transmission, start and stop bit is added by transmitter in order to notify the external device about the data transmission. Means suppose you have to transmit this data, then what happen in case of asynchronous, extra bit will be added here and here. By this bit, receiver or peripheral device is going to recognize on which mode data is transmitting. But in case of synchronous, we are not going to do such thing. Okay, now talking about transmit control, means this pin, it is used to control the transmission action, and it is done by accepting and sending signal both externally and internally. So this the various control signals generated by this unit are TX ready and TX C and TX E. So TX ready, this signal is used to notify the processor the buffer register of 8251 is empty. Now it is ready to accept the data which is sent by the microprocessor. So basically TX ready is going to notify the processor, yes, I am ready, means talking about buffer register is empty and now ready to accept the data. And now here TXE, this stands for transmitter empty. It is an active high signal that indicates that output buffer is empty, and thus data received from the processor can be loaded it for the conversion. Means firstly TX ready will be work. Okay, let me explain. This is TX ready and this is TXE, TX ready. Okay, so this will generate a control signal to tell microprocessor okay, I am empty and I am ready to accept data. Okay, as soon as microprocessor will accept the data, send the data, this will generate a control signal to TXE. Okay, now this is empty, then data will be received here, and this is going to convert that data into serial form. And when we are talking about TXC, it's sent for transmitter clock and active low pin. It's control the rate of character, how many character are transmitting during the transmission operation between the microprocessor and peripheral device. And now talking about receiver buffer. So now we are talking about receive. So this unit take the serial data from the external device, changes the serial data into parallel form so that it can be accepted by the processor. So this work is going to done by receiver buffer. When an external device is ready to send the data to the 8251, then it send a low signal to RxD lines. Here we are talking about RxD lines. And in asynchronous mode, once 8251 receive a low signal, it consider that signal is a start bit of data. In previous slide, I have already discussed when you are going to operate transmission in asynchronous mode, then we have to add some start bit and a stop bit. Okay. Once data is received by the receiver input register, then it convert the data bits in the parallel form and send to the receiver buffer register. In the case of means what we have already discussed about buffer register and output register, now we are talking in the case of receiver also. So here you can see receiver buffer. Okay, I think this is not so much important because I have already discussed in the previous slide. So just receiver control means receiver control this pin. This unit control the operation of the receiver buffer. It manages the data reception, along with that also detects the presence of false start bit, error, priority wing and framing error if there is any possibility of that. Rx ready, it stands for receiver ready. When this signal goes high, then it indicates that the receiver buffer register is holding the data and ready to transfer it to the processor. Once the CPU reaches the data sent by the 8251, then this pin is reset. And RxE is sent for receiver clock, and this clock signally control the rate with the 8251 receive the data in the synchronous mode of the operation. Okay, so this is basically working of receiver. Now here we are talking about modem control. So this unit of 8251 hold input output control signal that simplify the operation of the whole system. Means this modem is going to control all the operation which is happening within the microprocessor and your peripheral device. And this contains 4 low signal. First one is DSR, stand for data set ready, and this signal is used to check whether the data set is ready. Means when we are talking about data set, means we are talking about collection of data, and data is just a single data, but when you discuss about data set, means you are going to talk about collection of data. And DTR implies data terminal ready, means an active low signal, means here we are talking about DTR bar. So please don't be confused. When you are going to write about DTR, then you have to mention here high signal, so that 8251 is now ready to accept the data from the processor. Now RTS is stand for request to send. A high signal shows an assertion for data transmission, and CTS clear to send. When the 8251 receive a low signal at this pin, then it clear all the data present in the modem in order to allow further communication. So this was some discussion about architecture. Now talking about how interfacing of 8251 with 8085 is going to happen. So here you can see this is 8251, this is 8085 microprocessor. So you can connect reset pin with reset, D7 to D7, RD to RD, write to write, clock to clock. A0 is connected to CD, and chip select is going to connect A0 to A7. So basically this is simple architecture. By using this diagram also you can connect your 8251 with 805 microprocessor, because we need some signal, and you can see in this picture we have already connected. And this is a pictorial diagram how this is going to work. So if you want to create a circuit diagram, so by using this picture you can also create. So this is all in this lecture, and I hope you understand. I will cover what is serial communication and what is basically difference between serial communication and parallel communication, introduction of RS-232, working of RS-232, and specification, handshaking, and some application which is basically based on RS-232. So let's start the lecture. So as you know, the process of sending data sequentially over a computer bus is called a serial communication. When we are going to discuss what is basically definition of serial communication, so serial communication is a process to send data in a sequence over a single line. Okay, and suppose if you want to transmit 8-bit data through that line, so you have to transmit your data bit by bit. Means first bit will be received, then you have to send second, then third, then fourth. Means you have to send your data in a sequence to the receiver, and that will be happen through one single line. So here in this picture you can see this is transmitter and this is receiver, and this is the example of serial communication because through the single line, this is line, bit by bit transmission is happening. So this is example of serial communication. When we are talking about parallel communication, so in case of parallel communication you can transmit 8-bit data, 16-bit data, 32-bit data at a time by using several data lines. Using several data lines means suppose you have to transmit 4-bit data, then you require 4 data lines. If you want to transmit 8-bit data, then you require 8 data lines. Then you know what happened when we are talking about parallel communication and we are dealing to transmitting data 16 bits, means we require 16 lines. So sometimes it makes your system very bulkier and also increases the cost, because suppose if you want to transmit data over 50 meter, then you need wire of 50 meters. So sometimes it's increase the cost. To avoid this cost and not make your system bulkier, serial communication come into line. And serial communication is slower than the parallel communication because in parallel communication you can transmit maximum data at a time, but in serial communication you have to transmit bit by bit. That's why serial communication take more time compared to parallel communication. But serial communication you can use for long data transmission due to lower cost and also practical region, because sometimes it is not possible to transmit data in a practical manner. Also, just I want to give you an example. Suppose you have a file in your laptop, you want to transmit that file from laptop to the mobile. Then when you are going to send by using data cable, when you are going to send that data, your data will be not transmitted at a time, that will transmit one by one. Suppose there are 5 movies and you are transmitting, so firstly your first movie will be transferred, then second movie will be transferred, then third movie will be transferred. So basically this is example of serial communication. Also just this is example of serial communication. You can consider many example. Okay, and here you can see the diagram of parallel communication. Suppose this is a transmitter part and this is receiver part, and you want to transmit 8-bit data, so we required 8 data lines, and each data lines transmitting 1-bit data. So this is going to make your system very heavy and also bulkier, and also it will increase the cost of the system. So that's why we prefer to use serial communication. Also, by taking this example you can easily understand when we are talking about serial communication. So you can take example of machine gun where bullet reach one by one to the target. In parallel communication you can take using a shotgun, where number of bullets reach at the same time. So these are some very basic practical example. By this example, you can easily understand how serial communication and parallel communication works. Now, some properties of serial communication. First property is baud rate. So generally, baud rate is used to measure the speed of transmission, means how many bits transmitting in 1 second. Suppose baud rate is 200, means 200 bits are transmitting within a second. Now, what we have to discuss in this lecture, that is RS-232 bit. RS means recommended standard. So here RS-232 is a standard protocol used for serial communication. It is used for connecting computer and its peripheral device to allow serial data exchange between them. So just I have taken, I have already discussed in previous slide. So suppose if you want to transmit some data from your computer to your mobile phone, definitely then you need a data cable or Bluetooth. So when you are going to use data cable, basically that data cable is example of RS-232. Basically in current time we are not using such facility because in initial days we were used to use this RS-232. Now this is replaced by advanced USB, you can say Bluetooth, data cable. Basically these are some alternative of that RS-232. So whenever you are going to connect your data cable between your mobile phone and computer, a connection will be stabilized. After stabilizing connection, you can transmit your data from mobile to laptop or from laptop to mobile, because this is two-way communication. So this is a standard protocol used for the serial communication. It is used for connecting computer, means you can say RS-232 bit is just like a connector which is going to connect your computer with peripheral devices. And the RS-232 used for connecting data transmission equipment and data communication equipment, means okay. So by this picture you can easily understand this is a transmission, that is called DTE, and this is DCE, that is called receiver. Here you can also see the pictorial diagram of that. This is data communication equipment and this is data terminal equipment. Okay, so this is now just discuss working of RS-232, how it's worked. So let me draw a diagram to make you understand. Hope you can easily understand by this diagram. This is DT because we have two part, and this is transmitter, you can say, and this is receiver, that is DCE. Okay, DC. Okay. Now suppose you have to transmit data from here to here. Okay, and already RS-232 works on the two-way communication that exchange data to each other, means you can transmit data from here to here or from here to here. Okay, so firstly condition I am discussing, suppose you have to transfer the data from here to here, then what happen? Okay, there is a pin that is RTS. RTS will generate a signal that is called request to send, okay, to DC, and the CTS of DC will clear the path. Then DC will receive all the data, means transmitter will transmit the data and DC will receive the data. Means firstly what happen, DT will generate a signal that is called request to send. CTS of DC will do clear the path. When that clears the path, receiver can receive the data. Okay, this is process. Now second process, suppose if you want to transmit data from here to here, then what happen? In that case, RTS of DCE RTS of DC will generate a signal, and CTS of DT will clear the path. When path will be clear, DC transmit the data and DT will receive the data. Means this is two-way communication. You can transmit data from here to here, as well as you can transmit the data from here to here, and we have 2 pin which DT have, and also that pin DC have, that is RTS and CTS. RTS used for request to send, and this is used for clear the path in same case. Means at a time when you are going to transmit data from here to here, then firstly RTS of DT will work, then CTS of DC will work. Then when you are going to transmit data from here to here, then RTS of this will work and CTS of DT will work, and they are going to stabilize a connection and they are going to transmit the data. So this is basic definition, and by reading also you can understand how these are working. Okay. So we have some pin here, you can see these are TXD represent transmitter, RXD represent receiver, RTS request to send, and CTS clear to send, and ground. Okay. So in this picture, previous picture, here you can see this is a transmitter and this is receiver. Okay. Now connector, basically what I have discussed, RS-232 boot is basically a connector which going to stabilize a connection between your computer and peripheral device. By using that you can communicate your data. So there are 2 type of connector, that is DB25 and DB9. So in DB25 there are 25 pin available which are used for many of the application, but some of the application did not use whole 25 pins. So the 9 pin connector is made for convenience of the devices and equipment. There are 2 types of connector, one is male connector and second is female connector. So here you can see the pictorial diagram of male connector. Okay. So you can see, and also just I want to tell something about that. When we are talking about RS-32, actually I have already explained that now that this has been replaced by some socket. Suppose if you want to transmit, if you want to run internet on a system, by using LAN cable also you can do. So what you do, you have to put that wire in your slot. So basically that slot is an example of connector, or you can say RS-32 2 bits. And also suppose if you want to transfer data from pen drive to your computer, so in that case you can also transfer the data from the pen drive to computer, and also from computer to pen drive. So basically this is example of two-way communication, and where you are going to put up your pen drive, there is a slot for applying pen drive, means that slot is an example of RS-32 bits. That is a basically example of connector, and by using that you can connect your peripheral device to CPU. In that case your pen drive is example of peripheral device and CPU is a microprocessor, and that slot is going to work as a RS-232 bits, because that suppose two-way communication, means you can transfer data from system to pen drive as well from pen drive to system. So this is example of male connector. Here you can see the female connector, and these are some pin. By using this table you can understand how these pin are going to work. So first pin is CD, means carrier detect incoming signal for DC, means okay. RD means receive data, receive incoming from the DT. TD means transmit data, send outgoing to data, because we are talking about DC. So by using this pin you can easily understand this. Basically we are talking about receiver, and you can say okay. DTR, data transmit terminal ready. Ground means signal ground. DCR, data set ready. RTS means request to send. CTS means clear to send, means just clear the path and now clear to send. RI means ring indicator, incoming signal from the DC. So these are some working of these pins. Now we are talking about handshaking. What is basically handshaking? you know what happened, before transmitting data, firstly you have to stabilize a connection. Okay, just I am taking example. I think sometime also you have noticed when you are going to transmit data from your mobile phone to your system or your laptop or your computer system, firstly you have to select, you know, there is a setting, you have to select as transfer file and video, something like that. When you are going to click on that, so basically that is going to stabilize a connection. And also you can take example pen drive. Sometime when you put your pen drive in any system, you got a pop-up message and also indicate a sign of pen drive. So basically that is process of stabilizing a connection between pen drive and a system. So basically that is handshaking. What is important of handshaking? Handshaking actually stabilize connection before transmitting the actual data. How can a transmitter transmit and receiver receive data successfully? So the handshaking defines. Okay, so handshaking is a process which is used to transfer the signal from DTE to DCE to make the connection before the actual transfer of data. So, and the messaging between transmitter and receiver can be done by handshaking. So what I have discussed, when you are going to put up pen drive in system, you have seen some message. We are talking about that message, and that message is going to tell us, yes, your connection is stabilized and you can transmit the data. When your connection is stabilized, you start transmitting your data, means just copying data from pen drive to system or system to pen drive. So these are example. Okay, so there are three type of handshaking. One is no handshaking, hardware handshaking, and software handshaking. So in no handshaking means, what is perfect communication? When we talk about perfect communication, so when your data is fully transmitted over receiver, that is called perfect transmission. Suppose I have transmitted 5-bit data and receiver received 5-bit data, means that is perfect communication, you can say, or perfect transmission and receiver. Suppose I have transmitted 8-bit data, receiver only receives 6-bit data, means that is not perfect communication. So this is example of also no handshaking. In what happened? In case of no handshaking, some data lost. Why? Because due to BG of register buffer, you can say. So just let me explain. If there is no handshaking, then DC reads the already received data while DTE transmit the next data. All received data is stored in a memory location known as receiver buffer. This buffer can only store 1 bit. Receiver must read memory before the next bit arrive. This buffer can only 1 bit. Okay, that is main point, only 1 bit. If the receiver is not able to read the stored bit in the buffer and next bit arrive, then the stored bit will be lost. So that is problem in no handshaking, because at a time receiver have to read this data. If receiver read the data, your buffer is empty, so transmitter can send the data. But what happened in some case, suppose receiver has not received has not read the data, data is already available in register buffer, receiver buffer, and transmitter send the data, then what happen? In that case, your received data will be lost. So that is not example of perfect communication. So here by this picture you can easily understand, transmitter transmitted a data, here this is read and received, there is no problem. In second case no problem, third case no problem. But in this case what happened? Till now receiver had not read the data and transmitter transmitted the data. Then what happened? In this case this data will be lost. Suppose in case of next data and it transmitted, there is no problem. Again in next data, suppose data in register buffer and transmitter again they send the data. In that case what happen? This data will be already lost, means this is not example of perfect communication, because here we are losing the data. So that's why we have two concepts, one is hardware handshaking and software handshaking, and these are example of perfect communication, you can say, because in this we are not going to losing our data. So it uses specific serial ports RTS and CTS to control data flow. In this process, transmitter asks the receiver that is ready to receive data, then receiver check the buffer that is empty or not. If it is empty, then it will give signal to transmitter, yes, I am ready to receive data, you can send the data. So in this case, data will be not lost, because because transmitter and receiver going to transmit data by understanding. If receiver is empty, then receiver can receive the data and then transmitter will transmit. If receiver is full, in that case transmitter is not going to transmit data. So in this process we can avoid losing the data. So the receiver gives this signal to transmitter not to send any data while already received data cannot be read. So its working process is same as above described in the handshaking. So here software, in the software there are two forms. One is axon, one is x off. X is transmitter. Axon means it is a part in which it resumes the data transmission. X off, it is part which pauses the data transmission. So it is used to control the data flow and prevent loss during the transmission, because if X is on means data transmission can occur. If X off means data will not transmitted. Transmitter will have to be in a pause state. Whenever receiver will generate a signal, yes, I am free, you can transmit, then axon X will be on and transmit the data. Now talking about some applications, so I have already discussed. Now we are not currently using our RS-232 because this is replaced by advanced USB, some socket, some data cable you can say, but it is still used by some microcontroller boards, and there are some also many devices where we use to RS-232 to stabilize a connection. So in this lecture I will cover introduction of 8255 IC, some feature of 8255, pin diagram of 8255, block diagram of 8255, and control port and control word. These are a very important topic which I am going to cover in this lecture, and also I will cover how 8085 microprocessor is going to interface with 8255. So here, as you know, microprocessor and microcontroller are primarily used to process the data from the CPU to external device, or you can say peripheral device. And if when we are talking about some application of microprocessor and microcontroller, so they are countless. If we are going to talk in terms of interacting microprocessor and microcontroller to outside world. Outside world means here we are talking about when you are going to connect your microprocessor, your microcontroller to peripheral device. So there are countless application, and this is done by inserting input output device between the microprocessor and peripheral device. And it is also impossible to take a name or a real life application which is used in communication without using input output device, because when we are talking about communication or transferring data from the CPU to peripheral device, definitely we are going to use input output device, and because they play very vital role in communicating data from the microprocessor to peripheral device. And as you know also that microprocessor has a finite number of pins that is used to interface with the peripheral or external devices. But can you imagine, have you imagined in any time, suppose in case of you having more input output device than pin, then what will happen? In that scenario, your 8255 IC is going to work, means that comes into picture. Suppose your microprocessor has only 8 pins, but you have 10 peripheral devices to communicate with microprocessor. In that case, programmer peripheral interface going to play big role, and that's why we need 8255 IC, so we can easily communicate more devices compared to pins. So 8255 is a programmable chip used for interfacing peripheral device. It's connected with processor or a controller and increase the number of input-output pins that can be used in the system. And it has 3 8-bit ports to connect input-output device. That means we have 24 pins for interfacing input-output device that are divided into 3 ports. So in this lecture we are also going to discuss about control port and control over register, so we can know what is the name of those port and how they are going to work within 8255 IC and also with communication of 8255. So here there are some feature of 8255. One is this is 40 pin IC and which works on power supply of 5 volt, and it is compatible with wide range of microprocessor and microcontroller application. That's why it's also 8255 is very much popular compared to other ICs, and it has 3 ports and every port has 8 bit, and those ports are port A, B and C. So port A and port B can function as 8 bit input or output port, and bits of port C are divided into subgroup 4 bit each. So port C upper and port C lower means here we can see port C are divided into 2 group. One is port C upper and port C lower, and both part contain 4 bit. So, and there are other control pins which are used to specify and control the flow of data and operation of the 8255. I know the most important feature of 8255 is that this is programmable. Programmable means you can do programming in this. This means that the operation of 8255 can be controlled by programming the microprocessor accordingly, and this gives us freedom to use 8255 in number of ways without changing or without having to change the wiring and connection. Only due to only programming we can manage all the operation between 8255, and there is no need to change the connection wire again and again. So this is basically program based interface device, you can say, and it has few different mode of operation, and this is awesome because we get the freedom to choose from which bunch of different functionalities. So later on this lecture we are also going to see what are different mode of operation. So basically there are 2 mode of operation. One is BSR, bit set reset, and one is input output mode. So later on in this lecture I will discuss. So this is pin diagram of 8255. As I mentioned earlier, this is 40 pin IC. So here you can see the IC from 1 to 40, and BCC that is used that is need plus 5 volt supply to function, and ground all the voltage are measured with the respect to this pin. And when you are talking about P0 to P7, so these are 8-bit bidirectional input output pins. So here you can see PA0 to P7. So here you can see P0, 1, 2, 3 and 4, 5, 6, 7. So these are bidirectional pin I use to send data to output from a device and to receive. Basically this is going to send the data as well as going to receive data because this is bidirectional. And next is PB0 to PB7. These are 8-bit bidirectional, and this is going to work same as port A. And we have also PC0 to PC3, because in earlier slide I have discussed port C is divided in 2 parts. One is upper part and one is lower part. So here, and each having 4 bits. So, and this pin also used for communicating with input output device. And we have D0 to D7. Basically these are data bus, and the main responsibility of data bus to carry the data that can be from microprocessor to peripheral device or from the peripheral device to
microprocessor. And CS we have a chip select, and this is active high input port, and the microprocessor uses input to select the chip 8255. In other words, you can say microprocessor uses this pin to say, hey, now I am talking to you, means now I am ready to transmit data. If you are interested, then we can start the process. And read, this is also active high input port used by microprocessor to tell 8255 that I want to read data from one of its ports. Means just I want to read data from one of your ports. When we are talking about writing, means microprocessor is ready to send data to those ports. Now here, this is very important pins, and there are two pins, and they are used to tell microprocessor, or microprocessor is going to tell about using this pin which port is selected to communicate the data. Means here we are talking about port pin A0, A1 and 0, means we are talking about pin number 8 and 9. So both pin are 0, means port is A is selected. If 01, port B is selected, 10, port C is selected, and value of both pin is 11, means control port is selected. So by this pin also we can find out on which port microprocessor is going to communicate data. Reset, this is active high input used to reset 8255. And here you can see the block diagram or internal architecture of 8255. So let me discuss each and every block one by one. So first block is data bus buffer, and this main responsibility of data bus buffer is to carry data and communicate with data bus. So it is bidirectional data bus. This connects every, because we have to transfer or receive data from the every port. That's why it is connected to every port except read and write. Okay, port A, B and C are divided in two groups. So port A, P0, PA7, here you can see, plus port C upper, and port B in the same manner, PB0, here you can see, to PB7 plus port C lower. So there are separate control unit for group A and group B. So here you can see the separate control unit, group A, and this is group B. Okay, and that get their control signal from the main read write logic control. Definitely here from you can see in this diagram, and this end, this they are going to take signal from, and by that signal they are going to respond. Okay, so group A control and group B control blocks are connected to their respective group blocks. Since also here you can see they are connected to their respective block. They control the flow of data and modes of operation as those ports. And control of group A and group B represented by control block group A control. So here you can see the name, and control B, and together they make control port. If you are talking about control ports, means we are discussing about the combination of group A control as well as group B control. This port is used to specify the modes of operation and is manipulated by the microprocessor. Hence these two blocks are connected by the data bus in this diagram also you can see, and these control blocks play a crucial role as they ensure that port can be used in number of ways. So hence 8255 gives a lot of freedom and control to the user, and it's totally depend upon user how they are going to managing the operation of 8255. Now we have two very important topic. One is control port and second is control word. So the fourth port of 8255 is the control port, because we have already discussed it's also depend upon the value of A1 and A0. If both are 0 means control A, and 01 control B, and 10 control C, and 11 for control
port. So there are no pins for this port. This is because the control port is not supposed to use for input or output purposes. This port is used by the microprocessor to give instruction to 855 about the mode which is want to use a specific input output ports. So this is only carrier to carry the signal which is generated by the microprocessor to the ports. And to communicate with this port, the microprocessor needs to make the input A0 at 0. So both will be high, because we have already discussed. Firstly, a microprocessor make both signal high, then we can say yes, control port is selected and control port is going to do work whatever signal generated by microprocessor. When both of these are high, 8255 knows that the microprocessor is telling it about the modes of the input output port that need to be chosen. Okay, so there are two major modes of operation. One is input output mode and second is bit set reset mode. So port A, B and C are used as 8-bit input output port, and BCR mode, the bits of port C can be also used as individual input output bits and can be set and reset individually. So here now we are talking about control word in 8255. So control word is basically 8-bit register, you can say. So here you can see the arrangement D0 to D7, and D7 is going to tell us 1 for input output mode and 0 for BSR mode. So basically we have discussed there are two modes of operation. One is input output mode and second is BCR mode. The value of D7 is going to tell us on which mode you are working or microprocessor is going to work. And also each and every block you can see there is some information given, and by this information we can set the value of control register also, and then we can find. Okay, next later on I am going to discuss a program. So by that program also you can learn how you are going to use control word. Okay, so here there are two modes in 8255 microprocessor. One is bit set reset. So this mode is used to set or reset the bits of port C only, and the selected when the most significant D7 in the control register is 0. Means D7 is 0 means we are working with BSR mode, and if this is 1 means we are working in input output mode. So this mode affect only one bit of port C at a time, because as user set the bit, it remains set unless user changes it. Now talking about input output mode. So if D7 is 1 means that is input output mode, and mode 0 simple or basic input output mode, and second is mode 1 that is handshake input output. So in case of mode 0 simple or basic, port A, B and C can work either as an input function or as output function. In case of mode A, in this either port A or B can work, and port C bits are used to provide handshaking. The outputs as the always input are latched, and it has interrupt handling capability. Before actual data transfer, there is a transmission of signal to match speed of CPU and printer. So this is also an example. When CPU want to send data to slow peripheral device like printer, it will send handshaking signal to printer to tell whether it is ready or not. If printer is ready, then it will set one acknowledgement to CPU, and then transmission will begin. And when you are talking about mode 2, so that is bidirectional input output. In this mode only port A will work, port B can either is in mode 0 or 1, and port C bits are used as handshake signal. So here also by the control register you can see D7 equal to 1 means we are talking about input output mode, and D0 0 means output, 1 means input, and D1 about D1 also you can see This is port B, 0 for input output and 1 for output. So these are going to tell us, and this is also going to help us when you are going to design any control board. So if you want to understand the concept of this figure, definitely you can understand. The most significant bit means we are talking about D7 is 1 for input mode and 0 for BSR mode, and we have already discussed many times. So here D6 and D5, it is used to set the port A mode, means 00 means mode 0, 01 means mode 1, and 1 0 1 1 you can say mode 2. D4 used to tell whether port A is taking input or displaying the output. If it is 1 means it is taking input, otherwise displaying output. D3 also used to tell whether port C upper bits is taking input or displaying result. If it is 1, then it is taking input, otherwise displaying output, because in this figure you can see this is already mentioned, 0 output, 1 is input, and which port or something like that you can see. And D2 is tells the mode of port B, 0 means mode 0, 1 means mode 1, and D1 is going to whether port B is taking input or output. So 0 is for taking input and 1 for output. And now D0 whether still port C lower is taking input or displaying output. So 0 is for output, 1 is for input. So now when you are talking about interfacing of 8085 8255, so in this figure you can see we have 8085, and also we are using NAND gate, and also we are using demultiplexer and 8255. So let me discuss why we are using this. So first of all, we need to supply power to both 8085 and 8255 by connecting VCC and ground. Okay, reset out pin of 8085 is connected to reset pin of 8255, there is no issue, and read and write pins of 8085 are connected to read and write. Okay, and here also you can see pin number 80 to 87 have dual functionality as well in these bits act as for both addresses bus and as well as data bus. So this is achieved by multiplexing. So extract address from here, we need to demultiplex, then we can get only data. After demultiplexing, pin A0 and A1 are connected to pin A0 and A1 of 8255, and these two pins tell whether about which port microprocessor is talking about. And when you are talking about chiplet logic, so for the microprocessor to be able to communicate with 8255, the CS should be low. So we design a logic circuit that takes addresses line 8287. Okay, and this signal design should be such that if the addresses allotted to any of the port appears on 80 and 80, output should be go low. So let's allot the address of port A and B, C up to 8255. So the port address of A is 20, port B is 21, port C is 22, and the control port is 23. So please try to remember this port address, because when you are going to write program in case of interfacing of 8255, then definitely we are going to use port address, because on this port address your microprocessor, your peripheral device is going to communicate. So here just take a simple example. Suppose we are required to take input from port A and port B and output at port C, means we have to take input from port A and port B and we have to show output at port C. Then how you can do? So first step that firstly you have to specify the control word register and send it to the control port, and the control port word 825. Okay, and also in this picture you can see
ports will be working in input output mode. So here value of D7 will be 1, and this is simple input output operation. So we need all the 3 port A and B, C to work in mode 0. So D6 and D5 equal to D2 means 0. I think till now there is no any issue, you can easily understand. Now port A and B are in input mode and port C is in output mode. Therefore D4 equal to D1 and D3 equal to D0 equal to 0. Now when you are talking about next step, so after getting all the value of D7, D6, D5, D2, D4 and D3, D0, we can define a control register. So after getting all the value, what we find, that is 92. Okay. So second is read input from port A. Okay, so here you can see MVI 92, this is controllable register that is loaded in accumulator, and we have to show output, means we are working with control port. So here you can, we as you know, the address of control port is 23, and we have to take input from port A. So address of port A is 20, and we just move the content of accumulator in C. And second, when we are going to access port B, means that is in 21. Here we are talking or accessing data from the port B. At C means A plus. At C means here we are going to add 2 values. And here you can show output because the port address of C is 22. So here you can see the output. So this is a very simple program. If you want to interface 8255 with 8085 microprocessor, by using this you can do. Firstly, you have to initialize the control port register. So here you can see, and you have to indicate control port. So you have to write out 23 because 23 is the address of control port, and in 2020 is basically telling the port A address, and we have shifted the content of A into C. Okay, and here in increment 21 means here we are getting data from B. Okay, and after this we are going to add C, means we are going to finally add A and C. So here basically this data is stored in a accumulator. Okay, and here 21 is the address of port B. A plus C, A means there is a content of B, and C, this is going to represent port A. So here we can get output. Means just try to understand, let me explain it clear manner. Firstly, I think there is no issue and there is no issue. For what happened after this, the content which is available at this memory location, and basically this is indicating port way, that will be stored in accumulator. Okay, and the content of accumulator here is stored in C. Okay, there no problem. Now here we are reading the data from the port B, and that is also stored in accumulator. And add C means A plus C. So A having the data of port B and C having data of port A. So this is by default A plus B, and here you can store output. So this is process of interfacing 8085 with
So, in this lecture I will cover introduction of 8255 IC, some feature of 8255, pin diagram of 8255, block diagram of 8255 and control port and control word. These are very important topic which I am going to cover in this lecture, and also I will cover how 8085 microprocessor is going to interface with 8255. So, here as we know, microprocessor and microcontroller are primarily used to process the data from the CPU to external device, or you can say peripheral device. And if when we are talking about some application of microprocessor and microcontroller, so they are countless. If we are going to talk in terms of interacting microprocessor and microcontroller to outside world. Outside world means here we are talking about when you are going to connect your microprocessor, your microcontroller to peripheral device. So, there are countless application, and this is done by inserting input output device between the microprocessor and peripheral device. And it is also impossible to take a name or a real life application which is used in communication without using input output device, because when we are talking about communication or transferring data from the CPU to peripheral device, definitely we are going to use input output device, and because they play very vital role in communicating data from the microprocessor to peripheral device. And as you know also that, so microprocessor has a finite number of pins that is used to interface with the peripheral or external devices. But can you imagine, have you imagined in any time, suppose in case of you have having more input output device than pin, then what will happen? In that scenario, your 8255 IC is going to work, means that comes into picture. Suppose your microprocessor has only 8 pins, but you have 10 peripheral devices to communicate with microprocessor. In that case, programmer peripheral interface going to play big role, and that is why we need 8255 IC. So, we can easily communicate more devices compared to pins. So, 8255 is a programmable chip used for interfacing peripheral device. It's connect with processor or a controller and increase the number of input output pins that can be used in the system. And it has 3 8-bit ports to connect input output device. That means we have 24 pins for interfacing input output device that are divided into 3 ports. So, in this lecture we are also going to discuss about control port and control over register. So, we can know what is the name of those port and how they are going to work within 8255 IC, and also with communication of 8255. So, here there are some feature of 8255. One is this is 40 pin IC, and which works on power supply of 5 volt, and it is compatible with wide range of microprocessor and microcontroller application. That is why it is also 8255 is very much popular compared to other ICs, and it has 3 ports, and every port has 8 bit, and those ports are port A, B and C. So, port A and port B can function as 8 bit input or output port, and bits of port C are divided into subgroup 4 bit each. So, port C upper and port C lower means here we can see port C are divided into 2 group. One is port C upper and port C lower, and both part contain 4 bit. So, and there are other control pins which are used to specify and control the flow of data and operation of the 8255. I know the most important feature of 8255 is that this is programmable. Programmable means you can do programming in this. This means that the operation of 8255 can be controlled by programming the microprocessor accordingly, and this gives us freedom to use 8255 in number of ways without changing or without having to change the wiring and connection. Only due to only programming we can manage all the operation between 8255, and there is no need to change the connection wire again and again. So, this is basically program based interface device, you can say, and it has few different mode of operation, and this is awesome because we get the freedom to choose from which bunch of different functionality. So, later on this lecture we are also going to see what are different mode of operation. So, basically there are two mode of operation, one is BSR, bit set reset, and one is input output mode. So, later on in this lecture I will discuss. So, this is pin diagram of 8255 as I mentioned earlier. This is 40 pin IC. So, here you can see the IC from 1 to 40, and BCC that is used that is need plus 5 volt supply to function, and ground all the voltage are measured with the respect to this pin. And when you are talking about P0 to P7, so these are 8-bit bidirectional input output pins. So, here you can see PA0 to P7. So, here you can see P0, 1, 2, 3 and 4, 5, 6, 7. So, these are bidirectional pin I used to send data to output from a device and to receive. Basically, this is going to send the data as well as going to receive data, because this is bidirectional. And next is PB0 to PB7, these are 8-bit bidirectional, and this is going to work same as port A. And we have also PC0 to PC3, because in earlier slide I have discussed port C is divided in two part, one is upper part and one is lower part. So, here and each having 4 bits. So, and this pin also used for communicating with input output device. And we have D0 to D7, basically these are data bus, and the main responsibility of data bus to carry the data that can be from microprocessor to peripheral device or from the peripheral device to microprocessor. And CS we have a chip select, and this is active high input port, and the microprocessor uses input to select the chip 8255. In other word, you can say microprocessor uses this pin to say, hey, now I am talking to you, means now I am ready to transmit data. If you are interested, then we can start the process. And read, this is also active high input port used by microprocessor to tell 8255 that I want to read data from one of its ports. Means just I want to read data from one of your ports. When we are talking about writing, means microprocessor is ready to send data to those ports. Now, here this is very important pins, and there are 2 pins, and they are used to tell microprocessor, or microprocessor is going to tell about using this pin which port is selected to communicate the data. Means here we are talking about port pin A0, A1 and 0, means we are talking about pin number 8 and 9. So, both pin are 0, means port is A is selected. If 01 port B is selected, 10 port C is selected, and value of both pin is 11, means control port is selected. So, by this pin also we can find out on which port microprocessor is going to communicate data. Reset, this is active high input used to reset 8255, and here you can see the block diagram or internal architecture of 8255. So, let me discuss each and every block one by one. So, first block is data bus buffer, and this main responsibility of data bus buffer is to carry data and communicate with data bus. So, it is bidirectional data bus, This connects every, because we have to transfer or receive data from the every port. That's why it is connected to every port except read and write. Okay. Port A, B and C are divided into group. So, port A P00, PA7, here you can see, plus port C upper, and port B in the same manner, PB0, here you can see, to PB7 plus port C lower. So, there are separate control unit for group A and group B. So, here you can see the separate control unit, group A, and this is group B. Okay. And that get their control signal from the main read write logic control. Definitely here from you can see in this diagram, and this end, this they are going to take signal from, and by that signal they are going to respond. Okay. So, group A control and group B control blocks are connected to their respective group blocks. So, also here you can see they are connected to their respective block. They control the flow of data and modes of operation as those ports, and control of group A and group B represented by control block group A control. So, here you can see the name and control B, and together they make control port. If you are talking about control ports, means we are discussing about the combination of group A control as well as group B control. This port is used to specify the modes of operation and is manipulated by the microprocessor. Hence, these two blocks are connected by the data bus in this diagram also you can see, and these control blocks play a crucial role as they ensure that port can be used in number of ways. So, hence 8255 gives a lot of freedom and control to the user, and is totally depend upon user how they are going to managing the operation of 8255. Now, we have two very important topic, one is control port and second is control word. So, the fourth port of 8255 is the control port, because we have already discussed is also depend upon the value of A1 and A0. If both are 0 means control A, and 01 control B, and 10 control C, and 11 for control port. So, there are no pins for this port. This is because the control port is not supposed to use for input or output purposes. This port is used by the microprocessor to give instruction to 855 about the mode which is want to use a specific input output ports. So, this is only carrier to carry the signal which is generated by the microprocessor to the ports. And to communicate with this port, the microprocessor needs to make the input A0 at 0. So, both will be high, because we have already discussed. Firstly, microprocessor make both signal high, then we can say yes, control port is selected and control port is going to do work whatever signal generated by microprocessor. When both of these are high, 8255 knows that the microprocessor is telling it about the modes of the input output port that need to be chosen. Okay, so there are two major modes of operation. One is input output mode and second is bit set reset mode. So, port A, B and C are used as 8-bit input output port, and BCR mode, the bits of port C can be also used as individual input output bits and can be set and reset individually. So, here now we are talking about control word in 8255. So, control word is basically 8-bit register you can say. So, here you can see the arrangement D0 to D7, and D7 is going to tell us 1 for input output mode and 0 for BSR mode. So, basically we have discussed there are two modes of operation, one is input output mode and second is BCR mode. So, value of D7 is going to tell us on which mode you are working or microprocessor is going to work. And also each and every block you can see there is some information given, and by this information we can set the value of control register also, and then we can find. Okay, next later on I am going to discuss a program. So by that program also you can learn how you are going to use control word. Okay, so here there are two modes in 8255 microprocessor. One is bit set reset. So this mode is used to set or reset the bits of port C only, and the selected when the most significant D7 in the control register is 0. Means D7 is 0 means we are working with BSR mode, and if this is 1 means we are working in input output mode. So this mode affect only one bit of port C at a time, because as user set the bit, it remains set until unless user changes it. Now talking about input output mode. So if D7 is 1 means that is input output mode, and mode 0 simple or basic input output mode, and second is mode 1, that is handshake input output. So in case of mode 0 simple or basic, port A, B and C can work either as a input function or as output function. In case of mode A, in this either port A or B can work, and port C bits are used to provide handshaking. The outputs as the always input are latched, and it has interrupt handling capability. Before actual data transfer, there is a transmission of signal to match speed of CPU and printer. So this is also an example. When CPU want to send data to slow peripheral device like printer, it will send handshaking signal to printer to tell whether it is ready or not. If printer is ready, then it will set one acknowledgement to CPU, and then transmission will begin. And when you are talking about mode 2, so that is bidirectional input output. In this mode only port A will work, port B can either is in mode 0 or 1, and port C bits are used as handshake signal. So here also by the control register you can see D7 equal to 1 means we are talking about input output mode, and D0 0 means output, 1 means input, and D1 about D1 also you can see this is port B, 0 for input output input, and 1 for output. So these are going to tell us, and this is also going to help us when you are going to design any control board. So if you want to understand the concept of this figure, definitely you can understand. The most significant bit means you are talking about D7 is 1 for input mode and 0 for BSR mode, and we have already discussed many times. So here D6 and D5 it is used to set the port A mode, means 0 0 means mode 0, 0 1 means mode 1, and 1 0 1 1 you can say mode 2. D4 used to tell whether port A is taking input or displaying the output. If it is 1 means it is taking input, otherwise displaying output. D3 also used to tell whether port C upper bits is taking input or displaying result. If it is 1, then it is taking input, otherwise displaying output, because in this figure you can see this is already mentioned 0 output, 1 is input, and which port or something like that you can see. And D2 is tells the mode of port B, 0 means mode 0, 1 means mode 1, and D1 is going to whether port B is taking input or output. So 0 is for taking input and 1 for output. And now D0 whether still port C lower is taking input or displaying output. So 0 is for output, 1 is for input. So now when you are talking about interfacing of 8085 8255, so in this figure you can see we have 8085, and also we are using NAND gate, and also we are using demultiplexer and 255. So let me discuss why we are using this. So first of all, we need to supply power to both 8085 and 8255 by connecting VCC and ground. Okay, reset out pin of 8085 is connected to reset pin of 8255, there is no issue, and read and write pins of 8085 are connected to read and write. Okay, and here also you can see pin number 80 to 87 have dual functionality as well in these bits act as for both addresses bus and as well as data bus. So this is achieved by multiplexing. So extract address from here, we need to demultiplex, then we can get only data. After demultiplexing, pin A0 and A1 are connected to pin A0 and A1 of 8255, and these two pins tell whether about which port microprocessor is talking about. And when you are talking about chip select logic, so for the microprocessor to be able to communicate with 8255, the CS should be low. So we design a logic circuit that takes addresses line 8287. Okay, and this signal design should be such that if the addresses allotted to any of the port appears on 80 and 80, output should be go low. So let's allot the address of port A and B, C up to 8255. So the port address of A is 20, port B is 21, port C is 22, and control port is 23. So please try to remember this port address, because when you are going to write program in case of interfacing of 8255, then definitely we are going to use port address, because on this port address your microprocessor, your peripheral device is going to communicate. So here just take a simple example. Suppose we are required to take input from port A and port B and output at port C, means we have to take input from port A and port B and we have to show output at port C. Then how you can do? So first step that firstly you have to specify the control word register and send it to the control port, and the control port word 825. Okay, and also in this picture you can see ports will be working in input output mode. So here value of D7 will be 1, and this is simple input output operation. So we need all the 3 port A and B, C to work in mode 0. So D6 and D5 equal to D2 means 0. I think till now there is no any issue, you can easily understand. Now port A and B are in input mode and port C is in output mode. Therefore D4 equal to D1 and D3 equal to D0 equal to 0. Now when you are talking about next step, so after getting all the value of D7, D6, D5, D2, D4 and D3, D0, we can define a control register. So after getting all the value, what we find, that is 92. Okay. So second is read input from port A. Okay, so here you can see MVI and 92, this is control over register that is loaded in accumulator, and we have to show output, means we are working with control port. So here you can we, as you know, the address of control port is 23 and we have to take input from port A. So address of port A is 20 and we just move the content of accumulator in C. And second, when you are going to SS port B, means that is in 21. Here we are talking or accessing data from the port B. At C means A plus, at C means here we are going to add 2 values. And here you can show output because the port address of C is 22. So here you can see the output. So this is a very simple program. If you want to interface 8255 with 8085 microprocessor, by using this you can do. Firstly, you have to initialize the control word register. So here you can see, and you have to indicate control port. So you have to write out 23 because 23 is the address of control port, and in 2020 is basically telling the port A address, and we have shifted the content of A into C. Okay, and here increment 21 means here we are getting data from B. Okay, and after this we are going to add C, means we are going to finally add A and C. So here basically this data is stored in a accumulator. Okay, and here 21 is the address of port B. A plus C, A means there is a content of B, and C, this is going to represent port A. So here we can get output. Means just try to understand. Let me explain it clear manner. Firstly, I think there is no issue and there is no issue. For what happened after this, the content which is available at this memory location, and basically this is indicating port way, that will be stored in accumulator. Okay, and the content of accumulator here is stored in C. Okay, there no problem. Now here we are reading the data from the port B, and that is also stored in accumulator, and add C means A plus C. So A having the data of port B and C having data of port A. So this is by default A plus B, and here you can store output. So this is process of interfacing 8085 with 82.